Good evening to all. Is everything clear, audio and video? जल्दी बताना guys. Yeah. Good evening Shivam. Good evening Chanchal. Good evening Tanush. Nikki. Good evening. Shifuk. Good evening. All clear? Good. Good evening Satyam. Good evening. Yeah. आज की डिस्कशन ऑन क्या सब्जेक्ट है? आज की डिस्कशन ऑन थियरी ऑफ कंप्यूटेशन, राइट? गुड इवनिंग सत्या. अवनिश गुड इवनिंग. काजल, अनुषा गुड इवनिंग. हितिक गुड इवनिंग. यार अगर कोई मिस किया तो प्लीज़ शेयर द लिंक विद योर फ्रेंड्स. तनुज, आपको टीवीसी फेवरेट बन गया बट डोंट नो हाउ. ओ ग्रेट. पढ़ लिया होगा बहुत. साक्षी गुड इवनिंग. प्रियंका, मिनिमम टारगेट है 100, तो आज टारगेट होगा 5 से 6 घंटे टारगेट है, बट देखते कितने बजे तक होगा. तो शुरू होगा तो रुकेंगे नहीं हम. लैगिंग हो रहा है क्या? शिफू प्लीज रिफ्रेश. गुड मॉर्निंग राजा. मोहित, यस. एनी टिप्स फॉर गेट 2024? यू हैव द टाइम, राइट? I will check if there is anything issue with the lagging. I will check. प्लीज रिमाइंड करते रहो अगर कुछ वीडियो में दिक्कत है बफरिंग में. या निशो गुड मॉर्निंग. गुड मॉर्निंग. ओ माय गॉड. गुड इवनिंग. नो लैग. ओके, कभी कभी होता होगा, बता देना. हैप्पी न्यू ईयर राजा. या so tell me guys how you are preparing for the gate 2023, and those people are preparing for gate 2024. You know how this is a good practice for you, right? Yeah, it's fine. Those people who are preparing for both 2023 and 2024 and later also you can attend, not an issue. अच्छा, okay. So आज की सेशन है राइट. आज के सेशन में हम ऑलमोस्ट 100 क्वेश्चंस करने वाला है. तो जिसको अच्छा प्रैक्टिस करना है प्लीज़ ट्राई टू अटेंड. विल गो एज पर द फ्रीक्वेंसी, राइट? एवरी क्वेश्चन वी विल डिस्कस इन डिटेल. ऐसा नहीं है यार क्वेश्चन छोड़ के जाएंगे. कभी कभी थोड़ा लेंथी बन रहा है तो होमवर्क कर लेते, बट मैक्सिमम क्वेश्चंस को हम यहाँ पर कोशिश करेंगे इन डिटेल्ड एक्सप्लेनेशन. साथी है गुड. यार जिसी को है ना गाइडेंस चाहिए यार, आप पूछ लेना क्वेश्चंस बीच बीच में, हम डिस्कस करेंगे, राइट? आप है ना 2023 के लिए तैयार कर रहे हैं. अभी टाइम कितना है? यू हैव वेरी लेस टाइम, राइट? इस जो नेक्स्ट फ्यू डेज है, राइट, 20 डेज लगभग, राइट? इस 20 डेज के लिए आपको है ना बहुत कम टाइम है. तो इस कम टाइम में आपको रिस्ट्रिक्टेड मतलब प्रैक्टिस के लिए बहुत ज़्यादा यूज़ करना है. हमारा इंटेंशन यही है जितने भी क्लासेस ला रहे हैं हम मैक्सिमम फोकस ऑन प्रैक्टिसिंग. बट अभी पढ़ाएंगे तो यार टाइम नहीं है उसको रिवाइज करने के लिए, यार याद रखने के लिए. बट प्रैक्टिसिंग में ही हो जाता. अगर आपको ये सब्जेक्ट कॉन्फिडेंट से मतलब कुछ एक बार प्रिपेयर कर लिया होगा तो ये प्रैक्टिस से आपको फुल रिविजन हो जाएगा. जो भी डाउट से आप राउंड ऑफ कर लेना और उसको ज़्यादा प्रैक्टिस कर लेना, ठीक है? फुल मार्क्स हर सब्जेक्ट में नहीं होता सैन, बट जो सब्जेक्ट्स आपका फुल कॉन्फिडेंट है तो you can do it. हो सकता है depends on how they make the questions in the exam, right? Yes, let's begin. Begin the today's session. Yeah, मेरा नाम है मल्लेशम देवसन है. You can call me as Deva sir. So today we are going to start the PYQ discussion राइट तो क्या क्या टॉपिक्स कवर होंगे यार, पूरा सब्जेक्ट तो आपको मालूम है, राइट, पूरा सब्जेक्ट तो मालूम है, यू नो द फुल, राइट, सो यू कैन एक्सपेक्ट दिस 2 टॉपिक्स, 2 to 4 मार्क्स, राइट। एंड कॉन्टेक्स्ट फ्री ग्रामर यहाँ पर आपको 2 मार्क्स एवरेज, ये अप्रोक्सीमेट है, एग्जैक्टली मुझे भी मालूम है यार, गेट का जो मेकर है वो डिसाइड करेगा। ट्यूरिंग मशीन अनडिसेबिलिटी 2 to 4 मार्क्स, यहाँ थोड़ा वेटेज कम ज़्यादा रहेगा। सो जो फर्स्ट 2 टॉपिक्स एंड लास्ट 2 टॉपिक्स मोस्टली द वेटेज इज मोर, सो यू स्पेंड मोर टाइम हियर एंड यू स्पेंड लेस टाइम हियर, सो दैट मेक्स द डिफरेंस हियर। सो equally you spend kar lena, so you prepare much time for this, right, half of the time, so remaining half of the time mostly the 40% of the time you should be here, right, so you spend the time more here, 40 to 50% and 20 to 30%, and here you spend more time 40%, so that you can secure more weightage is around 7 to 10 marks. Total weightage for the GATE exam is 7 to 10 marks. And do you require any textbook for this? Really not required if you are attending the classes in PW, but if you are not confident about all these topics, definitely you require one textbook like Peter Lynch or Xavier Martin. There are many good books for undergraduate level, so आप उसको prepare कर सकते हैं, right? Yes, 9 marks, तो मैं ये हमेशा ये रेंज लेके चलता हूँ, बट वर्स्ट केस में क्या होगा, बेस्ट केस में क्या होगा, बस ये दोनों है, बट हो सकता है 8-9 इज द मोस्ट एक्सपेक्टेड द मार्क्स फॉर द गेट। बफर हो रहा है शिवम? यस, मुझे भी दिख रहा है कभी कभी बफर हो रहा है, बट चलो देखते। द फर्स्ट टॉपिक फॉर द थियरी ऑफ कंपटीशन, राइट? So those people who did not like, yes, guys, 42 are watching, the likes I can see the 10, right? So make it, because today we are going to spend much time on the practice, right? As I promised in the morning, I promised in the beginning, now we are into the action, right? So please like the session and also share with your friends. चलो शुरू करें। The first topic, which is regular expression, राइट, हम कहीं पर भी शॉर्टकट्स भी होगा, रिवीजन भी करना है, तो वी विल डू इट टुडे, राइट? एनीथिंग यू वांट टू डू रिवीजन, यस वी विल डू इट। द फर्स्ट क्वेश्चन, द क्वेश्चन इज, you have the W and that W contains the strings from zeros and ones, even number of ones। देखो इससे पहले यार गेट एग्जाम है, राइट, यू हैव ऑड नंबर ऑफ वंस आल्सो, सो इट्स अ मोस्ट एक्सपेक्टेड क्वेश्चन और सिमिलर काइंड ऑफ क्वेश्चंस इन द एग्जाम, लाइक यू हैव इवन नंबर ऑफ वंस, इवन नंबर ऑफ वंस, और कभी कभी ऑड नंबर ऑफ वंस। एग्जाम में both the questions are important, right? Even number of ones, how do you write an expression? Or number of ones, how do you write an expression? Tell me what is the right answer for this? And do you know any other? Yes, कुछ लोग बोल रहा है C, कुछ लोग बोल रहा है D. Which one is the right answer? And now in this session especially, I am promising you that not only the question, we will practice the questions which are related to this question. What are the possible expected gate questions for each model one? Right, I am saying here the question is about even number of ones, but you should also practice even number of odd number of ones. Not only this, you should practice even number of zeros. What is an expression? You should also practice odd number of zeros, right? There are 4 expressions we are going to write here. हम यहाँ पर चारों expressions लिखने वाला है, but easy expressions. एग्जाम में ऐसे नहीं इनफाइनाइट आंसर से हर क्वेश्चन के लिए, राइट? तो यहां पर हम 4 क्वेश्चंस करेंगे, 1 2 3 4, बट इस क्वेश्चन ये इवन नंबर ऑफ वंस इसके लिए, तो यहां पर पहले आइडेंटिफाई करेंगे, उसके बाद हम इजी क्वेश्चन वहां लिखेंगे, इजी ऑप्शन वहां लिखेंगे, राइट? वाई द ऑप्शन ए गलत है, क्यों? रेगुलर एक्सप्रेशन में यही होता, एलिमिनेशन बेस्ट टेक्निक है। वाई दिस इज राइट और रॉन्ग? तो पहले देख लेते इवन नंबर ऑफ वंस मतलब क्या होता, इवन नंबर ऑफ वंस मतलब क्या क्या स्ट्रिंग्स होगा, यहां लिख लेते। एप्सिलॉन कुछ मेंशन किया नहीं किया, राइट? एप्सिलॉन 0 नंबर ऑफ वंस, और क्या? सिंगल जीरो, उसमें वन नहीं है, मतलब जीरो नंबर ऑफ वंस। डबल जीरो वैलिड स्ट्रिंग है, क्यों, इसमें भी जीरो वंस है। और क्या होगा, डबल वन, इसमें इवन नंबर ऑफ वंस है। और क्या है, टू लेंथ में तो इतना ही है, और थ्री लेंथ में ट्रिपल जीरो वैलिड है, क्यों, उसमें जीरो नंबर ऑफ वंस है। और कितने हैं, जीरो 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 डबल वन, इसमें इवन नंबर ऑफ वंस है, वन जीरो वन, वन डबल वन जीरो। और कुछ है ऑप्शन आपके पास, ये है तीन लेंथ की स्ट्रिंग्स है। वैसे ही आपको आपके पास इनफिनाइट स्ट्रिंग्स है। बट मैं ये बता रहा हूं, क्वेश्चन को पहले समझ लेना। कुछ लोग पहली बार प्रैक्टिस कर रहा है ना, वो आर प्रैक्टिसिंग द फर्स्ट टाइम, दे शुड अंडरस्टैंड द प्रॉब्लम नॉट द आंसर, राइट। आंसर तो वैसे ही आ जाएगा, बट क्वेश्चन में ही सारे आंसर्स, सारे ऑप्शंस है, और इसी से आपको ऑप्शंस डिलीट होगा, राइट। अब देखो इसमें क्या दिक्कत है, इसमें क्या स्ट्रिंग जनरेट नहीं हो रहा है, चेक कर लेना। एप्सिलॉन जनरेट हो रहा है, जीरो जीरो, इससे क्यों जीरो जनरेट नहीं हो रहा है, देखो जीरो में एटलीस्ट नो दिस टू वंस होगा अंदर गया तो, राइट। एवरी टाइम यू गो इनसाइड एटलीस्ट टू वंस कम्स आउट, बट सिंगल जीरो यू विल नेवर गेट इट, दैट्स व्हाई दिस ऑप्शन ये डिलीटेड है। एप्सिलॉन तो हो रहा था बट सिंगल जीरो नहीं हो रहा है, राइट। Everybody, you are able to understand why I am eliminating the option, because this language will contain all the strings. In case if you are not able to generate any string, you delete. In case if you are able to generate anything extra string than this, like single one, इसमें नहीं है, अगर जनरेट किया उसको भी हटा दो, क्यों, वो इनवैलिड एक्सप्रेशन है। देखो यहां पर देखो, ये करेक्ट है क्या, जीरो एप्सिलॉन जनरेट हो रहा है, सिंगल जीरो यहां से जनरेट हो रहा है, डबल जीरो इसी से जनरेट हो रहा है, डबल वन अंदर से जनरेट हो रहा है, ट्रिपल जीरो यही से जनरेट हो रहा है, जीरो डबल वन जीरो वन वन जनरेट हो रहा है, और वन जीरो वन वन जीरो वन जनरेट हो रहा है, वन वन जीरो, मतलब सब जनरेट हो रहा है। और यहां मैं जो एक्सप्रेशन लिखूंगा ना, इसी से ये बन जाता, राइट। यू कैन मेक इट दैट एक्सप्रेशन फ्रॉम हियर। इवन नंबर ऑफ वंस, देखो ये कैसे लिखना है, डबल वन होल स्टार, और यहां भी जीरोस आएगा, यहां भी जीरोस आएगा, यहां भी जीरोस आएगा। जो आउटसाइड आएगा यहां भी रख सकते, यहां भी रख सकते, आपकी चॉइस है, यहां भी जीरो स्टार, यहां भी जीरो स्टार। बट ये सारे जीरो स्टार जरूरत नहीं है, कुछ जीरो स्टार्स को आप हटा सकते। इसमें क्या हुआ, इसमें ऑप्शनल से ये हटाया हम, क्या हटाया, देखो ये वन ये हटाया, और क्या हटाया, ये हटाया, ये जरूरत नहीं है, क्यों, ये जो जीरो स्टार है ना, यहां से भी प्रूव कर सकते और यहां से भी प्रूव कर सकते, और यहां पे जो जीरो, यहां पे जीरो स्टार है ना, ये यहां से भी ले सकते हैं हम, यहां से भी ले सकते हैं। इसकी वजह से ये दोनों जीरो स्टार हम डिलीट किया। बट यू डू नॉट रियली रिक्वायर टू डिलीट, बट दिस इज द बेस्ट ऑप्शन, एंड यू हैव सिमिलर टू दिस you can also write many other answers, like I have deleted outside this zero star, right? When I keep this zero star, now this zero star is not needed, so I can delete that zero star, right? I'm keeping this zero star, outside zero star I have deleted, now outside zero star I have deleted. These are the two options you can get from here itself, but you write all the zero star first, you decide which zero star is not required, you can make other options. But ऐसा नहीं होता सर यही राइट आंसर है, ये गलत है, ऐसा नहीं बोलना चाहिए, क्यों, ये दोनों इक्वल सेट ऑफ स्ट्रिंग्स जनरेट करेगा, राइट, ये सही है। बट ऑप्शन सी क्यों गलत है, वाइट्स रॉन्ग। आई एम जस्ट लुकिंग एट द ऑप्शंस। बी में जीरो के बाद वन नहीं आ सकता है, ठीक है, जीरो के बाद किसमें, कौन बता रहा है, निशु, जीरो के बाद वन नहीं आ सकते हैं, क्या प्रॉब्लम है, जीरो के बाद वन तो अंदर है ना, you can go inside, you can get it, right? You can go inside, you can get it. Zero after zero, you can get one. Yes, B is right answer. Who is saying it's wrong? Good evening, Prabhakar. Let's go for the option C. यही तो है. See here, I am not coming for discussion to give the option, right option. Right option पूरा दुनिया में, right? Google में search करो, you will get the right answer. बट इसकी एक्सप्लेनेशन कम जगह में दिखेगा, और वो भी वीडियो में बहुत कम लोग ज़्यादा टाइम स्पेंड नहीं करेंगे। बट हम यहाँ पर हर क्वेश्चन के ऊपर, हो सकता सुबह तक क्लास चलेगा, मुझे गारंटी नहीं है, राइट, बट आई एम टारगेटिंग टू गिव एवरी ऑप्शन विथ सैटिस्फैक्टरी आंसर, बट वो भी 100 क्वेश्चंस की टारगेट है आज। सो जिसको भी टीओसी रिवीजन करना है, प्लीज स्पेंड द टाइम टुडे, बिकॉज दैट्स आवर टारगेट टू मेक ए रिवीजन एटलीस्ट बाय एंड ऑफ द टुडे और बाय टुमारो मॉर्निंग। ओके, why this is the wrong option? तो if anybody want to generate, see epsilon तो जनरेट हो रहा है, डबल जीरो जीरो डबल जीरो जनरेट हो रहा है, डबल वन भी जनरेट हो रहा है, और 000 जनरेट हो रहा है, 011 वो भी जनरेट हो रहा है, 101 ये भी जनरेट हो रहा है, 110 ये भी जनरेट हो रहा है। तो क्यों गलत है? इसमें क्या दिक्कत है? इसमें दिक्कत है, सपोज यहां पर मुझे 11011 जनरेट करना है, ये तो यहां नहीं लिखा बट ये वैलिड स्ट्रिंग है कि इसके बाद 4 लेंथ 5 लेंथ बहुत सारे है ना, 5 लेंथ में 4 वंस है। प्रॉब्लम ये है ये 1111 जनरेट करने के बाद अगर 0 जनरेट किया बाहर जाओगे तो क्लिनिक क्लोजर के अंदर नहीं रहोगे, तो ये 11 अगर बाहर गया तो यू कैन नॉट जनरेट दिस 11। इफ यू आर इनसाइड 11 के बाद फिर रिपीट आया तो थर्ड 1 तुरंत आएगा, ऐसे 111 तुरंत आएगा। तो हमको क्या चाहिए? 11 के बाद 0 चाहिए, तो वो अंदर से इसमें से पॉसिबल नहीं है, राइट? इसमें से पॉसिबल नहीं, अगर बाहर आया तो फिर वापस फिर रिवर्स में नहीं जा सकते। तो ये 11011 जनरेट नहीं होगा, ये वैलिड स्ट्रिंग है बट ये नहीं करता इसलिए डिलीटेड है। ये सबको समझ में आना चाहिए। ये लोग मैं बहुत लोग को देखा यह सही ही गलत, ये भी सही है बट क्यों सही नहीं है? जो वैलिड स्ट्रिंग्स है वो जनरेट नहीं कर पाया, बट कुछ वैलिड स्ट्रिंग से जनरेट कर पाया, कुछ वैलिड स्ट्रिंग से वो जनरेट नहीं कर पाया, इसलिए डिलीट कर दिया। हमको इक्वलेंट चाहिए, सबसेट नहीं चाहिए। ये तो सबसेट है, ये भी इवन नंबर ऑफ वन जनरेट करता बट सारे जनरेट नहीं करेगा, थोड़ा जनरेट करेगा, थोड़ा नहीं जनरेट करेगा, राइट? ऑप्शन डी ये गलत क्यों है? देखो ये 1 रिस्ट्रिक्टेड है बाहर, मतलब इससे पहले मुझे 0 चाहिए, देखो मुझे ऐसे चाहिए, ये 2 1s रिस्ट्रिक्टेड है, मतलब मुझे सिंगल 0 चाहिए, एप्सिलॉन चाहिए, इससे नहीं हो पाएगा। क्यों? ये 11 हमेशा आएगा, राइट? एप्सिलॉन मुझे चाहिए बट ये नहीं जनरेट कर रहा है, तो इसलिए ऑप्शन डी, राइट? यहां पर कोई दिक्कत है? ओ सत्या, सॉरी, आई एम वेरी सॉरी. I will also explain in English, right? Better to explain English. If anybody needs an explanation in Hindi, please let me know. So right, I will explain both possible explanations. So what I'm trying to say, in these options, right? In these options, you need to think 2 directions. One direction is those strings which are there here should be generated. Those strings which are not here should not be generated, right? Now option A, why we have eliminated? Because we want to generate epsilon generated, but 0 we want to generate, it is not able to. 0 is having even number of ones, but it is not generating. That's why this is not generated. That's why it's deleted. Why we have chosen this? Because this is actually equivalent to our expression. This is actually equivalent to our expression. And see why we have deleted 11011 is a valid string but not generated by this expression, but we want equivalent expression. Whoever generates even number of ones, that we will select, right? But just not even number of ones, we want all even number of ones. By default, even number of ones means we are going to choose every W in the world who is having even number of ones. Okay, the option D, why we have deleted? Epsilon is not able to generate. How can I believe it is generating all the even number of ones, right? All right, right, first question is clear. Now we need to write the answers for this 4, right? These 4 possible gate questions. Now in future, if anybody asks the answer for even number of zeros, then how do you answer it? Now just switch 1 and 0. Here ones you kept, right? Here 0 you keep. Okay, so I'm deleting this portion, just don't worry. Okay, you need 2 zeros, you need 2 zeros because even number of zeros. Now we need to have a ones. One may come here, one may come here, any number of ones, but all the ones, all the positions are not compulsory. Some positions you can ignore. So that is for the first option, that is for the first question, even number of zeros. Even number of ones, just what you do is in place of ones you replace with the zeros. Now odd number of zeros, now these 2 are easy questions. Odd number of ones means 3 ones you keep and 2 ones you repeat any number of times. You can repeat these 2 ones or you can repeat these 2 ones. If you don't have zeros, right, this is the right answer, but in the question you will also have zeros. So now you need to put a zeros here, any number of zeros, here any number of zeros. This is a very easy, this is a very easy answer, but this one you can also keep this side. I kept that side, you can also keep this side, that's not an issue. Now odd number of zeros, 0 0 0, these 2 zeros you can repeat any number of times. Even number of zeros followed by 1 0 will be odd zeros. Now ones you can keep here or any position. So once I am filling now 1 star 1 star 1 star, any empty position. That's it. But you know, all the one stars are not compulsory. You can ignore them wherever you understood. Yeah, this is the first question. Okay, that's good. I'm numbering it. Good point. The question 1. Okay, so I'm numbering as you have requested. Question number 1. See how much time we spent for the question 1. Right? Are you able to understand? We are going to not just answering here. We are also, exploring the possible gate questions from this kind of, right? Anybody want to practice the gate questions, right? Don't answer the gate question. Understand what kind of question it is. Understand what are the possible questions in future if they ask from the same model, and how many possible answers for this question. So you need to, think in 3 directions, right? Everyone, are you able to? But even though you are able to write the answer, these answers might not be there in the options. So for this question, for this answer, you have multiple equivalent answers. So that is your target, how I can write the multiple answers for the same option, right? Everyone, if anybody want for even number of ones, this is a question, right? So I'm just helping you. Even number of ones, how many right answers are there? Over sigma is equal 0, 1. You tell me the first answer just now we have seen, right? That is double 1 whole star. Now all the positions I can keep. This is a one answer, right? 0 star, 0 star, 0 star and 0 star. Your focus is on the even number of ones. See, this is the compulsory one, right? This is the compulsory one. Now if you have any ones, definitely even number of ones. If you don't have a ones, that's fine. 0 number of ones is also even. Now how many equivalent answers we can write? I told you, right? You can delete this when you keep this, and out of this 2, when you are deleting this, don't delete this ever. You can delete this one. So one answer comes out as 1 0 star 1 0 star. That's it. Don't delete this 2 0 stars, never, because one of them is must. Now I'll delete this one now. I'll delete this one, but I will keep this one. So I'm going to delete this one, and when I delete this, this is must and this is must. So I can delete this one. So what is going to happen? 0 star 1 0 star 1 whole star 0 star. This is the one other answer. Now we have one more option. The same one you can also write another way. When you don't want to keep this 2 0 stars, still it is fine, but you need a 0 star outside. So any number of zeros you want to generate, only zeros you can't generate if you don't have these 2 0 stars. So you can keep outside. Now if you have at least one, you can go inside, you can generate even number of ones. If you don't have the ones, you can come here, you can generate. So this is also another right option. These 4 are the famous options. These 4 are famous options for the even number of ones. In the exam, they could ask any possible answer from here. But still I can write more answers, but not required. If you are able to understand this 4, anything will be given in the exam, you can easily select it. Fine? Everybody? Need more discussion, guys. If you are not discussing much, then I cannot spend more time. My classes always depends on the students. If the students interaction is more, I will teach more. That's what proportionally happens. It's not the recorded video, right? It is a live class. Okay, let's go to the second question. Please read the question. Let P be a regular language and Q is a CFL. Okay. P is what? Regular language. And Q is a context-free language. Okay. Q is a subset of P. Oh, it's also given that this Q is a subset of P. That's fine. For example, let P be the language represented by the regular expression. This P is given as some other example. P star, Q star. This is one example, right? Regular language you can represent with any regular expression. QB, some language like P power n, Q power n. Yes, definitely CFL, no doubt. And which of the following is always regular? Which of the, this example only, not the always, remember that. Don't choose these options. These are only examples. That you need to focus on only this in general statement. Then which of the following is always regular? Okay, now look at which one is regular. P intersection Q. What is the P here? It means regular intersection context free language. Is it always regular? You think about it, I will tell you. Sigma star minus P. Sigma star minus regular. What it means? Complement of regular language. This complement of regular, you write sigma star minus L. If you remember that, L complement definition is sigma star minus L. When you write regular complement, you will get sigma star minus regular. Correct? Now P minus Q, that is a regular minus context free language. And sigma star minus Q, that is sigma star of obviously regular. Sigma star, it's just Q complement, nothing but CFL complement. Tell me which is guaranteed to be a regular always. Choose an A, C, B. Oh, this many answers should not be there. Let's try. Regular intersection CFL, those people are answering A, right? That means you are only studying the introduction chapter, not the theory of computation. In the introduction chapter, there is a Chomsky hierarchy. It's not about the regular, it's about the class of regulars. If somebody asks class of regulars, not one regular, class of all regulars, intersection, class of CFLs. Class of CFLs, then you will get class of regulars. But they did not say class of regulars here. What did they say? यार यहाँ पर चल रहा है one regular, not the all regular. Set of regulars is different, one regular is different. Class of regulars intersection class of CFLs is class of regulars, but regular intersection CFL no need to be regular. What is the actual answer? Need not be regular. ऐसे क्यों यार? यही पे तो एग्जाम्पल दिया, तो उसको ले लेना. A star B star intersection A power n B power n. What do you get? A power n B power n. Why don't you get regular? Because the regular intersection CFL no need to be regular. Sometimes not regular coming. How can you say regular? Don't look at Chomsky hierarchy. Chomsky hierarchy is not about one regular. It's about set of all regulars in the world, right? This relation is definitely different from this one. You are talking about one regular. You are talking about a class of regulars. Both are different sentences. Okay. That's what I'm. A is the wrong. Never say, here only example. Regular intersection CFL. Regular intersection CFL. Why are you not getting regular if you are saying regular? That is the best counter example I can say. No need to be regular in general, right? So don't choose. Yeah, regular complement. हमेशा क्या होता? Regular तो है. Always it is regular. Regular complement is always regular. That's what we need, right? Option B is so easy. You are already stuck in option A, then you can't go to option B. Option C, you know, regular minus CFL. You can also write regular intersection CFL complement. CFL complement, you know, need not be CFL, but always context sensitive language. So regular intersection CSL is always CSL. Okay, the option C is guaranteed always CSL, but I want whoever gives always regular. So option C we can't choose. We are not leaving with the answer. Remember that we are looking for every option. This might be the future gate question. Who knows that, right? So you need to analyze it. Option D, CFL complement is always what? CSL. So in the future, if they ask which of the following is always context sensitive language, then A, C, D will be going to be the right answer. Q need not be regular, but CFL intersection regular is always CFL. Always CFL. So always CFL means always CSL. If they ask in the future, if it is always CFL, choose only option A. Always CSL, choose A, C, D. Are you able to understand? In future, the same question could be possible to ask in different ways in MCQ and MSQ. Right? Everybody understood? हम जाएंगे जब आपका कॉन्सेप्ट क्लियर है. देखो एक क्वेश्चन को प्रैक्टिस करने के लिए कितने टाइम लगता, राइट हम ऐसे नहीं जाना है यार इस क्वेश्चन के लिए ए आंसर सही है तो इसको टिक करके नहीं जाना है, तो रिमेनिंग के लिए भी समझना है. यू नीड टू अंडरस्टैंड एवरी ऑप्शन, राइट. Good. Let's go to the third question. Question 3 is easy yaar. You can do it. Just I'll give the time. Just do it quickly. This is one of the easy question in the TOC. L is given. L star is asking, right? L star will be what? AB plus AA plus BAA whole star. Right? 3 strings are there. Just you need to make whole star. So this is the expression. Now, which of the following strings are in L star? In means belongs to. So you need to find who are belongs to L star. Is 1, 2, 3 are they belongs to L star? Just find out. Right. So I'll do it. Also you practice parallelly. I'll just write. Okay. AB is there. AA is there. You can repeat, right? BAA is there. AB is there, AA is there. 1, 2, 3, 4, 5. So if I go to L power 5, definitely you will find that. Right? L star means of course you can take any power. So in L power 5, I'll go 5 times. Each time I go, I'll pick one of the option. Of course, you just say L star. That would be fine. You just say L star. So one definitely present inside. Now 2, AA and again AA and BAA, yes, AA, yes. So if I go 4 times, I'll definitely find this string. L power 4 can generate this string. Okay, what about this one? BAA, because I can see that there, BAA. And then I want to choose AAA is not there, AA is there, AA. Next AB. Next you find AA only option, right? Next AA. Oh, this B I am not able to generate alone, remember that. So this is not belongs to L star. So option, this third string we can't. And fourth one, BAA or kya? And then AA and AB. Yes, you can do it. AA, you can do it. So if I go 4 times, I can generate this string. So ye bahut easy question, right? Belongs to L star. So 1, 2, 4, 1, 2, 4. C is the right answer, right? 1, 2, 4. Acha kiya. Right. You have done, almost you have done correctly. So very easy question. You know, these questions you are not able to do, then you have to think about your preparation style. बहुत easy one. यही होता है एग्जाम में. Even this was a gate question, right? That means gate is not always difficult. Some questions are difficult, not whole gate. So let me tell you one principle. The gate exam difficult for those people who don't prepare at all. Difficult only for those who don't dare to prepare. But if you are preparing, the one extra thing should be needed. Why we make difficult? Why we make difficult even though we prepare? Why we make difficult? Of course, difficult is a famous word. Why we make difficult even though we prepare? Of course, not for everybody, right? For some people, prepare and say they are difficult. Because why we make difficult? The first point may be we don't have patience to prepare. We don't have patience to do systematically. This might be the one problem. You test your patience. Now you have decided to come to this practice, and how long you have the patience to practice the questions and to revise. That makes your determination, the patience. And the second, the preparation style. The systematic preparation is needed. Systematic preparation not done. What? Why systematic preparation is not done? ऐसे होता है ना यार, अभी TOC पढ़ लिया 1 घंटा कुछ और कंपाइलर पढ़ लिया 1 घंटा, एप्टीट्यूड पढ़ लिया, तो रैंडमली पढ़ रहा है, तो ये क्या हो रहा है? मतलब you are not consistent to complete the syllabus, then how will you get a confident? So make systematically, do topic by topic, do subject by subject, get a confidence and master each and every concept systematically. So don't go here and there, make it plan well. So well plan is needed. So whenever you prepare for the gate, right, you are already preparing for the gate, you complete the subjects, now you need a systematic way to revise. I hope you are doing it. Just make it continuously and do it happen, right? Yes, when you know the things, and remember, when you know the things, it will become easy, everything easy. Why we are able to teach with a confidence? Only the thing is, we have learned the things, and now we know the things, then it will become easy. When you don't know the things, then you will have a problem. That means you are not able to solve any question. It might be the reason that you are not aware of the concept. You are ignoring the concept. You are ignoring some points. That's why you are making the difficult yourself, right? Nobody made, right? Some people are able to answer. The reason is they are doing, they know the things properly. All right. We'll continuing the same thing, right? How many questions are over? 3? Yes. Let's go to the 4th one. A very easy question again. So can you do it quickly? Just replace it. What is L1? Pi. Of course, please read that question. I am not reading. Consider the language. L1 is pi, L2 is a. Which one of the following represents this language? L1 is the pi, L2 is what? A. You can write A whole star union L1 whole star, that is a pi star. And you know, pi dot anything is what? You know, right? Pi dot, in the expressions you might be studied, it is always pi. Even in the set notation also same, pi. Union pi star. What is the pi star? Is equal pi power 0 plus pi plus or union, you can use anything. Pi power 1 union pi power 2 and so on. But pi power 0 is what? Epsilon. Union, all these are going to be giving pi. So which will give you epsilon. So this you are going to write epsilon. So now pi union epsilon is what? Epsilon. So which one is the right option for you? Option A. That's correct. That's correct. Guys, please like the session in case if you have not yet liked. Good. Nice. Done? No doubt. So in the exam what happens, you might have an issue. Please practice this. You know, pi star, why it is epsilon? Pi power 0, because of this pi star is epsilon. But you ask me anything, pi power 2 is pi only, pi power 100 is pi only. Only the problem is pi power 0 was there inside, right? Due to that it is epsilon, pi power star. Okay, next. The length of the shortest string and which is not in the language. So what do you mean by shortest string? Remember that you need to look at this way. Order is very important. Epsilon, A, B, A, B. There is an order, right? In the world, that's 0 length first, then comes 1 length, then 2 length, and so on. This should be the order. Now you need to find the shortest string who are not generating, who is not generating from this. Now you need to look at from here epsilon generated. Yes or no? How? A power 0, B power 0, this power 0 and A power 0. So epsilon is generated. Epsilon is generated. The first one is generated. And what about A? A is generated or not? A power 1 remaining all power 0. This is also generated. Is that a B generated? Yes. A power 0, B power 1 remaining everything power 0. This is also generated. AA you can generate from here, remaining all put power 0. AB you can generate from here, remaining put power 0. And BA, B here, A here or here. There are many multiple ways to generate the BA. Here also you can generate, or here B and A you can generate. B you can generate from here. And now the question is 3 length. So now look quickly, 3 length strings very quickly. So I'm writing here, and which might take time because this is the best way to do that. Of course, don't write all these things, just you can do with the brain, right? I'm only writing to explain properly. But in the exam, these things are not required. You know all these things, just speak and cross check. AAA can you generate? Yes. How? You can generate from here. AAB you can generate? Yes. A and B. 2 A's here, 1 B here. You can generate. ABA, A, B, A you can generate. A, B, B, A, B, B here you can generate. B, double A, B, double A you can generate. B, A, B, B, A, B, you can't. If you go here, then B you can't get outside, because every time you get a B, there is A. So this is the first string. Then stop here, then say answer is 3, over. They did not ask the question how many 3 length strings are not generated. That is a different question. Here only asked what is the length of the shortest string. 0 length generated, 1 length all, 2 length all. In the 3 length there is an issue. So 3 is the shortest string, that is also BAB. Now check for if you want how many 3 length strings. If they ask in the future how many 3 length strings, there's a future possible gate question. How many 3 length strings not generated, then the question changes. It is also numerical type. Then tell me, these are all generated, this is not generated. Double BA, yes, B, B, A you can generate, and triple B you can generate. So only one, here only one. This is a different model, right? For this, the right answer is what? 3. But directly getting BAB, no. This is time taking question. And you should go systematically, because you directly go 3 length, there might be the possibility 2 length may not be generated. So always go systematically when they ask for the shortest string. Only one 3 length string not generated. Right, correct. Got it? These are the easy questions, right? It's happened in 2014. That's easy question. Let's go to the next one. Question 6. Yeah, take time for 1 minute, then let's do how to do it. Which of the following choices represents the strings in X0? That means they are talking about what is the X0 expression. You know how to solve this question, right? When you want X0, X0 depends on X1, X1 depends on both X1, X2, X2 depends on X1. So now for this, you always go, there is systematic approach. I used to explain in the grammars, right? Always go from bottom to top. So that when you go to X0, the only depends on X1, X1 you get before that, and when you are solving X1, get X2, then answers will be very clear. So first solve X2, and then solve X1, then solve X0. This is always a systematic approach. Anybody? No Arden's lemma, yaar. Don't use Arden's theorem. Who is that? Nishu. No theorem is required. No theorem is required, yaar. Why do you need a theorem? You don't need. Of course, if you are using the theorem, you can use it. But no theorems needed for the exam point of view, because they don't ask any theorems in the exam, okay? X2 is equal. Have you remember the grammar? When you have something like X2 derives 0, X1 or epsilon. The similar kind of expression, this is the grammar. So I'm just writing the grammar to simplify. Okay, X1 is actually 0, X1 or 1, X2. And here X0 derives 1, X1. So if you know the answer for this, that means you know the answer for X0. So now first you are solving X2. What is X2 from here? What is X2 from here? Take as it is. How? 0, X1 plus epsilon. Assume this is X2 answer, because X1 is not yet solved. So keep X1 as it is in the X2. Right? Now keep this, take this X1 and substitute in the X1. So X1, I'm going to take something 0, X1, X2 already solved. So I'm going to write 1, X2 nothing but either 0, X1 or epsilon. So I'm writing 0, X1 or 1 followed by epsilon. So I'm going to put this here and this here. So what do you get here? 1, that's it. Now what is the advantage of this? Because we know the answer for this. If anybody asks like A, something like, let me write here, A capital A, B capital A, or C. What do you write? Basically, this one is A plus B whole star C. Did you remember how did you write an expression? Here small a is 0 and small b is 1, 0 and small c is 1. So you are going to get the answer for x1 from here. What is x1 here? A plus b, that's 0 plus 1, 0. Recursive equation it is, right? 0 plus 1, 0 whole star and c is nothing but a 1. So this x1 you are going to get and put here in x0. What is x0 is going to be? X0 is equal to 1x1. What is the 1x1? 1 followed by 0 plus 1 0 whole star 1. Now you got x0 right. Is there anybody matching directly with this? Just choose it. But if it is ms cube, be careful. Done? So somebody answered already. x0 you got right. What is the x0? 1 starting with 1, ending with 1, in between 0 and 1 0 sequence will happen. See, but anybody matching with this, just cross check. Here 1 is there, but 0 also there always. So delete it. And here 1 0 always there. We don't need a 1 0. We need a 1 and 1 must. 1 0. Because of this we are deleting. But in other ways, this can be asked different way. 1 is there, 1 is there. This is a plus b whole star, right? You know a plus b whole star many ways. How do you write? A plus b whole star, you can also write a star, b star whole star, right? So they may write in the future this 0 whole star. This a star means 0 star, and this 1 0 star. 1 0 star. So this is also right answer. See, they almost tried here, but they kept 0. Because of this we are not choosing it. If the 0 is not there, right, this b is also correct option. If this b is the 0 is not there, b is also correct option. Because of this 0 we are not choosing the b. But if I want to make MSQ in the future, just I will delete this 0, then I'll keep the same options, but you will answer C because you assume it is a PYQ. But it is actually small change in the B, so be careful. Alright, good. Everyone? Nice. This is also again another easy question, but time taking question. As you know, you need to solve this. You should know systematically how to solve this one. Okay. Next one. 7th question. Set of all binary strings having 2 consecutive zeros and 2 consecutive ones. They did not say that. See, there are many questions which are different. 2 consecutive zeros and 2 consecutive ones. Another one having 0011, having 00 and 11, both are different. So look at these 2 different questions. Here the 00 and 11 are present in the string, right? Here 00 and 11. This question is different from this one. Here they did not say 0011. They said it 2 consecutive zeros and 2 consecutive ones. The question is related to this one, not this one. Remember that first. The question is about 2 zeros and 2 ones individually. Do not choose this one ever. Okay, so be careful. It's not having 0011 problem. It is the having 00 and 11. So these two no need to come together. Remember that. I may have something like 1011. So in this option, see, this is a valid string for this question, but this is not a valid string for having 0011. So you need to understand for the question first, what is the problem? The problem is 00 and 11 present in the string, in every string. Okay, so I hope you are you're clear about this question. Okay, now choose the right option. First understand the question. The 00 and 11 can present anywhere, no need to be together. 00 may come first or 11 may come first. Here both strings are valid. Here both strings are valid. 0011 and 1100. It is a valid. It is also valid. These are the 2 minimum strings. If you look at the option A, it looks like, but here they are demanding 0011 and 1100 containing. Did I say that? No, right? What did we say? 00 and 11 can come in any order or any place. So 00, let's say x00, x11, x. The one possible choice, or x11, x00, x. What is x here? 0 plus 1 whole star. So this should be the expression. 00 and 11 can appear anywhere. Either this could be one option or another option. Now you need to choose which one is the right option matching this one. But what is the problem with this? If anybody want a string something like this, 00, then let me try some string, 1011. Can you get this string? 001011. In this, 00 is there, 11 is there, but this cannot. This will only look for 0011 or 1100. So this is impossible to generate from option A, but that is a valid string according to the question. Okay, and next one, that's very complicated options, right? Very complicated options. Can you see So B and C looks similar, but where is the difference? Can you identify that? Can you identify quickly where is the difference in both of them? Here in options it looks very simple. 00 is there, R 11. So this is not R. If it is here R is there, then you can choose this option, obviously, right? But this is not about R, it's about AND. But this question is containing having 00 or 11. This is having 00 or 11. But this question is having 00 and 11. So this cannot be chosen. This and this, what is the difference now? This is starting with 00 and ending with 11, or starting with 11 or ending with 00. This is also eliminated. Of course, option B you should understand not this way. In the exam, this is one of the question where you may waste your time because every option looks like same, almost, right? That is the reason you should be very careful while choosing these options. Okay, I'm not able to see the chart, guys. I don't know what is the issue. Some people choose an D, some people choose an B. B is the right one. But those people who have chosen D, definitely wrong, because this is starting with 00, ending with 11, or starting with 11 or and ending with 00. 00 and 11, here 11, 00, starting with 00, ending with 11, or starting with 11, ending with 00. That is a different question completely. So now option C, why these two are same? You can see here X is there, here 00 is there, X is there, 11, sorry, here. Just wait. 11 is there, or 11 X 00 and then X. I kept X nothing but 0 plus 1 whole star. So this one, is it matching with this one or not? So you can see it is matching. How? This X, this 2X, right? You pull left side, you pull left side, and there is another X. There is another X, you pull right side. This X, you pull right side. So this 2X comes here and this 2X comes here left, and in between you left with 00X 11 or 11X 00. Is exactly matching or not with this? So option B is the right one. This is another question where you may take time. Time taken question, right? Because you cannot predict, right? You know, if you are already practiced, you are aware of this question, immediately you can choose it. But you know, we have practiced in the class like containing 00 or containing 11. This kind of easy questions. Sometimes they may make questions takes 2 or 3 minutes time or 4 or 5 minutes time. But you should aware. But every question will not take this much time, right? So you should balance. You should balance. Okay, let's go for question 8. And also look at every question I have an answer. Every option I have an answer. What is that? This is a problem about the option A. What is this statement? Containing 00 having, the problem is different, having 0011 and, sorry, R, not and, R 1100. Then you will choose this one. The second one you will choose exactly what is our question. Third one you will choose having 00 or 11. Fourth one you will choose when you want to start with 00, starting with 00 and ending with 11, or starting with 11 and ending with 00. So we have two kinds of options here. So this is option D. Everyone clear? So this could be the possible gate question for the future. In the future exam, if they ask having 00 or 11, then choose this one. Don't choose any other one. Okay. Okay. Question number 8. Question number 8. I think we did right. Odd number of ones. Did you remember that? Odd number of ones. 1, 1, 1. So make even number of ones. Look at the options. What are they trying to do? One time they kept left side, one time they kept right side, so one time they kept left side. So you should try both. So one you keep whole star here, other you keep this one, this side. So now you try with the 0 stars. Here you keep a lot of 0 stars. One 0 star, other 0 star, other 0 star, right? You keep all the 0 stars wherever it is possible. And here also you keep all the 0 stars. Then look who is matching here. Who is matching with this one? Right, these are the two possible famous easy options. But do you think these options will come here? Always? No, right? So always we don't match. If it is matching, fine. If it is not matching, you can't look at it, right? Now we'll go to the question option. We'll try to eliminate. That is the best another option. When they are not matching exactly, then don't blindly choose it. Okay? Don't blindly. These two are not there as it is. Then we need to look at each one. First, have you understood the problem? Odd number of ones. What is the right option? Like what are the right strings, valid strings? Odd number of ones. At least 1 1 should be there, odd 1 1, and then 0 1 1 0, both are, all the three are valid. and one single one strings. And is there any option? Two with the 2 length is done, 3 length, 100, 010, 001, and so on, right? These are the valid strings. With single one I have tried this many, with 3 ones you have lot of strings, but I did not write all of them, right? To understand few strings, okay, odd number of ones means either 1 or 3 ones or 5 ones, but any number of zeros can come. So don't count the zeros ever. Now look at this is demanding ending with 1. Is that my string always ending with 1? See that I have ending with 0 also. So this blindly you can delete. Look at the restriction. This is demanding starting with 1. This ends always. I have no such restriction. Here starts always. Is that really string starting with 1? No, right? I can also start with 0. So delete. And what is demanding? Oh, this one compulsory. This one compulsory. See, here 2 ones are there. Oh, again, one more time. This is whole star is there. That's a mistake. So let me write here whole star is here. Okay. This one is compulsory. Must. Now I want to generate, let's say 0, 1. Because 1 I can generate, 0, 1. Can I generate from here? This 1 is here. Can I get a 0 from here? If I go inside, this one definitely comes. So I can't generate a single 0 from here. This 0, 1 is missing here. Here 0, 1 is missing. That's why I'm deleting option C. And option D, oh, this one is must. Can I get the same string from here? Can I get the 0, 1 from here? Here 0. Is it possible? Again 2 ones are there. Here again missing 0, 1. That means the no option is correct. This is the one of the problem with the gate. Sometimes they make the question but they may not have the right option. Then everybody will get the full marks for this question, and nobody, I think, because nobody is told here the no option except Nishu. Not an answer. Okay. And look at that. People assume that some option is right, but why are you doing that? You're not understanding the options at all. You're blindly choosing this one is right, that one is right. Will not work for the gate. You need to analyze it properly. Here there is no option at all. How many of you understood, right? Because you are practicing and you are are assuming some are right, but why is that? Right? There should be an approach when you choose expressions. Always when you look at the expression, look at who is must and take that as a reference and look for the valid strings and invalid. Okay. So in this question, the way you can choose properly who is must here. With that you can eliminate all the options. You may ask, sir, why option D is wrong? Because 0, 1 is the valid string because it has odd number of ones, but this can't generate 0, 1. This can't generate 0, 1. This can't generate 0, 1. That's why we deleted option C and D. But many people answered C and D. That's absolutely wrong here. Okay, should not do that. That is why we are able to not choose the correct options, because we are blindly following assumptions. Okay, we are not looking at the fact of the answer. Fact is that I want every string, not some strings. What is the problem with the option C and D? They are option C is absolutely wrong, but option D looks like it is generating odd number of ones, but it can't generate all. It generates only some. D is almost right, but it can't generate all of them. Whatever D generates odd number of ones, but it can't generate all odd number of ones. It generates only some of odd number of ones. Okay, that's a mistake. Anyhow, question number 8, you understood, right? There is no correct option here. So don't do such mistakes while practicing at least. Question number 9. Okay, another one, divisible by 3. Set of all binary strings divisible by 3. So I believe that in the entire gate history, and the one question I felt really difficult. The reason is, anybody? Because you can't choose it directly without having the knowledge of the construction of the finite automata. So there is somewhat relation between the automata and expressions. Sometimes you need, this question absolutely takes much time in the exam. You ignore the question in the first scan. That is my recommendation. I don't ever ask, even though you know how to answer it. Please never, because this might take 3 to 10 minutes. I don't know how you practice it. If you are spending 10 minutes for a question, means all gate somewhat affecting. So whenever the question might take much time, you are not clear because you never have seen the expression for divisible by 3. That is also, it's not number of A's, it's not the length of the string, it is about the binary numbers. Then it's going to take much time. So I'll tell you how you need to approach the question. Clear, everyone? So when you are not aware completely, you don't know how to approach this question, better to keep at the end. Because I know, because right now I'm telling you, because I don't know how to approach this question. See, there are 3 types of question. Number of A's divisible by 3. Oh, it's a very easy, right? A's, there is multiple of 3 A's, right? 3 A's you keep whole star. Okay, now B star you write here, B star. This is different, right? Here it's about number of A's. Let's talk about there's a number of ones, let's say, because they have given zeros and ones, right? Number of ones. Let me write that. If the question is about number of ones divisible by 3, then what is your answer? You keep 1, 1, 1 whole star. And zeros keep everywhere. 0 star, 0 star. Oh, this is an easy question, right? They didn't ask this question. If they ask length of the string is divisible by 3, oh, it's about the string, right? You can add 0 plus 1 whole power 3 whole star. Oh, this is also easy question. Oh, this is not that question. It's about something different. Application oriented. How do I know application oriented? Set of all binary numbers. Binary numbers means something you know. B0, B1, you know, right? Binary digits. They're talking about this. Now let's talk up to 6 digits. Now let's say if I want to divisible by 3, epsilon also divisible. Epsilon means what? The string. You have not given the string. Let's say epsilon. Epsilon is valid. And who else is valid? Single 0. 0. Is it having the number of ones divisible by 3? 0. How many ones are there? No one. So single 0 is valid, double 0 valid, triple 0 valid. Right, everybody? And number of ones divisible by 3. Single 1 never keep. 2 ones never keep. So keep 3 ones minimum. Sorry, it means divisible by, right? How do I say that? It's not number of zeros here. It's confusing. Now binary number is talking about binary number. Tell me which binary numbers are multiple of 3. So don't talk about double ones, 2 ones. That's the wrong option, right? Which numbers in decimal? Let me write. I'm also going wrong direction because of I have taken other reference. Decimal numbers I'll take 0. What else? 3, 6, 9. These numbers, right? For 0, what are the options we have in the binary? Single 0 or double 0. These are the binary numbers. Triple 0, 4 zeros, and this can be valid. For 3, what are the numbers valid? 1, 1, 0, double 1, double 0, double 1, triple 0, double 1. This numbers valid. 6. What number is valid? 4 and 2, and that's it. 1, 1, 0. Or 0, double 1, 0. Double 0, double 1, 0. Have you understood the problem? See, this is the problem which takes time to understand the question itself. The question is about binary numbers are divisible by 3. Not the number of zeros, not the number of ones, not the length of the string is divisible by 3. These are different questions. Right? These two are different questions. Here the language is about the binary numbers. I'll keep these binary numbers in my language when its equivalent decimal is divisible by 3. So this is about representation, right? Decimal representation. Even they have forgotten to mention the decimal equivalent of binary number is divisible by 3. That's what they should mention, but still the question is not represented completely, right? But you should understand because there is none of this here. We can challenge at least none of this is given. Everybody, are you able to understand? Binary number is multiple of 3, not the number of ones. So this is your actual question, and this question is completely different from this. How the strings we have taken based on the number 0, 3, 6, 9. For 0, you can represent 0 or double 0, triple 0, 4 zeros. 3, you can represent double 1 or 0, double 1, double 0, double 1, triple 0, double 1. Because in the binary number, you can write in any one, like double 1, I can write 0, double 1, double 0, double 1. All are valid strings for the number 3. Are you able to understand first question? And this is another question where it might waste your time unnecessarily. I always recommend the students never blindly answer the questions when you are not aware of the data. Because for me to interpret it is taking a time. Definitely in the exam for the students, for most of the students, not for all. Some students are intelligent, they can immediately answer it. Understand it at least. Right? Everyone? Come on, quick. It's not about even number of ones. It's not about odd number of ones here. So please check even number of ones. Is it generating every even number of ones? See that 1, 0, 1. What is this? 0, sorry, 1. This is even number, not even number of ones here. 1, 2, 4. It's equal to 5. 1, 0, 1. It's having even number of ones, but you do not choose that ever. Remember that. Even number of ones don't choose here. Even it looks like even number of ones is wrong. It's wrong, but there is a pattern. When you keep understanding it, you will understand that pattern. Right, 2 ones are there here, here also 2 ones are there. If you go for 9, again you will have the 2 ones. There is a pattern with the ones. That pattern you will get when you practice much time. Are you getting my point? Everybody? Sritam, even number of ones is wrong, yaar. Even number of ones is wrong. Okay, anyhow, we'll choose it. Now you understood the value strings including epsilon. Including epsilon, because they mentioned epsilon is also divisible by 3. So is that everybody generating epsilon? Just choose that first. Epsilon. Okay, is there any missing star here because they kept parentheses and they missed it? Okay, leave it. Is that epsilon valid? Look at everyone. Epsilon, everybody generated? 0 star and whole star. Yes, everybody generated. Don't choose it. Single 0, everybody generated? Yes. Double 0. See here, because of this 0, all the possible. This is always generated. Always generated. Now look for other options. Now double 1, 0, double 1, double 0, double 1, triple 0, double 1. So now you look at here. Double 1, here 1, 1 generated. And 0, double 1 here generated. Double 0, double 1. If you keep on going this right, how long we take to verify? Really, we don't understand it. It looks like 3 also generated, 0 generated, 3 generated here. And here 0 generated, here 0 generated, here 0 generated. But we have an easy option if you go from finite beta. How do we know that? We should construct the finite beta and should convert it. Really, we are not aware of that. This kind of questions better to ignore, because you do not have the quick answer unless you practice much outside the exam. The first time happened in the exam, so even I do not give you the best question, only the way that I tell you, skip this question to save your time to get the best rank in the exam, because never tells by anybody, any faculty in the world, that please ignore the question, because I'm telling you, because this question can take your time for the whole GATE exam. I can help you to answer this question, but that's not the right way to explain. Okay, anyhow, let me do that. So I'm just trying for these options till 6, then we'll go for other technique. Okay, 0 done by everybody. 3, what are options? Double 1, double 1 you can do. 0 double 1, yes. Double 0 double 1, double 0 double 1 you can do it. Triple 0 you can do here. Double 1 you can do. So 3 also you are able to do here. And 3, what about 3 here? Double 1 you can generate, 0 double 1 you can generate, double 0 double 1 and triple 0 double 1 you can generate 3 also. And what about here? Double 1 you can, yes, because of this 0 double 1, right, you can generate even 3 here also. Not an issue. Let's go to the 6 and understand in detail. Double 1 0, double 1 0 you can't generate here. Here the problem is double 1 0. So option A eliminated. Everybody understood? So now the problem is happening from here. The 6, 6 in the 6, double 1 0 here not able to. 1 1 and 0, how you get it? If you go back, then 1 comes again. There is no whole star to go here, right? So that is the reason double 1 0 you can't eliminate. What about option B? Can you generate double 1 0? 1 1 0 you can generate. So here you are able to generate. And 0 double 1 0, 0 double 1 0, here also you can generate. Double 0 double 1 0, 0 0 and double 1, and you can come back, you can generate 0. So this one able to generate 6. And what about this? You just try again. For the 6, double 1 0 you can generate, 0 double 1 0 you can generate, double 0 double 1 0 you can generate here also. So 6 you can generate here. Are you able to understand? If you keep on going this way, even 6 you may generate here also. If you keep on going this way, definitely you cannot get the answer. So I have another technique. You understood, right? Everybody understood the option, right? That's why they mentioned epsilon. Yeah, epsilon has no corresponding decimal number. Epsilon is not there in any language in the world except TOC, right? Epsilon means no input is provided to. That is called as epsilon here. It's a special language in the world, right? TOC languages are very special because epsilon also there. Epsilon means no digit, no number at all. So these are the numbers, right? When you don't write any number here, that's called as epsilon. That means when I don't give any input, you should assume that that is also divisible by 3. That is the meaning of epsilon. Okay. So epsilon, don't speak, yeah. They mentioned that when you don't take a number that is accepted, that means make initial state as a final. Indirectly, they are saying initial state as a final. Let's go to the concept. Now, if you try to design the problem, did you remember the problem? You know, there is a technique like Q0, Q1, Q2, and initial is Q0, and you have binary numbers. So what is the way you generate divisible by 3? Divisible by 3 means there are 3 remainders, you know, 0, 1, 2. That's why 3 states. And how you design the machine? There is another way to design machine. This is the easiest shortcut technique. Q0, Q1, Q2. Again, you repeat it. Q0, Q1, Q2. If you don't like this approach, we have another approach too. So for this, we have a machine. Like Q0. See how much time it's taking. Are you going to do these things in the exam? Never. Better to ignore this question, and at the end, if you have time, 10 minutes at least, you do it. So that's why I don't recommend it all. See, Q0 on 0. Why you are coming to Q0? Because 0, this is a binary number. Actually, decimal number is also 0. That's why we're coming. Why Q0 is the final? Because they said epsilon is accepted. That's why we are making Q0 is the final. And Q0 on 1, you can see on 1 we know you are going to Q1. Why? Because see that 0, 1 or 1, you just take 1 by number 1 or 0, 1, doesn't matter. 0, 1 or 1, I'm just writing here 1 or 0, 1 or 001, all will be here, right? So why, what is the equivalent decimal number? 1. That's why Q1 we are going, the state represents Q1. So we are going to Q1. So from Q0, that's why on 0 we go to Q0, on 1 we go to Q1. There's a meaning. Meaning we don't need it because we already have a shortcut. And Q1 on 0. Now you look at Q1 on 0, it's going to Q2. Why? Why we have this shortcut? Understand, from initial state 1 0 0 1 0. So 1 0 0 1 0 0 1 0 equivalent decimal number is a 2. That's why we are going to Q2. That means whatever we did, even though it is shortcut, you have a meaning. Everybody got this point? Why I am saying this? Because with the meaning you can design, but takes much time. But we have a shortcut. Why do you want to go like this? Because every binary number you need to convert into decimal takes time. So we have a shortcut already. So blindly follow that shortcut. You assume that's giving the right option for you. So now Q1 on 1, it's going to Q0. Why also we have a reason, right? Sorry, on 1. And Q2 on 0. On 0 going to Q1. On 1 going to Q2. So now this machine has the nearest relationship with these options. Now if you try to eliminate the option, I'm deleting this also. Now if you try to eliminate the options, I'm deleting all these things now. Okay. Now look at, even I can eliminate the option directly. So now look at this Q1 you eliminate, then what happens here is, you can observe there is a cycle here, there is a cycle here, right? So now when you eliminate the Q1, then you have a different option. Let me see that. Q1 and Q2 elimination is the target for you. Q1 and Q2. So eliminate one by one. If I eliminate Q1, then Q0, Q2 will be left. If I eliminate Q2, then Q1 will be left. You decide which one you want to eliminate first. Okay. So now this 2 you need to eliminate, that is your target. If you look at the option, Q0 is what? You have a 0 star, right? So 0. R. Any other option that you have here? 1 1. So that 1 1 also there. You can see in both options. And is this this one or this one you should get? 1 0 followed by something star 0 1. Is that correct? See 1 0. This is one path. 1 0 1 0 R followed by what is that? 1. No, this is not the right way to do. So 1 plus 0 0. No, this is a very complicated matter. So better to convert. So I'm deleting Q1. So what is the right option now? Let's look at Q0. So I'm eliminating, I'm giving the options to. When I eliminate this, you need to do this way. Are you going to do this in the exam? No, just for practicing here. So from Q0 and from Q2, this we are eliminating. And this Q1 can go to Q0 or go to Q2. So now look at Q0 on which one? On 1 it is coming to Q1, and Q2 on 0 it is coming to Q1, and then Q1 on what? Q1 on 0 going to this side, 1 going to Q0 and Q1 on 0. Now I'm deleting this one. So what you do? Q1 on 1 1, sorry, Q0 on 1 1 going to Q0. So now we have an option, 0 already there. Now we got 1 1. Okay, can you see that? 1 1, another one. 1 0, 1 0 goes to Q2. 1 0 goes to Q2. Q2 already has some self loop. Keep it as it is. Keep it as it is. Now this one is done. Okay, not this one is done. Okay, another one, Q2 on 0 1, 0 1 goes to Q0, and 0 0 goes to, already 1 is there, plus 0 0. So now we have also done this one. So after deleting Q2, this one is a machine. Are you going to do this procedure? Right, everybody? Everyone? Every time I'm telling you this kind of questions we should never practice in the exam, right? So now we delete Q2, then you will get some other option. So I'm deleting Q2 now. So let's try to delete Q2 from here. What will happen if I delete Q2? What will happen? Let's see. Everything is self loop now, no, right? 0 is there, already 1 1 is there. Now you need to look at 1 0 followed by R, 1 0 followed by 1 plus 0 0 whole star 0 1. This is another way to come to Q0. Now can you see this option? 0 plus 1 1 plus 1 0 something whole star 0 1. This is going to be repeated every time. That's equal to 0 plus. If I do anything wrong in elimination, definitely I am going to be the wrong. Are you getting my point? If I do anything wrong, definitely it's going to be wrong. So every step that I did is here. So this one whole star, because this can be repeated any number of times. Is this exactly matching with somebody here? Is it matching 1 plus 0 0 star 0 1, right? So now you look at why this has chosen, right? Why we have chosen this. So if you look at this one here, 1 0 0 1, this string is going to tell you 9. Is that string is possible here? It's not possible here. It's not possible here. 1 0 0 1. Is it possible here? Here possible. Then look at, match these options, because you know, while converting, if you do anything wrong, then you know you might say this one. So 1 0 0 1 is the 9 or not? This is equal to 9. Now is it possible to generate here? 1 here, 1 here, but 0 you can't. So here it's 9 is not possible. 1 0 0 1 not possible. But how you can eliminate that? It's a very difficult, right? That's what some people can observe that pattern. Okay, 1 0 0 1 is 9. 9 I can generate here. Can I generate here? No. That's why D is deleted. See, D also deleted. Without doing this also you can understand. But you should know that 3 is what, 6 is what, 9 is what. 3 is, let's say 1 1, 6 is what, 1 0 1 1 0 1 1 0. This one is 1 0 0 1. So if you know this, verify this quickly. 0 is accepted, 0 for 0, 0 1 1 1 1 0 1 0 0 1. Just cross check this numbers quickly. 9 after 9, 12. 12 is what? 8 plus 4, 8, 4. 2 is 0, 1 is 0, 1 1 1 0 0. So who are generating all this? They will be the valid strings, valid expressions. Now 9 is not possible here. That's why we went to that option, right? Now try 1 0 0 1, 1 0 0 1 here possible, here possible. So here 1 1 possible, 1 1 0 possible, 1 0 0 1 possible. So now option B you need to eliminate. How to eliminate that? You need to try other options, right? But this machine is exactly matching the C. Now the homework for you is why option B is invalid. Find out why invalid. So now you know I spend much time on this question, right? Now I can't go further, but you will find definitely there is a string if it is invalid expression. Everybody clear? You see, he is coming with option A, B, C are correct. Who is that guy? Tejaswini? Why option A, B, C correct, yaar? I am already given one string, right? Here what you cannot eliminate 1 1 0. Here I think if you have a star, just check about it. Okay. This one you check, and if there is a star, then option will change. Here there is a star is missing maybe, then A, B, C are correct, then don't blindly say A, B, C are. Here look at the option, even the star missing, right? If this is not gate question, are you going to say blindly it is A is correct? If there is a star in the gate, there might be star, typing mistake might happen, I don't know. You know the gate question and don't blindly come here, say A, B, C is right. So cross check, yaar, I have not taken the star, then, okay, I got it, big people know it, right? MSQ. So now this is might be possibly correct, and if this is possible, there should be the star here, but I have eliminated because star was not there. Are you able to understand what I am saying to you, right? Here star is not there. If that star might be there in the exam, that's why that was correct. Okay, I am going blindly because I never remember the options. Now if A, B, C are correct and these two are actually giving the same answer, right? 0 plus 0 plus, these two are actually equal. If you have a whole star here, right, these two are equal. Why? Because 0 plus is there, they have written A star, B star, whole star. That's it, they have written. If this is equal, this is also equal only when you have the star. Are you getting my point? So in my PPT, this star is not there. but in the exam it is there. That's why you know ABC are correct. Are you getting? You're only blindly following the gate. You're not following my PPT. Even though I do typing mistake, you are following only the ABC are correct. Everybody got my point? Right. This is the mistake that we do. We just follow the gate, right? Yeah. See, even as I'm a faculty, I never follow the gate questions. I don't remember your star is there or not, but you are able to remember it. That's good. But you know, but you should tell that there is a typing mistake in the option A, but you didn't tell me. You are saying ABC are correct. That means you're not worried about what is the option. You are only worried about what is the answer. Okay. So please try to understand. First, when you eliminate Q2, then eliminate Q1, you may see other options. Are you getting my point? You may see other options. So try other way. First eliminate Q1, then Q2, then you do another way. Q2 eliminate first, then Q1, then you may see option A and B. So here A, B, C might be correct. So that is the other homework for you. So question 9 is one of the lengthy question for the exam point of view. I don't know really how to make it easy manner, because if I do this for the question, this question, other question might have a different approach. Okay. Anyhow, please do this question number 9. Let's go for question number 2. Oh, sorry, question number 10. Sorry, question number 10 is not there. We'll go here. Question number 10. Definitely question number 9 is ABC or right options, but you do it other homework. I did only one approach, right? Yeah. Next. Okay. Meanwhile, please do that. Somebody is saying if Q2 eliminates, then you will get the option B. That might be the right option. But we don't do that approach in the exam. It's always taking time. Then better to eliminate better to leave the option. Okay, good. So let W be any string of length in 0, 1 whole star. Let L be the set of all substrings of W. What is the minimum number of states in NFA? Okay, anybody? L be the set of all substrings of W. So you have X, and what is that X? X is substring of W, but W could be a string belongs to 0 plus 1 whole star. This is the problem. W is any string, particular string or any string, right? Any. That is the question. Suppose for the W, let's say W is equal, let me write some string 0, 1, 1. How do you design a machine NFA? 0, 1, 1, right? This is the NFA. Now this is accepting only the W. How can you make this machine for all the substrings of W? I want to accept all the substrings of W. You have a shortcut, right? Now in this machine, you can reach, you can start anywhere, you can end anywhere. So how do you do that? Initial to final, you will make everybody is a final and everybody is the initial. So this is the path you have, right? 0, 1, 1. So what is the approach here is shortcut, very easy shortcut. You will make everybody is a final. That means you can stop anywhere, but also you can start anywhere in this path. So I can go directly to here on epsilon, or I can go directly to here on epsilon, or I can go directly here to epsilon on epsilon. Now this epsilons you can delete by converting, this is NFA, right? NFA you can convert to epsilon NFA with the same number of states. Only this epsilon will be deleted. If you have n states here, you will also have n states. Okay, here n is there, right? So better to put a k. If you have k states here, then algorithm always converts here k states. Only these epsilons will be deleted and you will get other transitions. Now how many states we have? For this is 3 length, right? 3 length. How many states? 4 states. Now NFA has 4 states, then epsilon NFA, sorry, what I am doing? Epsilon NFA to NFA. Both are same, of course. NFA, it's also k states. And NFA to epsilon NFA also you can convert with the same number of states. So it's called same basically, k states. So k is here n plus 1. So you will choose option C. Anybody chosen that? Yeah, option C. That means every state is the initial, every state is the final indirectly, right? From initial state you can go to any one, means indirectly everybody considered as initial. So this is a substring concept. What is it? Substring. Already we know the prefix concept is very simple. Don't give the epsilons, then that will be the prefix motion. So in the future, if they ask in place of substrings, if they ask suppose prefixes of W, then what will be the answer? Same states. If they ask suffixes of W, in the future, same. Now they ask substrings of W, same. In future, if they ask subsequences of W, same. Are you getting my point? So in future, what could be the possibility? I am just writing here. Question number 10 is actually converted into 4 extra problems for you. Everybody? But algorithms are different. How do you get an n+1? The algorithms are different. Okay. Next, 11. Question number 11. Oh, I think I don't need to solve this. The lexical analysis, this is a compiler related question, but application of the finite automata. Lexical analysis of the modern compiler language such as Java or C, C++ needs power of which one of the following motion is necessary and sufficient. So here there are problems. Here necessary and sufficient is there. We choose the finite automata. Suppose this option is not there. Then what do you choose? If only this word is there, what do you choose? All are correct here. You can use finite automata, you can use DPDA, all are correct. FA, DPDA correct, PDA correct, even TM correct, LBA also correct. Because of necessary and sufficient, because of these 2 points, what is the strict answer? What is the best suitable answer? Is the finite automata. Okay. So this is another point. MSQ is possible if I delete this word. Okay. Necessary. Simply you can say it's not sufficient, but you know, or simply models in just models. If this word is not there at all, what do you choose? You choose A, B, C, D, all of them. So but forget about necessary and sufficient, then A, B, C, D will choose. Okay. So understand, sometimes they ask the questions a different way to make it as MSQ. Right now we want the best suitable answer, that is a finite automata. Okay, 12. Any printing mistake, please let me know, because I don't remember the gate questions. Always I follow based on the data. Okay. Yeah. Who is that? DFA? Sven. DFA, finite automata, all are same, right? NFA, all are equivalent. Quick. A DFA D with alphabet is given. Which of the following finite machine is a valid DFA which accepts same language as D? Oh. Okay, options are there down. Okay, I'm sorry. So you have the question right. Are you able to understand the question? Oh, it's giving A followed by A plus B whole star, plus there's another path B followed by B, A followed by A plus B whole star. That's it. Anyhow, R is the dead state, we can't go that side. So the string should be starting with A, or string should be starting with BA. That's nothing but starting with A or BA. That's the option, right? Starting with A or BA. This is the language. So are you able to understand? So we are going for the options. We are going for the options. Now who is starting with A or BA? We is starting with A or BA. This is should be our language. Starting with A or BA. Is there anybody here? Check. Starting with A or BA. This one is here A, B, A, and this is the absolutely final state. Okay, and here this is the final state, and these two are final, but starting with B should not be accepted. Starting with B should not be accepted. Here you are accepting, but this one starting with A accepted, starting with BA accepted. So this is the right machine. But look at, is it DFA or not? AB, ABS, DFA. So option A is the right. Everybody, option A is the right option. Option A is the correct one. Any difficulty here? I think you don't have a difficulty, right? It's everything is same. What they did basically, they combined the states. Combined, that's it. The question is very simple. Just combined. S and T are combined to get this option. To get this option, S and T are combined. They kept the name as S. You know, minimization algorithm, right? You can also apply that, but just observe, you will get the answer. Okay, what is each one doing? You can just try to understand, but sometimes not possible. So now this one, is accepting any string which is starting with a plus b is accepted here. Or is that no? No, no, no. It's a is accepted, b is accepted, a starting with aa or ba. This is the language here. Okay. In case in the future if they make the question here. Now this one, oh, this is not DFA at all. This is not DFA. But anyhow, you observe what is the language accepted by this. Language is very simple, starting with that's a or b. That's a plus b followed by anything. It's accepted, right? You always stay here. No need to go the dead state. It's not a DFA, but it is a plus b whole plus. What about this? B. Final. Come to final. One is a followed by anything, starting with a. Another one b followed by b star. Oh, that's b star. You can stop there. Or b star, a followed by a plus b whole star. So these are the strings accepted in this machine. Everyone? Yeah, R is the dead state, correct here. So every option might be important because this will give you analysis how you should approach the machines. We have done 12 questions today so far. Okay, let's go to the 13th question. So far only one question we felt very difficult, which was consuming time, because that should not be attempted. So you should know what question should be attempted and should not be attempted for the exam. Because of one question, whole GATE exam can waste your time. Because I have seen I've attempted multiple times the GATE exam. Even as a faculty, when I was attempting, it was tempting every question. And some questions even I spent 15 to 20 minutes even as a faculty. So that makes a sense. Sometimes we go into a greedy that I want to solve every question. In that mode we will waste our time. But that should be realized when you practice the mock test. So while you practice the mock test these days, at least you should know why we are giving 10 to 15 minutes for a single question. Should not in the beginning, but in the end, if you have the time, let's say 2 hours, if you have completed all the questions, the last 1 hour you give the time wherever you assume that takes more time. Okay, so should be careful. Yeah, come on guys. Is this easy? What is the complement of the language accepted by the NFA? So now I tell you one thing, complement of the language, it's not the complement of the machine. That's the first mistake we do. In a DFA, if you want to do that, just interchange final, non-final. But don't do this. This is not a DFA. First point. This is not DFA. Don't interchange. What? Final and non-final. That's a blunder mistake. If it is a DFA, you can do that, because in DFA, if you do interchange final, non-final, you get a complement of the language. But in NFA, you don't get that all the time. Final and non-final. Is that clear, this point? This is not DFA, so don't interchange final and non-final. If you do that, you will see the wrong answer. Okay, 2 approaches I am doing. Interchanging final and non-final. Another one by understanding the language. What is the language? First, what is the language? This is the final, right? You can go on A, that is the one option. Or, how can you come every time here? A, again one more A. So every 2 A's, after 1 A, next 1 A you can come to the final. So tell me, what is the next string you will accept? Double A, triple A, 4 A's. Can you accept? But if any mistake here, guys, I am not responsible, because sometimes I see the typing mistakes are there. Okay, so here single A accepted, next double A accepted, 3 A's accepted. So can I say A plus? If it is a complement of L, what should be that? Epsilon. Are you clear this point? So that is the right answer, epsilon. But in case if you do this, what happens is the initial is the final and middle is non-final, the last is the final. Then you see the language is completely different. What happens now? What is the language? This is a different one. Epsilon accepted, and then A accepted, then double A accepted. So A star will happen. So if you do this, if you do interchange, if you do, this is A star. So A star also there, epsilon also there. If you do interchange final, non-final, you will choose option C. But if you understand the problem, you will choose option B. So be careful this kind of questions. Interchanging final and non-final is not the right answer because it is not a DFA, it is NFA. It is NFA. That is a very important point. Everyone? So in the future, they may give, they may ask a question like, they don't give this. They ask interchange final, non-final, then tell me what is the language. Then you say A star. Okay, that may be possible, but they will give in the question itself. Next, 14. Oh, another important question. Question is too lengthy, but if you have solved this data or this kind of question already, then this is not a difficult one. There is an approach called as tree approach. If you have practiced the tree approach already, this question can be solved within a minute. But the data, if you look at, right, this is the question and these are the options. You see how big this question is. Right, please read the question. Please read the question. Yeah, Raja Babu. Yeah, you did the mistake, and some people might do it because I saw the many students were doing these mistakes. Okay, these are all finals. This is the non-final. Okay, and what they want is on 0 1. So read the question carefully. So strings on zeros and ones, and the substring of 3 symbols has at most 2 zeros. Every time they see 3 and at most 2 zeros, they should see at most 2 zeros. This is an invalid string because you see here in the substring of 3 zeros you have the 3 zeros, but they want maximum 2 zeros. Now you see here 1 0, here 1 0, here 2 zeros, here 2 zeros. So when you take every 3 symbols consecutively, right, you should see maximum 2 zeros. That is the data. Okay, that is the data given to you. Now they have given entire machine. Only thing you have to do, on which one? On 0 what happens, on 1 what happens, and any other transitions are missing here. Here 0 is there, here on 1 what happens, on here the 1 is already there, 0 what happens. Only this 4 transitions you have to understand. Okay, let me help you first. What should I do? Delta on 0 0, that's a state name, right? State name, this is a state, remember that. On 0, this is the input. What should we do? Are you aware of this? Tell me, on 0, when I take the 0, what is the total string? 0 0 0. Is it valid? 0 0 0 0 should is containing more than 2 zeros, right? It's going to dead state, that it should go to Q. Are you able to understand this statement? What happened when I take the 0? 0 0 is an invalid string. 0 0 is invalid. It has 3 zeros, but every 3 consecutive symbols you should have at most 2 zeros, but you have 3 zeros here. Okay, this one is done. Next, 0 0, from 0 0 on 1 you are going to which state? If you can understand this, right, here maximum you have remembered 2 symbols. You can see 2 symbols, last 2 symbols you are remembering. So 0 1 you will go 0 1. Why? You look at, when I take 1, 0 0 1, is it valid string or invalid? Valid. And what I do, I always remember last 2 symbols, because next symbol when I take, I will go to the again last 2 symbols back. So this one goes to 0 1. So on 1 we go here. Here on 0 we are going to Q. I hope you are able to understand, right? Next we are missing the 0 1. 0 1 on 1. 0 1 on 1, it's going to be 0 1 1. So 0 1 is also valid. But what are the last 2 symbols? 1 1. So we'll go to 1 1. And from 1 0, from 1 0, if you read 0, then what is the state? 1 0, if you read 0, it's a 1 0 0, it is also valid. So last 2 symbols are what? 0 0. That's all the data. But the problem is, they have not mentioned what you study in the TOC textbooks or in the classes, right? Everybody? So this is another question. Whenever I keep the 3 stars, definitely many people might see some difficulty, because what you do and what you do in the class and what you attempt in the exam may not match sometimes, because you need to apply the concepts, and everything will not come as it is in the exam, right? So this is a question they made it. Very lengthy, but the question is so easy. But for that, if you have studied T approach, I have helped that second symbol from ending is 0 or third symbol from ending is 0, then you will approach this kind of technique. Like, 0, you remember double 0, you remember double 0, 0 1, you remember 0 1, 1 0, you remember 1 0, 1 1, you remember double 1. So last two symbols you are remembering here. So that's the technique that we follow in this T approach. Anyhow, now this did not mention in the exam as it is. What we do in general, we do like this. From 0 0, on 0 we mention Q. But here, just small change. Instead of this way, they mention on 0, they will go to Q. This way they mentioned. So understand, from this, you should understand this way. From 0 0, on 1, we are going to 0 1. So just this is the Q, this is the sigma, this is a back Q. So Q cross sigma Q. Normally we do Q cross sigma Q, right? We do like this, Q, sigma here, Q. But just they interchange these two. This is an in general table, but they modified this table somewhat different way. Okay, so understand this pattern. This is a present state, this is an input symbol, this is the next state. Okay, this one is from 0 1, when you read input 1, you will go to double 1. And last one, from 1 0, when you read 0, you will go to double 0. So this is the comma. What you have here is comma. Okay, now just look at this table, right? 0 0 on 0, you should go to Q. 0 0 on 0, you go to 0 1, you go to 0 1, you go to Q. This is the correct. You go to Q. Now just look at, this is also same in both of them. Just compare these two. These two are same, fine. And just look at from 0 1 on 1. Here also you can look at 0 1 on 1, 0 1 on 1, double 1 you should go. So that's right. So this is right. Here from 0 1 on 1, you are going to 0 1, but here it's actually should be, when you keep a 1, it should be double 1. So this is the wrong. So you can also look at here, if you know the pattern, right? You don't need to, go back and check here. Right, you can see 1 0 on 0, 0 0, double 0. So this is the right on, and double 1 0, the last one, and the 0 1 0 you should go. So this is the right option D. Right, even though it is too lengthy question, and it's one of the easiest technique to apply. Just when you come here, right, just look at this table. 0 0, when you read a 1, so 0 1 you should go. So this is the only one it's happening. And you can see here 0 1 on 1 you should go to double 1. That's only happening here. So 1 0 0, just look at these two zeros, it's correct. And look at this 1 0 state, it's correct. So this state is, this table is correct. Okay. So triple star, please, keep the patience. As I told, most of the people may not cope up with this kind of data because they never face during their study, and they don't have the patience to read this data, and they misunderstand the question completely. Okay. Question number 14. So 15th question. Fine. So can you solve this? Is another easy question, I guess. You can use past, present, future technique, but not required all the time, right? It's only for understanding. You spend more time when you have the difficulties. You have easy, then you can do it alone also. Can you do this? DFA is given complement of this language. First understand what is the language. Complement of this language is context free. It is always true, right? They wanted to choose the false. When you have a DFA, it is accepting some L, right? It is regular, we know, because of the DFA is there. Regular complement is what? Regular. So complement of LFA is context free. This is the true statement. We know it is regular. No need to choose, no need to understand what is the complement. Okay, if you don't want. What is the language accepted by this? Are you able to understand what is the language? Starting with 0, or what is this path? What is this path? If starting with 0 or 1 1 star 0, 1 1 star 0 followed by anything. So either you can start with 0 or you can start with this path, and after that anything is fine. So is this same as what is written there? Just check it. Are they two same? 1 1 star 0 or 0? Yes, they have just switched this two. It's fine. Followed by anything. Oh, is this same as 0 plus 1 whole star? Understand, 0 plus 1 whole star, they are confusing you. 0 star 1 star is actually same as 0 plus 1 whole star. So these two are not compulsory, right? So this is exactly true. It's a true. Don't assume it is a false. What they did is that confusing by adding something 0 star 1 star, but actually without them, with them, still it is the same. Okay. For the language accepted by A is a minimal DFA. Is there any minimal DFA for this? Can you combine these two states? Is there any possibility? That you should understand. You see this problem is, can I take the 0 common here left side? Yes. What happens? Epsilon plus 1 1 star is a 1 plus basically. And this is the same after that 0 plus 1 whole star. And this one is 1 star, right? 0 1 star. Of course, parenthesis is not required now. Now actually what you can do here, 0 1 star 0 plus 1 whole plus. So this one you can do another way. Is this is nothing but what? 0 1 star 0 plus 1 whole star. Can you do that? Can you do another way? Just think about it. Can I combine these two states? Can I combine these two states? Just check. If I combine these two states, what happens? From this state on 0 you are going to final, from this state 0 you are going to final, from this state 1 you are going to non-final, from this state 1 also you are going to final. If I combine this one, will you get the same answer or not? Just check. Will you get the same answer or not? With a 0, without 0. Are you getting the same answer? Check it. Come on. D, somebody saying D. What is the D? 3 and 4. Now language accepted by A is a minimal DFA. Is it a minimal DFA? Can you make the better DFA? So what is the meaning of this one? 1 star 0 plus 1 whole star. Can you combine? Yes, it is nothing but just starting with 0. Starting with 0, how can you design? This is the starting with a 0. Right, starting with 0. Is it always starting with 0? Just check once check, cross check. Did I do any mistake? Oh, that's a mistake. Sometimes even I do. You know, what happened? Actually 0 I took the left. What should I take? So anyhow, sorry guys, overlooking it. So epsilon plus 1 1 star. The 0 actually I should send right. That was my mistake. Anyhow, just check it. 0. Switching the question to question also somewhat difficult. So this makes epsilon 1 plus is 1 star 0. So this problem is not starting with 0. That's what my mistake was. This is a containing 0. What is it? Contains 0. Is this the smallest motion? No, right? Contains 0. You can have 1 0 this one. What I did here, I combined these two states basically. Correct? I can combine these two states because these two are actually equivalent. If I say this is A, no, this is P, this is a Q. Actually P and Q are equivalent. You can combine them. So two states. So this 3 is false. Fourth is A accepts all strings over 0 1 of length at least 2. At least 2. Will it be accepted? Just check. All strings over, but is it accepting single 0, right? One length also accepted. Can you see? If you like 2 length, at least 2, right? What about double 1? Is it accepted? No. So double 1 fails. At least 2 you are accepting all strings, right? But not. So 4 is also false. Anyhow, interpretation just you do accordingly. But all strings of at least 2 length you are not going to accept. Double 1 is not accepted here. Even though triple 1 is not accepted even, right? So understand 3 and 4. Many people are answering it, but I'm not answering. What I'm doing is I'm trying to explain how to interpret. Everyone, 1 is not accepted, double 1 is not accepted. Yes, done. So far good. 15 questions. Come on, quick. Are you all right so far? Small interpretation, small interrupt, because going in this sequence for long time is also not good, right? Our brain is also need some rest. Because especially me, I'm speaking continuously, then needed. Tell me how many times you are attempted so far. Is it first attempt or second attempt or third attempt for you? What is your attempt? Is it first attempt or second attempt for the GATE exam? Or you are just preparing for the GATE but you are not attempting at this time? What is your status right now? Let me have some water. Second, third attempt. Good. First attempt. Okay. First attempt. Oh, that's what I'm saying. The attempt is not going to matter. Some people might crack even 5 attempts after 10 attempts, but that's their requirement, right? When you have the requirement, definitely आप prepare करोगे. First attempt में भी हो जाता, कोई दिक्कत ही नहीं है. But you do systematically, you definitely crack in first attempt itself. But when you don't have the time in the first attempt, then you go for the second. But second also you try, you don't have the time, then you will go for the third. That's what happens for many students. They are attempting multiple times, doesn't mean that they are not cracking the gate. They are not getting enough time to prepare for the gate, because they might be doing the job, or they might be struck with some other works, or they might be, preparing for other jobs. So that might be the situation. That's why they are attempting again and again. Okay, correct? So don't worry that you are attempting multiple times. That is because of your situations. No one can stop your situations, right? But still you are trying, keep doing it. If you are working at some company, then take the time and try best all the time, right? At least, every year you will see some difference. If you are too busy in this year, definitely you may not be busy in the next year, so you'll get the time. But don't stop writing the exam if you are aiming for the IITs to do the MTech. Okay, question number 16. Yeah. Which one of the following is true? Are you doing it? In case if you have any doubts or something related to your preparation, you can keep asking. I'll take up whenever I need a break. C, is it right? We wanted to choose the regular, right? So sometimes you don't understand the data, right? Then eliminate. Elimination is the best, because it's MCQ type only. So they are saying this language is regular. This language, well known, non-regular, we know it. So this is false. And a power and n is a prime. So whenever they are prime, definitely they should form the AP sequence, arithmetic progression, right? So this is anyhow not a regular, we know that. And we are not able to understand it, let's assume that. Go to the last one. So this WW form, where W belongs to 0 plus 1 whole star, it is also not regular, but this saying it is regular, so this is also eliminated. So obviously we'll go to option C. Now look at what is the option C. W has this 3k plus 1 b's for some k. That means the number of b's is 1 modulo 3. When you divide with 3, you will get the remainder 1. So this is divisible or remainder concept. So remainder concept is definitely, you can design a finite automata. So option C is definitely irregular. Yeah, Satya might be right. When you have so many responsibilities, definitely you may not get much time to prepare, right? But you should take the time, like everybody. When everybody, I will just tell you the story. One time I saw the similar comment by some student. So what she used to do, right? She used to prepare when everybody slept at her house. So that is for according to her situation, that might be the right time to prepare. Like from morning to evening, the woman cooks and does work at home, right? You may not get the time to prepare. Even you want to get prepare in the daytime, your family may not support you. So but when everybody sleeps, then you wake up, and daytime you try to manage to sleep if possible, and that is how you can prepare for the GATE exam. That's might be the one possible solution for those people who are working at home and as a housewife and then doing preparation. Question number 17. Chart is not working sometimes. Okay. Do it. Which of the following regular expressions given below represents the following DFA? Yeah, this kind of two states, right? Two states, when you have the two states, you can easily identify it. So which one is saying that? Option D. Is it D? All are correct. First, have you understood what is the motion here? So whenever you have the 1, you are going to the final state, yes or no? We have designed many times this question, right? Ending with 1. So ending with 1, you need a expression. Ends in 1. Now, which one is ending with 1? We know the simple expression is what? 0 plus 1 whole star followed by 1. Do you have any other expression? You have also another expression, 0 star 1 whole plus. This is another important expression for ending with 1. If you remember this, then also there is another expression that ending with 1. There is a, it's not the simple form, but it's another important expression. Now we need to look at, this one is correct. And here, what is it? 0 star 1. What is this means? Are you able to understand what is this means? Is it matching with anybody here? Just cross check. Can you take the 1 common? 1 you can take right side, right? So I'm trying that. 0 star 1. This is a whole star is here. And I'm taking the 1 common. So that is epsilon plus 0 0 star is 0 plus 1. So this will become 0 star 1. So this will become, oh, let me write here, equal 0 star 1. This is 0 star 1 again, whole star. In that also you have a 0 star 1. You know, 0 star 1, 0 star 1 whole star, A star. What is it? A plus. That is exactly matching with this. And what about this? 1 and 3 are correct so far. And what about 2? 0 1 star 1. Another one, 1 1 star 0 star 1. Can you do something to get the similar one? Is it possible? So let's try. Somebody said 1 2 3. Is that correct? D. Is that everybody getting D? Anybody getting different one? Just, is it really ends with 1? Is it really giving ends with 1? Just let me try somehow to get a different possibility. See, you have 1 0 1 1. Suppose I want a string 1 0 1 1. Can you get from any one here? Don't look at, because of this one is ending with 1. Here string can end with 0 also. I'm very sorry for that. I can quickly conclude the answer. From this 1 1 0, I can generate 1 1 0 by putting this is epsilon. But 1 1 0 is not accepted here. 2, why this is correct? Why did you say this is correct? I want an answer from you guys, because why are you choosing the D? This is definitely wrong, because here 0 is generated, ends with 0 is generated, but my machine never accepts ends with 0. So only 1 and 3, that's a B is the right. So why did you go for the option D? Not then, Varun. Okay, you should analyze that. Why each option is equivalent to the given motion, right? If you are choosing this ends with 1, can you generate all 1? Because there is nowhere the to generate all the sequence. You see, this whole star, but this whole star is not there. Then that makes a sense. Here there is a sequence is missing. I can give many other strings here by looking at that sequence. Oh, you need to observe it. That's what the mistakes, right? Is it able to generate all strings ending with 1? Is it generating any string not ending with 1? 2 ways you need to think about to answer very quickly. Okay, fine. 18. Question number 18. Now by the time 2 hours, right? Okay, after 20 we'll take small break. Okay, can you do it quickly? L1 is a power n, L2 is b power n, but what is L1, L2? You should never write a power n b power n, never write this one, because a power n means a star there, b power n means b star. You should write L1 L2 is nothing but a star b star, you should write, okay, because you can't say both are equal. Here any number of a's, here any number of b's. When you write a power n, b power n, what happens? You are trying to demand a power 3, b power 3. If a power 3 is there, b power 3, but it is not that, right? Here any string of L1 can concatenate with any string of L2, but what you are saying is the same number of a's, same number of b's, that will mismatch the concatenation. So this is not correct, but L1 L2 is definitely regular language. This is the correct one. Which one of the following is correct? Only one is the correct, okay. Yeah, most of you have done correctly, that's good job. This one you can write if you want in terms of power, a power m, b power n, where m and n sorry, m and n greater than or equal to 0. All right, so far everything is fine. Let's go to the 19. Yeah, another important one. We'll give the shortcut rather than designing the machine. Yeah, this is called as the pattern based question. What is that called as? Pattern based. You are looking for some pattern. It could be any relation, greater than, less than, equal, not equal, all can be done, okay. The question is, the W has at least as many occurrences of 1 1 zeros as 0 1 1s. So the question is something like this: L1 is equal to W such that W belongs to 0 plus 1 whole star, where number of 1 1 zeros of W greater than or equal to number of 0 1 1 of W, okay. The L2 is W such that W belongs to 0 comma 1 whole star, number of zeros, triple zeros of W again greater than or equal to number of triple ones of W. Now the question is, it's not about greater than or equal to or not equal, any relation is there, okay. The concept is similar, you know. By understanding this pattern based, right, I got to some, you know, some shortcut. What shortcut is, if this 1 1 0 its reverse is here, then you can design a DFA. So 000 reverse is not 000, right? So you cannot compare this two. So this you do not have a DFA, it is not regular. But here you observe 1 1 0, if you want to count one more 1 1 0, one more 1 1 0, what happens is that 0 1 1 automatically is happening here. So you cannot count 1 1 0 twice without having other 0 1 1. That means this makes a cycle when you DFA, when you make a DFA. But 000, I can count one more 000. Now here 2 000s are there without having 111. At least you take one more 000 without having this one. That means this count can happen 100 times, 1000 times, 1 lakh times, that I can't remember with the states. But this one, I no need to remember 100 times. Why? If 100 times 110 comes, this one might come 99 times or 100 times. That means I need to remember either 0 or 1 only, because the other one came already 99 times or 100 times. So this one count, if it is coming 2 times, then this has happened already 1 time. Maybe if I keep one more 111, it could happen 2 times, both are equal this time. So understand, this is a different pattern. So whenever you see this kind of questions, right, just remember one thing: if anything, you have a P1 of W, any comparison, equal or not equal or less than or equal or greater than or equal, any condition, and pattern is there here, just do one thing. In this situation, just check, is that P1 is equal to reverse of P2. If this is there, then this makes regular. So one shortcut I am giving to you: in the future, if you see any such things, like here, if I see number of 0 1 of W is equal to number of 1 0 of W, yes, you can do it. Number of 1 1 is there already, 1 no. Now number of 0 0 1 of W is equal to number of 1 0 0 of W. See, both are reverse to each other or not? Similarly, any condition, see 1 1 0 equal to 0 1 1, equal or not equal doesn't matter, any condition is fine, right? So these are regular patterns. These are what? Regular patterns. Now look at L1 is regular, L2 is not regular because this dependency, the 000 and 111, you cannot have a DFA, you cannot construct the DFA to remember this count. But to remember this count, you try 110 twice. You don't need to remember 011 because it already happened either once or twice. Got to my point? So you will see maximum one difference. So this is going to create only 3 classes. This difference will be 0 or difference will be 1. So 2 indirectly. So if total you have, you will see something like this. Number of, what is it? 110s equal to number of 011s, or number of 110s equal to number of 011s plus 1, or number of 011. You will see always only these 2. That's it. You take any string in the world I am talking about, you will see only these 3 things. That is, it will never happen number of 110s is equal to number of 011 plus 2 plus 3 plus 4, never happens. That is the reason this problem is going to be regular. That's why I am able to make this shortcut somehow. So now L1 is regular but not L2. L1 is regular but not L2. Okay, this is called as a pattern based. In the future, if you see this kind of question, so remember this shortcut, what I have given here, right? So you remember this shortcut. But if anything which is somewhat different from this, so you need to analyze different way. Everyone? And this is also asked in other questions like other exams like TIF or ISRO and CMI, Chennai Mathematical Institute. You know, in other exams, this kind of question is really important. That's why I kept 3 triple star here. Done? Everybody? But really you want to design a DFA? Yes, that is the right approach. You should design a DFA for this. You should design DFA for this. 110 should be greater than or equal to 011. You can design a DFA, that's homework. But try for this enough. If you put a greater than or equal to 1 here, just try this this motion. That would be sufficient. Just to save the time, I am giving the shortcut, but we don't consider the DFA. It will take much time in the exam. Only for interviews, that will help you. Question number 20. Good. Can you do next one? 2 DFAs are there. DFAs, yes. The number of states in minimum DFA that accept the intersection. Okay. So now you need to do L of M, L of N. What is L of M? Are you able to answer it? What is L of M? This one is ends with A, right? Every time ending with A you are at final. So I'm just writing ending with A. And what is this? Every time B comes at the end, you are going to final. That's ends with B. So very easy motions. So somebody doing intersection. If you do intersection, what happens? L of M intersection L of N. Is there any common string between this? Oh, no common string, so it is a pi. Empty language, how many states you need for the DFA? Just 1 state, right? So number of states, how many? 1. It's a numerical answer type, right? Yeah, 1. Good. So you are able to answer it. That's great, right? It's a very simple question. So till regular languages, you don't have any issue. The problem will come from the push down automata. There you need to focus. Yeah. Do you want a small break? Because almost 2 hours, right? Do you really need small break for 2 minutes or 3 minutes? Or 5 minutes? So that you can refresh, you can have tea or come back. People are answering already. Just do it and then tell me about the break. The question is 21. So ends with 10. Ends with 10. What is the shortcut? Without designing a machine, we can give a shortcut, right? Ends with 10 means the minimum string is a 10, 2 length. 2 length. So 2 length, how many states required? 3 states. That's obviously shortcut if you don't want to design a machine. But in the exam, never design. As I told, for easy questions you can do it without using pen and paper. So ends with 10 takes much time to design. That's why the problem is, if 0 comes you have to wait. After 1 comes, you can stay there itself. After 10, any more 0 comes, you should start again to end with 10. After 10, if one more 1 comes, after 10 1 comes, then just come to the previous state, so that after 0 you can come to here. So any string which halts here, you will see last two symbols are always ending with 1 0, always ending with 1 0. Anyhow, this takes time to design, but we have the shortcut how to get the 3 states directly. Okay. Okay, so we'll just wait. We'll resume by 9. Okay, how many minutes you want? 9 10, right? Just take 9 10 minutes. 9:20 p.m. We'll resume after 10 minutes then. 9:30, somebody want 10 minutes? Okay, somebody want a dinner break, so better to have later, we don't have the break, right? So do you want to come back at 9:30? Varun asking about, right? Already 1 minute gone, yeah. Just do it quickly. So please resume at 9:30. Have a dinner, come back. Okay, meanwhile you can watch the video if you are missing some questions to explain. 10 minutes. I'll try to come back 10 minutes, but try to resume at 9:30. Yes, Varun, I was. Good. We'll see you back. Okay, I'll keep this question as it is then. We'll stop here and we'll. Welcome back. Am I visible, audible? Is it everything clear, guys? Is there an issue with the audio and video? All clear? Okay, great. So you have answered last question correctly, right? Now in future what kind of questions that you may face, आपको पता होगा यार, ends with 1 0 आया तो एग्जाम में कुछ भी आ सकते हैं ends के रिलेटेड, राइट? end with 0 0, कितने स्टेट्स होंगे? 3 स्टेट्स. ends with 0 0 पूछा, सपोज 3 consecutive zeros, कितने स्टेट्स होना चाहिए? 4 स्टेट्स. अगर ends with 0 1 0 पूछा, कितने स्टेट्स होना चाहिए? 4 स्टेट्स. अगर ends with 1 1 1 1 1 0 पूछा, कितने स्टेट्स होना चाहिए? 6 length plus 1 7 states. But right, the question, please don't construct the DFA at all. As you know, it might take much time, even 15 minutes 10 minutes, more than that, right? Sometimes. So you should be aware of that, how many states without constructing the DFAs. Okay, just let me do the refresh. Yeah, Satyam, that's the issue, right? We make the silly mistakes only, but that we do not realize during the exam due to pressure, or due to you are more expecting from your side, right? That might happen, Satyam. Even I go to the gate exam today, or in this year, I'll face the same situation like you. So who are having much control on what they do, they will crack the exam. So you should control yourself. I can't come to exam and I can't say any suggestions to you, right? You should aware of that, what should be done, what should not do that during the exam. Okay. आई डेंट गेट यू सर. अगर स्टार की जगह पे प्लस होता तो 0+1 भी कंसिडर करेंगे ना. तो क्या बोले, अब क्या पूछ रहा है यहाँ पर समझ नहीं आ रहा, किस क्वेश्चन की बात कर रहा है यार मूवी. Okay, that depends, right? How you do. If this is 0+1 instead of x, instead of 0+1 whole star, if this is 0+1 whole plus, then problem changes, right? Minimum length will change to 4. That will give the different answer. It will not give the same answer. That will be a completely different question. So in place of whole star, you have a whole plus. The problem completely changes. Okay. 22. Oh, sorry. Okay. So this is what you have. Another problem is a containing, right? Previous problem was ending. Now this is a containing 0011. This is a different question. I told you, right? That earlier question was containing 00 and 11. This is a containing completely one string, that 0011 as a substring. So this is a different question now. Expression is very simple. Already given sigma star 0011. Sigma star is the expression, right? Now what is the minimum number of states in DFA? That recognizes L complement. They didn't ask L. So if it is L, how many states you need? Minimum length is 4. Minimum string is what? 0011. And do you need any dead state? No. So you will be requiring just 5 states to understand that 4 length. Now whenever L takes 5 states, L complement will also take the same number of states. No need to design a DFA or anything. So answer will be 5 states. This will be true. Correct. So this question definitely easy, right? This question definitely easy. Now in future they may ask what? Containing 0, something like that. Yeah, containing 0 or containing 1, doesn't matter. Answer will be similar. Containing 00 or containing 01 or containing 011. How many states here? Minimum 1 length, so 2 states. Here minimum 1 length, so 2 states. Same. Here minimum 2 length, so 3 states. And here 3 states. Here minimum 3 length, so here will be 4 states. But how easy the questions are, right? Only you should be aware of what problem you are dealing with. Yeah, number of states remains same. Only interchange what happens. Final will become non-final and non-final will become final. They will be interchanged for L and L complement. So in the exam they just try to confuse L and L complement. So don't worry about it. If L has n states, L complement will also have same number of states. Question number 23. Which of the following languages regular? How many are there? You should aware of that. It is a very famous topic, right? Let's see what are the answers you will be having. And no Mac. Depends on the question, right? Not every question. This question is fine. You can design, but you already have a shortcut. You don't need anything. Even NFA, DFA, you do not need Mac for ending, containing, starting problems. Somebody saying A, somebody saying D. Which one is right? Okay. What is the difference between A and D? L1 and L3. So now what you are trying to say? L1, L3. L3 is L1. Oh, that means L3 you didn't understand. Length of W and length of X greater than 0. So the question is something like this. L1, they're trying to say WX W power R. Here all star is given, but they said greater than 0. It means the W comma X going to A comma B whole plus. That's it. What did they say? Same problem. What did they say is WX W power R, where WX belongs to A comma B whole star, but they have given condition length of W and as well as X both are greater than 0. It means the together it's all plus only. At least one length you need to consider for W and X. And what is this L1? You know, right? When you put the minimum W, what happens here is you are going to get here A, X, A or B, X, B. It's enough to understand whatever the W you take. You take W is AA, W is AB. These two forms are already covered everything. So this makes the regular expression A followed by A plus B whole plus A, or X is free right here. It's not depending on anybody. So this is equivalent to this one. L1 is, I have written regular expression. So L1 is regular language, very famous. Okay. But in the same problem, if X is not in the middle, then you will face an issue. X is there before or after, this will not become a regular. It's going to be non-regular. Only because of that X is in the middle, so everything you can convert into this starting and ending with A or starting and ending with B. But X is there at least one length. Now this one, M not equal N or M equal N or M less than N, M greater than N, any condition is given, but one condition only, right? So if I give all the conditions together, that will become different problem. Remember that. This M not equal N, then this language is going to be a non-regular because of dependency. And now here, A power, B power, C power, no relation except sequence. So somebody can write A star, B star, C star. So this is a regular. That's why people are saying A is the correct. L1 and L3 only. Okay. Those people who say D, just change it. Correct. Especially you might aware of that. You know, if in the exam you see something like this, WX, W power R, W power R X, and X W power R. If you have here W comma X belongs to A comma B whole star, then all are regular. All are what? Then all are regular. Because all become A plus B whole star. But when you have WX, W power R, W power R X, what else you have? X, W power R. In this case, in case if they have given here W comma X belongs to A comma B whole plus, then this will become regular and this too will become non-regular. If they have given the change here, if they have given plus here, if they have given plus here, this will be the answer. Okay, you should be aware of this. Oh, how A plus B whole star here, you just think about it. Put W epsilon, you get whatever you want. Put W is equal to epsilon, then everybody will convert into A plus B whole star. Once you have A plus B whole star, no need to worry about other W's, because in A plus B whole star, everything is covered. See, WX, W power R. This will become epsilon, epsilon, epsilon x epsilon. This is also x. X means A plus B whole plus. I'm very sorry. This one is A plus B whole star, na? Okay, then fine. A plus B whole star only. Previous problem is different. X is here what? A plus B whole star. Similarly, think about all other things. Your X and W both are A plus B whole star. That's why you're getting A plus B whole star. If W is not epsilon, it's not. If W is not epsilon, did I write anything? It's a whole plus only I kept, right? X is A plus. This is different. Okay. Which question you are asking, Bhagwa? Okay, next question. What is the question number next? Quick. 24. Okay, 24. Which of the following languages generated by this grammar? Oh, what is this grammar? Have you remembered this one? AS, BS or epsilon? You know, there are very famous grammars, right? AS using right recursion, or you take left recursion, SA or SB or epsilon. What this both do basically language? A plus B whole star. Any sequence over A's and B's can be generated by both of them. दोनों क्या करेगा? A plus B whole star को ही generate करेंगे, right? So now which one is going to be? Is this A plus B whole star? No, it's a different. You know, I don't know how this gate people are making the questions, right? They should not ask this question, which of the following languages generated? Of course, MCQ, we know they will go to option D. They should not ask this way, which of the following languages are equivalent? यार generated तो सब कुछ करेंगे कभी कभी, because A plus B whole star करेंगे तो सब करेंगे ना. ये तो सारे इसी के अंदर रहेगा। ऐसा नहीं पूछना चाहिए था, इनको पूछना चाहिए था विच ऑफ द फॉलोइंग लैंग्वेजेस आर इक्वलेंट टू द फॉलोइंग ग्रामर, ऐसे पूछना चाहिए था, देन ये होता। ये सारे तो जनरेट करेगा ए प्लस बी होल स्टार के अंदर ही है सारे सब कुछ, राइट। तो ये कुछ ऐसे क्वेश्चन है यार, ये लोग कैसे फॉर्म करते हैं, यही तो उनसे पूछना पड़ेगा। ये एमसीक्यू है तो हमको समझ में आता है यार, एक ही चूज करना है। अगर एमएसक्यू है ना तो विच ऑफ द फॉलोइंग जनरेट, मतलब ये सारे जनरेट होगा। Anyhow, you know, people are having the limited restriction while making the question, so we can't argue with them, right? But actual question should be like, which of the following languages are equivalent to the following grammar? Okay, it's indirectly which of the following strings are generated, means all the strings are generated basically. Okay, anyhow, we'll go for the equivalent all the time. But as MCQ, no confusion, but MSQ, they should make some changes in the question. Okay. The number of states in the minimum size DFA, that means minimum DFA, that accepts the language defined by the regular expression. What is this expression? Anybody can understand this problem? Like this one, x star, x star. Is it same as x plus? Means can I say 0 plus 1 whole plus? Small x I am assuming 0 or 1. Just I am showing x star, x star. Nothing but 0 plus 1 whole plus. What is the number here? 25. What is the answer? Oh, 0 plus 1 whole plus, how many states it takes? Epsilon should not be accepted, but either 0 or 1 should be accepted. It's similarly the length of W greater than or equal to 1. This problem. Right, greater than or equal to 1. That's why 2 states. So if you have here greater than or equal to k plus 1 states. If you have remembered the at least k length, then k plus 1 states. You can also use that shortcut, but anyhow, this is a very famous problem, right? So you can go for the 2 states. Question number 26. No doubt so far, right? All easy. These are all previous recent year questions, last 10 years questions only. Consider the following 2 statements. If all states of NFA are accepting states, final states, both are same, right? Final states. If all the states of NFA are final, then the language accepted by NFA, that is also a very important word. So in NFA, can you assume that everybody is a final? Can you assume it is sigma star? No. If it is DFA, definitely correct, but these are about NFA. This concept is about NFA, so no need to be sigma star. So this statement is false. Okay, incorrect. Why incorrect? In NFA, you can just say that, this is the NFA, right? Even I make both are final. No guarantee A plus B whole star, no guarantee A star, only epsilon comma A accepted. So look at this is NFA, no guarantee of accepting sigma star. It's wrong. There exists a regular language A such that for all languages B, A intersection B is regular. Is there any A such that A intersection B, every language B, remember, every language B. So for all B, can you put some A so that it is always regular? I'm going to choose that. Pi intersection B, is it guaranteed always regular? Yes. So obviously you will get a pi, but this is a fixed, sum exists, sum A exists, that is a sum A is the pi intersection B is the pi, that is always regular. So this is definitely true. So who is the correct statement? Only 2. Yeah, most of you are doing good. B is the right. Look at others and try to answer it very quickly here. Only 5 to 10 people are answering, remaining all are watching it. That's not good. Answer it whether it is wrong or right. So based on your analysis, answer it, and if you have done any wrong analysis, try to correct from the explanation. Right? जल्दी करना, जो भी है. $27. Where S is a start variable, then which one of the following strings not generated? So these words should be very important. Not generated. So that means somebody here generating, somebody is not generating. Observe it. Can you generate the first one, second one, third one, fourth one? Find out quickly. First, can you generate AB, AB? So this ASB you can put here, and you can also put here, you can generate AB, AB. So this can be generated, right? So this is generated. So I'll just write belongs to. Assume that belongs to L of G, means it is generated. Triple AB. Can you generate triple AB? So that ASB is there, right? ASB. So this S you can write as many A's you want it. As many A's you want it. So remaining all you put epsilon. Here A is there, here B is there, here A is there, here B is there. So you got one more A. Sorry. A, again SAS and ASB. So you got triple AB, right? You put epsilon this S, and this S you put epsilon. So you get a triple AB. This is also belongs to L of G. Now ABB double E. So can you generate the ABB double E? So just take here, I'm just taking here SAS, and one A is there, and this S I'm trying to put this double A. What is double B double A? Can I get from here BSA? And BSA I will take. Again I will take BSA. That means you got it, right? A, B, B, A, A. Remaining all S, whatever you left, you put epsilon. So this is also belongs to L of G. And what about the last one? Anybody answered? Oh, C is I am able to generate, right? C I am able to generate, no? You got it, right? A double B double A. You put epsilon here, you put epsilon here. So last one, B A double B A. So you can understand what's the problem here. See, this SAS can guarantee more A's. More A's can guarantee without any B. But this is having equal number of A's and B's. This is having equal number of A's and B's. These two are also depends on what S is basically. Now here you have a 3 B's. When you have 3 B's, you cannot have the 2 A's ever, because every time you get a B, definitely there is A with them. So that's why this option D not belongs to L of G. So if you can understand these 3 productions right, you can easily analyze it, but sometimes it's better to try to generate, because you don't know what sequence they generate, right? So that's the best way. If it is MCQ type, so that analysis will work. If it is MSQ type, we don't know exactly how many options are right. That analysis may go wrong. Okay, so are you able to understand? This will generate any number of A's if you want it. This will generate equal number of A's and B's always. This will generate equal number of A's, except S I'm talking about, except the S. And this SS depends on what you take. Okay. Yeah. No, it's not like that. B will not, middle it not generate. It will generate. Why not? See, I will take S directly. Double S I take. And this S I can take BSA. And this S I will take, let's say, one more time S, and this S I will take ASB. See that what I am trying to do, guys? ASB and BSA. Almost you have ABBA. This I will put epsilon, this I will put epsilon. The problem is this S cannot generate this B. That is an issue. ABBA I can generate. Do not assume that middle I can't generate B. No, that way, right? So you can generate. That's not an issue. Okay. Okay. Anyhow, fine. So that D is a not possibility. Next question number 28. How many, right? How many did they ask? Numerical or no? It's just options only. Fine. 28. Yeah, it's okay, Sinchal. That might be the right analysis for you. It could be possible. What is it? It's a direct question, I think. We did this in the class itself. What is this problem? You have X, you have B, and we have some symbol here. Second symbol from ending is B. Second symbol from ending is B. From ending is B. Then second symbol from ending is Z. If it is a kth symbol, suppose, then 2 power k is an answer. Here 2 power 2 is equal to 4 states. Who is saying the 3? They are wrong. Huh? Am I wrong? Why everybody 3? Why everybody 3? Guys, 2 power 2 is the 4 states. How did you get 3? Is it NFA or DFA? DFA. Who I am cross checking. It's a 4, right? Is it NFA or DFA? DFA. Oh, where did you study that? N plus 1. Second symbol from ending, not beginning. It's ending, yaar, ending, yaar. You need a tree approach for this. You need a tree approach. Minimum BA or BB. You have to design something like this. B, A, accepted. Then B, you can't go to that final. You need to go this final. This is the 4 states. You can't reduce this at all. And this one, after BA, A comes, you will be there itself. Tree approach you have to do, not like this. BA, then B comes, that B you can, I think, AB, right? You can go back. And after double B, BA accepted, and then BB accepted, fine. Double B, and then after that A comes, you can go to this final. And if again B comes, after double B, one more B comes, you just think about it. Double B accepted, and B comes, it's accepted. Oh, BA accepted. Oh, this is wrong. That's what I know. I'm cross checking it. I can't do it very quickly, just need analysis. So just understand, BA, one more A comes. This is ending with double A. It's not accepted, right? So what you do is, after BA, one more A comes, you need to start again for the B, because B is not there here. So now you come back here. That's the issue with the A. But after double B, if one more B comes, this triple B, 4B, 5B accepted. So understand, with these 4 states you can do. This might take time. A's you put here self loop. This might take time, but 3 states impossible, yaar. That's what we don't design in the exam. As you see, that 4 states we know, but it takes time to design. That's why you apply this concept. Oh, everybody is doing 3. If this is there as the beginning, if here A plus B is there, here A plus B whole star is there, then that will take the 3 states. Clear? Almost everyone doing it was 3. I was just checking. Is anybody doing 4? Nobody. So keep it this as a star marks, where you might do the wrong answer there because of you are remembering the formula, not the concept. Okay. 29. Yeah. At least can you do it quickly? They are easy questions, they don't take much time. Yeah. What is the answer now? The minimum possible number of states of a DFA. Okay. Is anybody newly joined, guys? Don't forget to like the session. Okay. W1A, W2. W1A, W2. What is restricted? This is exactly 2 length, right? This is the 2 length. And this is the minimum 3 length. Minimum 3 length. This is exactly 2 length. So what will happen in that case? This 2 length means 2 positions. This is the 3rd position. This is the 3rd position. So first position anything, second position is anything, but 3rd position is restricted, and 4th anything, 5th anything, 6th anything, and then after that you can have any sequence. So this is your problem, right? So how many states required? Without designing also you can do it. To understand 1, 2, 3, 4, 5, 6 length, to understand this 6 length, to understand or to accept 6 length, you need how many states? We need 7 states. But to have a dead state, if this symbol is not A, for that one dead state is additional. So total 8 states needed. I did not design it, but you can understand with analysis. It's not 7 because extra dead state is needed. So look at, we don't need to design in the exam, just need to approach how to get the conclusion, that is 8 states. That this conclusion comes from the practice, okay, not from the formulas that you make. Okay, everybody, it is correct. But really somebody want to design? Yes, design it and understand. In practice you should do that. First symbol is anything, so A or B. This is how both are same, right? Whether you put box or whether you design, there is no change in that. Only you should analyze in short form. This third symbol is must A. If not, then you will go to dead state. Here you will go to dead state. This is extra state we need. But third is A, and fourth is anything, fifth is anything, and the sixth is anything. After that, you can accept anything. Clear? That's what you design. It takes time. That's fine. Don't do that ever. Just do small approach to get the conclusion. Okay, 30. This is NFA with epsilon moves or epsilon transitions. Okay, what is the question you have? What happens? Okay, don't assume it is a Q2. It's a from Q2 state. After reading ABA, what are the states that you can halt? That is the meaning. From Q2, after reading ABA, what are the states that you may halt? Because of epsilons, you may have multiple paths, and multiple paths may reach different states to halt. So understand this problem. From Q2, by reading the string ABA, what is the state that you will halt? It might be having multiple answers that you need to find. First, can you do it from the diagram? Could take much time. So what you do quickly in the exam, you do finite automata diagram. So state diagram, you make it quickly, but don't take much time. So Q0, how many states are there? Q1, Q2, Q3, total 4 states. And who is the initial? Here final is not matter, it's not about the final. That's why you don't need to worry about the final state at all in the diagram, in the problem at all, right? So from Q0, on epsilon, you go to Q2. So I'm making the transitions, you observe them carefully. On epsilon, you go to Q2. So this, no need to write epsilon. If you want to write, you can write. That's not the problem. Okay, Q0 A, Q1, and Q0 B, self loop. That's over. Q1 on epsilon, Q2, this is epsilon, and Q1 on A, epsilon as well as A, epsilon comma A, and Q1 on B, Q3, and Q2 on epsilon is a Q0, a Q2 on A, nothing, Q2 on B, nothing, Q3 on epsilon, nothing, Q3 on A, nothing, Q3 on B, Q2. So you have a machine. Now from this you need to observe, find out what is the answer. Here it is very easy to understand what happens from Q2 on ABA. On ABA, what happens from here only. From Q2, look at ABA. So who is A? Where is A? Where is B? Where is A? So there are, these two are B's, here also there, here A is there. First A, can I read this? Can I read this? That is how you should do multiple choices. So can I read this A directly, the first A? First A, I can go this way, epsilon, then A. Can I read this as the first A? Impossible, because Q2 to Q1 without reading anything can you reach? Impossible, because either this path or this, oh, not there, only this path. So this never be the first A, this is only the first A. So you need to look at that way. So from Q2, by reading epsilon, you can go to Q0. From Q0, by reading A, I can go to Q1. So in the ABA, I read the first A now. This is only the way you can get A. There is no other way. If you have any other way, take it now only. Now after that, this B, how many ways? From here, how many ways I can read the B? So now see, this is a 1B. This is a second symbol, right? That is the B, or any other way. This B impossible as a second B. And is this B possible as a second B? Look at this. Epsilon, epsilon, B. That means two paths are there. From Q1, I can read the B directly, go to Q3, or from Q1 on epsilon I can go to Q2, on epsilon I can go to Q0, on B I can read another way. So from here, this path is also reading AB, this path also reading AB, but epsilon A, epsilon B, that is also AB. Now from Q3, the last one, B is over. From last one, Q3 on A. How many ways I can read A from Q3? There is no way, because B always comes from here. So this path will give you nothing. And this path from Q0, how many ways I can read A? This A I can read, or this A how? Oh no, sorry, this A always, sorry, I'm sorry. This is A only, because I can't go to Q1 directly impossible. But is there any other way? Epsilon, oh, I can't go to any other way. So this is the only one, Q0 on A. Oh, most of the people, what they do, they will stop here. But see, here Q1 is not there, so lucky. But when you are at Q1, indirectly on epsilon, I can go to Q2, right? There is, here I can halt. This is a halt. But you can also go on epsilon, I can go to Q2. You can halt here if you want. On epsilon again, from Q2, I can go to Q0. I can also halt here. So many choices you have, right? यहाँ भी halt कर सकते हैं, यहाँ भी halt कर सकते हैं, यहाँ भी क्यों? यहाँ से आपको choice है, यहाँ भी halt करो, नहीं तो बिना read करके यहाँ भी halt करो, नहीं तो बिना read करके Q0 में भी halt कर सकते हैं. So यहाँ पे आपको तीन choices मिलेगा, Q1 पे, Q2 पे, Q0 पे. So Q1, Q2, Q0 कहाँ पर है option? Where is that? Option C. Q3 impossible है, आप देख सकते हैं Q3 incoming, ये लास्ट सिंबल ये है ना, तो ये कहीं पर भी नहीं है, बी से ही ऑल्ट होगा, ये कभी बी आएगा तभी ऑल्ट हो सकता Q3 पर. ओके, सो सी इज द राइट ऑप्शन. यार बहुत कम लोग आंसर किया, सिर्फ चंचल, ऋतिक एंड रोहित, दैट्स ऑल. बाकी लोग क्या कर रहा था? टाइम टेकिंग, राइट. सो दिस इज अ वेरी इंपॉर्टेंट क्वेश्चन एंड practice it. In case you are not able to do it quickly, please practice it, because you need to look at the options carefully, because ABA directly not available. You need to look at after so many epsilons. That might be, interesting example, right? C. Yeah. प्रॉब्लम को समझना है, राइट? यहां ABA एक्सेप्ट हो रहा है क्या? वो अलग प्रॉब्लम होता, वो Q0 से हो जाता, Q0 से ABA फाइनल में हाल्ट होगा क्या, वो चेक करना है. वो है दैट इज कॉल्ड एज द acceptance valid string. We are not doing that at all. There is no final state here. It is only the problem, where do you halt after reading ABA? How many possibilities, right? That is also from Q2. Okay, next 31. Of course ये तो easy question है directly. Can you answer it without using pen and paper? Yeah, at most which one of the following is necessarily true? तो NFA में how many states given? N states. N be the NFA with N states. This is a N. And how many states? N states. Then question ये है, number of states in DFA which is equivalent, but here minimum DFA चाहिए इनको, which is equivalent to N. यहाँ पर कितने states है? K states है. यहाँ रिलेशन क्या होता आपको पता होगा, मिनिमम DFA में आपको एटमोस्ट 2 पावर n होता, एटमोस्ट 2 पावर n. तो ये दोनों देख के आपको बताना पड़ेगा दैट एटमोस्ट 2 पावर n. एटमोस्ट मतलब क्या है? लेस देन और इक्वल 2 पावर n. तो k इज एक्चुअली लेस देन और इक्वल टू 2 पावर n. तो डायरेक्टली लिख देना k लेस देन और इक्वल 2 पावर n. हाँ, ये तो D है, राइट. ये दिखेगा आपको NFA टू DFA कॉन्सेप्ट में, एल्गोरिथम में NFA टू DFA, DFA टू मिनिमम DFA. तो ये तीनों यूज करना पड़ेगा, राइट. NFA टू DFA ये एल्गोरिथम में यूज होगा ये कॉन्सेप्ट. यहाँ पर n स्टेट्स है, यहाँ पर एटमोस्ट 2 पावर n स्टेट्स होगा. अगर DFA में एटमोस्ट 2 पावर n है, मिनिमम DFA में भी उतना ही होगा. क्वेश्चन नंबर 32. This is one of the easy, but those people who know the algorithm, जिसको algorithm समझ में आता, ये क्वेश्चन related to algo and TOC combination. कि क्वेश्चन दिया है algorithm जैसे but data है TOC से, तो the question looks like algorithm but the data taken is from the TOC. The machine is DOC but the whole concept is from the algorithm, recursive concept. Even discrete mathematics recursion related, recurrence relation. या देखते कोई आंसर कर सकता है इसको. कुछ टाइपिंग मिस्टेक है गाइस, आई कांट अवॉइड इट, राइट. सो आई better to take care if anything goes different option because of maybe the typing mistake. Please cross check the question thoroughly, because one question it was happened whole star, right? The similar way you observe the other questions too. Now it takes time. Which year? 2018. Any answer? Order of L1 is what? Okay, do not try to answer which you have remembered. Solve it right now and answer it based on the given data on the slide. The order of a language L is defined as the smallest case such that in future they may ask largest k, so you should be careful. Or in future they ask L power k minus 1. So remember, even I can change small data here, you will get a different question, right? Even the data is almost same, one plus minus can change the whole answer, or smallest largest can change the answer. So this is about smallest, and you need to find that equation. Anybody answered? No one. So let me solve it. Are you able to understand? L power 0 is epsilon. L power any I you want to calculate, you must use L power I minus 1 is the recursive equation. For all I, even L power I minus 1 dot L. So this is your equation. L power I is equal to L power I minus 1 dot L. This is for all other I's. But L power 0 you need to solve epsilon. So this is algorithm. And for this, if you want to find order, आपको order find out करना है, तो आपको एक concept है यहाँ पर, smallest k find out करना है, वहां पर आपको ये L power k is equal L power k plus 1 होगा. So you need to satisfy L power k is equal to L power k plus 1. Like L power 0 compute करना और L power 1 compute करना, you need to compute this order. But if you see L1, sorry, like this, L power 0 is equal to L power 1, then 0 is the smallest, k is the answer, right? K. Suppose L power 1 is equal to L power 2, then 1 is the answer. Suppose these two are not equal, let's say L power 3. Suppose first time L power 2 is equal to L power 3, then 2 is your answer. So you need to find who is the smallest k first, so that L power k is equal to L power k plus 1. Got my point? So you are getting some answers here. Let's say I am telling L power 2 and L power 3, you got the same answer first time, but remaining you didn't get. L power 0, L power 1, L power 2, in this sequence, these two are not same, these two are not same. Then first time you got the same, then stop there and answer should be k is equal to 2. That means if anybody asks what is the order of L, it is 2. So this is how you compute. Anyhow, that we need to try what exactly the answer is. Correct? Now, this L1, assume that L only, right? Why need to change? If you change then L1, then all of them you need to L1, 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 you need to write that. It takes time, right? So let me say that here, what is this L? Assume this is L only. So what is the L here? I'm writing L, L1 both are same, okay? L is equal to epsilon accepted and 0 accepted. But what is this? Every time 00, 000, 0 followed by. That makes this is odd number of zeros. Odd number of zeros. If you observe it, 10 accepted, then 10 followed by other 2 zeros will be 3 zeros accepted. Then if you keep on repeating, you will get 0 followed by 00 whole star. That should be, very simple to understand, not the big immersion, right? So don't take much time. Epsilon accepted and odd number of zeros accepted. So this is the language, or L1 or L, both are same here. Now it's given, first you need to find out L power 0. L power 0 is given to you all the time. L power 0 is epsilon. But the problem is L power 1. L power 1 you need to find out. That is 1 minus 1, it is L power 0 dot L. But what is L power 0? Epsilon. Epsilon dot L is what? L only. So what is that? L is the same, right? Epsilon plus 0 followed by 00 star. Now you stop here. Check. Make a check. Is L power 0 is equal to L power 1? No. No, right? So we'll go further. L power 2. What is L power 2? That L power 2 minus 1. That is L power 1 dot L. What is L power 1? Same. This one only L power 1, right? So you write twice. Epsilon plus 0 00 whole star. And again same. That I'm putting, right? This L1 dot L is actually L square, right? So again same. Epsilon plus 0 followed by 00 whole star. And you are concatenating this, what it will result. Can you observe? Epsilon comes, single 0 comes, because 0 epsilon, double 0 means single 0 here, double 0, so this will become 0 star. Observe it carefully, this will become 0 star. So L power 2, L power, check here, is L power 2, L power 1 equal to L power 2? No, because L power 1 is different, L power 2 is different. Now when you do L power 3, this will become L power 2 dot L. If you do it, L power 2 is 0 star, L power 1 is this one, 0 star concatenated with this, you will get 0 star. So at this point of time, you got the answer like L power 2 is equal to L power 3, then L power k is equal to L power k plus 1, then we say order of, what is that? Order of L is k. Where is that missing here? Order of L1 you are finding, the order of the language is k, smallest k. So order of L this time you got it is 2. Don't 3, don't say 3. When we say 3, if it is k minus 1, then what you do? L power 3 is equal to L power 2 happens. Then order of L will change. If this is a k minus 1, then answer will be 3. There's a k plus 1, that's why answer is 2. So here you will get a 2. Are you able to see it? Yeah. Bhagwa, it's not 3 or 2, it's about 2 only. 3 comes when it is L power k minus 1, then you will see the 3. A small change can make the answer 3, but this is the 2 only. Correct? Yeah. Is it taking time or not? Definitely, but you should do that without writing. Many things you can avoid writing. You are able to understand this question, then many steps you can do without writing. This is always L, so no need to write. And this one L dot L, just observe. Oh, this if I write again here concatenate. So do you get all the strings? Then 0 star, and then just think about it. So always, one shortcut I am trying to tell you in the exam, those people who succeed, who can save the time. In exam, you need to understand, do you need pen and paper? For the question, for every question that you read, for question, the first point, that you don't need to analyze. That should come automatically based on the question. Do you really not need a pen and paper? Analyze what you have understood from the question, because when you don't use a pen and paper, you can solve the question in seconds. That happens because of you are not wasting the time because of external devices. Right? When you have the computer, if you connect the external devices, it takes time to connect and disconnect and to make the connection between the computer and external devices. So always pen and paper are external. Your brain can do it, please do it. That takes less time. So you can save a lot of time. And if you see 65 questions, maybe I am saying minimum 10 to 15 questions, you don't need it. 10 to 15 questions, you don't need any pen and paper. This can be solved. I don't know which questions, but definitely happens. Minimum 10 to 15 questions can be solved in seconds just by reading. Can be solved without pen and paper. So if you can do that, you can save more than half an hour time minimum. I am saying that can be utilized for those questions which are taking really 10 minutes. You can give the time. So be careful that don't waste time unnecessarily. That you can do without using pen and paper. Still you are using pen and paper, means you are wasting your time. Getting my point? So always analyze. आपको पता होना चाहिए यार, मैं क्यों यूज कर रहा हूँ, मुझे ऑलरेडी आंसर आ गया, फिर क्यों सॉल्व कर रहा हूँ यूजिंग पेन एंड पेपर. तो आपको पता होना चाहिए. ठीक है, तो इसलिए मैं बता रहा हूं कुछ क्वेश्चंस को पेन एंड पेपर जरूरत नहीं, और जब भी पेन एंड पेपर जरूरत है, हर स्टेप जरूरत नहीं पड़ेगा. देखो इसी क्वेश्चन को मैं अगर दोबारा सॉल्व करूं तो मैं तो एक्सप्लेन तो किया, राइट. अगर मुझे दोबारा सॉल्व करना है तो ऐसे कर लेता हूं मैं. एल पता है ना, डायरेक्ट लिख लेना, एप्सिलॉन 0 फॉलोड बाय 00 होल स्टार, ये पता है. सो अब एल पावर 1 इज इक्वल L पावर 2 इज इक्वल L डॉट L L1 डॉट L. सो इसी को 2 बार लिखा तो लिख लेना, प्रैक्टिस कर लेना फटाफट. एप्सिलॉन प्लस 0 फॉलोड बाय 00 होल स्टार. आपको समझ में आ रहा है, यही है तो डबल स्क्वायर, तो इज नथिंग बट 0 स्टार. तो L3 क्या होगा, 0 स्टार डॉट जो लिख लेना, ये L2 है, L2 डॉट L है. तो 0 स्टार यहाँ एप्सिलॉन तो दिख रहा है, तो बिल्कुल 0 स्टार बाहर तो आएगी, राइट. बस यहां पर रुकना, बस कितना स्टेप्स में हो गया, कितना जल्दी हो गया, राइट. ये प्रैक्टिस में हो जाता है. ऑल राइट, तो दिस इज अबाउट 32, 33. You need to practice in the mock test to Get that point. Okay, next question. X is equal to the pumping lemma concept, right? The first time it was happened in the history that about the pumping lemmas, this kind of question. Okay. Following can be the pumping lemma. Can be means there are multiple answers for this, not 1, 2, 3. So can be the pumping lemma. Is it MCQ or MSQ? If it is MCQ, so easy. If it is MSQ, you need to work on. Which one of the following? One only, right? And there is none of this. There is no none of this. So question might be so easy for you. So if you ask me, I'll go blindly to 24. Why? Shortcut I am saying. Why? Because it's MCQ. Only one option is right. And pumping length, if multiple answers are there, then definitely 24 will, if 9 will be the pumping length, then 24 can be the right answer, because I can choose the pumping length any higher number. So if 9 is the answer, 9 and 24 will be the answer. If 3 is answer, then 3, 5, 9, 24 will be the answer. So here the shortcut I am telling you, without analyzing the question, I can go to 24 because that is only the highest number. Which cannot be, then I am in trouble, because if it is only one, I can go to the 3. If it is MSQ, again multiple answers can be not. So here there is a shortcut which can be a pumping length. Always choose the highest one here. Always choose the highest one. But let's go. Right? Are you getting my point? Without knowing the concept, I am giving the shortcut. The pumping length possibility here out of 4, definitely 24, but 9 and 5 and 3 I don't know. But if 9 is the answer, 9 and 24 will be the answer, because pumping length, if it is greater than or equal 9, everybody 9 and 24, everybody will be the answer above the 9, including 9. So that's what I'm saying. Then 24 will definitely the answer. If it is MCQ, no need to worry, because this is only the answer. But how we are going to do it? So now the language is what? It is a union of a power 2 plus 3k and b power 10 plus 12k. Now when you design the DFA, right, when you design the DFA here for this initial state, now this side you need A's. How many states required for this? Are you able to understand this? Are you able to understand this? This is nothing but 3 mod 2, what is a 2 mod 3 problem. When you divide with 3, you will get the remainder 2. Here when you divide with 12, you will get the remainder 10. So this is when number of base, when you do with a mod 12, you will get a 10 here. Here number of A's, when you do with mod 3, you will get equal to 2 here, because 2 plus is there always. So understand the problem first. Now how should I solve it? Really, this should not be done, already done in the exam how to approach it, right? If it is which of the following cannot be, then you will go to the 3, because that is only the one possibility you can have. So when they ask cannot be, choose the smallest. Whenever they say which of the following can be, choose the largest. If it is MCQ, MSQ, you have the different answers. Okay, now let's go. And now how many states required for this? See, multiple of 3, right? 1A, you have to go here. 2A's should be accepted this side. And third A, don't come here. Why? Because only B's or only A's are there. After A, B, after B, A, not accepted. So you need to make extras. Don't come back here. So keep here. This is the A. And now you take the help of this state rather than going here. So 2 A's. Then after every, how many A's should be? Look at after every 3 A's, right? See, 2 accepted. 1, 2, 3. So from here, after every 3 A's you will accept, because 2 plus 2 is there, and then every 3 A's you will accept. Every 3 A's you will accept. So this is the one way, one path. Other path, how many B's you need to? 10 B's should be accepted. So 1B, 2B. Of course, no need to write in the exam. Already answer is over. Just I'm building it for you. Never ever do this kind of machine. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 B's you accept, and then now after every 12 B's you should come back here. So now if I go initial, I am in problem, because again after B, A may accepted. So I'll take one extra B, and then I'll take the help of this one. Now look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, again count it. Did I do any mistake? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means we need one more extra state. So let's take that to B. Now here let me take the help. I can't go to initial. Now count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now every 12 bits I can come. So now this is how you design. Now count the number of states. How many you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 should be the minimum pumping length. But anyhow, by looking at these two are different path, somebody can come up with the answer. At least you should have, in this path, if you look at, right, so at least you should have 13 states. 13, 16 plus 3, 16. So either you can use 13 or 16, but anyhow, if you want to go greater than or equal 13 or greater than or equal 16, you definitely have the 24 only. So greater than or equal 16, because number of states here is 16. So greater than or equal 16 is only the 24. So you can choose this 24 as the right answer. Okay, so this is how you should solve the question. The number of the pumping length should be greater than or equal number of states in this finite automata. This is a minimum finite automata. Okay, so here only the problem is dead states no need to consider, and there are two different paths. In this path is enough to understand, you don't need to go that path at all. But anyhow, to guarantee total number of states, we always take into consideration. So 16 is the number of states except dead state. Dead state I have not designed, just ignored it, right? So that is only the number which is matching. So greater than or equal to 16 is only 24. Everybody got this point? So in the exam, you don't do this. Just do this, by assuming it, by looking at this problem, it is MCQ, then shortcut. MSQ, no shortcut. Because if it is greater than or equal 9, there could be two answers here. That's why you need to be careful. Everybody got this point? So without designing any machine, by looking at the options, you can always come up with the answer. Who is the maximum number? That is the possible correct pumping length. But if it is MSQ, there could be more than one answer other than this. But when none of this is there, you should be careful. Okay, these things are not required for the exam, but if you want to understand, you need it. If you don't want to waste your time in the exam, always use a shortcut. Maximum for pumping length, and which cannot be, then should be minimum you should choose. Okay, that should match, otherwise they cannot make the right options. Any doubt here? Question number 34. 34. Okay, guys. Is the question which one of the following is regular? Not regular. Okay, not regular. Okay. So this is I think equaled. Right? Yeah, equal is missing. So typing mistakes might be there. Fine. Let's come up with the right answer if you have any. Why my chart is very slow here? Looks like my battery is going to dead. Which one of the following is not regular? Not regular. Okay. This is concatenation of two regular languages. If L is a regular language, concatenation of two regular languages. This is the meaning, right? L is regular, L power R is regular, then concatenation of two regular is also regular. So this should be regular, correct? Suffix of L. Suffix of regular is always what? L is already given regular. Suffix of regular definitely is what? Regular. Prefix of regular is always regular. But the problem is, this. Oh, what is this? W belongs to L. This L is what? Regular. Can you guarantee that W, actually they should give W belongs to sigma star, but I don't know why did they mention, because anyhow. So if this is regular, then W power R, let's say A plus B whole star, then W power R, the W belongs to A plus B whole star. So this maybe here, look at which of the following is not regular, but this is, I'll tell you, question number 34, people are answering D. Do you think really D is the right answer? This is what happening, what you are doing from the gate questions, right? People who are answering D, people are giving the answer D in anywhere. Remember, which of the following may be not regular, then it's fine. But L is a regular language. Which regular language? They didn't mention it. This may be the pi. If this is the pi, then this is a possible to be regular, because L is the pi. You can't take a string. This is also equal to pi. When L is the pi, then W you can't take. This language is equal to pi, right? This is always not regular. Remember that. Only sometimes. Well, I'm showing you regular because when I take L is equal to even epsilon, just take only epsilon. This is a regular language. And when I take L is equal to only epsilon, W belongs to L, that L is only epsilon, epsilon is epsilon, this whole language become epsilon, but this is a regular. So here the problem is whoever made the question, I'm telling you, whoever made the question, they did not analyze all the cases in the world. They only assumed, they know W power R, so that W belongs to A plus B whole star is not regular. But here they did blunder mistake. W belongs to regular. Regular might be empty language, might be very simple. When it is very simple, this whole language can be regular. Here only sometimes only not regular. Sometimes regular, sometimes not regular. But the question is something different. The question is, they say that which one of the following is not regular, means indirectly they are saying which of the following is always not regular. Even there is no option here. So in the exam, if we could have challenged in 2019, you could have got the marks, because I could have I have a counter example. Of course, we did not challenge that here. So people were assuming D. Actually here no answer is correct. No option in this question. Everybody got this point? Come on. Maybe. So this is not is, it's here, right? Is means always. Remember that? They did not say may not regular. Languages is not regular. So they are demanding somebody is not regular here. It's not regular always. Only sometimes. I'm giving whenever, if let's take something like this. If L is equal to epsilon, this is regular, right? Then what happens? This option W power R such that W belongs to L. What happens? This will become only epsilon. Oh, this is also regular. Then how can you say not regular? Okay. Anyhow. Everybody got? So this kind of analysis is missing from the most of the students, including whoever made, I'm saying who is that IIT faculty, right? Even he is doing the mistakes, it's a common mistake, see, for you and even for the faculty, right? Then we don't need to worry if one or two questions are not able to analyze it, that's fine. But from our side, when we practice, this was disclosed and you should analyze properly. That's what I'm saying. Don't blindly believe this answer is right given by everybody. You should not do that. You analyze your way so that you will get more approaches and more understanding. Okay. So here, please don't answer anything. Right. Even somebody says D is the right answer, D is the wrong, and here no answer is right, because these three are always regular. This is only sometimes regular, but question is not mentioned which of the following may give not regular is right. So here no answer is right. Question number 35. Okay, one of the again time taking question for the gate. That's what I'm saying. We have to check every aspect. How do you solve the gate questions? By analyzing everything that is there. It's not that you need to get the right answer. No way. Don't do that. What you have to do, understand the question, understand every option. Even you know the answer, why should be that? You try to disprove it so that you will get the conclusion correctly. Okay. You have the more time when you want to explore, right? Right now, don't remember anything. Just apply what you have from the concepts. Questions don't try to remember, but concept you try to remember. That's fine. Those people who remember the question, always they come up with the wrong answers, because when I change plus to minus, they don't realize it. Okay, what is this? This is combination of maths, discrete maths, and TOC. What the whole concept is mathematics, but the strings, the languages, they are applying on the TOC. So that makes sense, right? You need to know what is the bijection definition, right? And you should know what is the concatenation, because they are going to use the concatenation to get the strings. And that's actually, bijective mapping that is here. Not the concatenation, the bijective mapping. ID, what is that ID function? Identity function. Okay, anybody done? So I'm putting triple star means even I may take much time to explain you. So should analyze properly. Okay, so now the problem is understanding the question. What is the bijection, right? What is the bijection? It should satisfy 1 to 1 and on to both, right? And also you should know all the properties of the bijective function. Remember that. Suppose if one is bijective, let's say I is a identity, then the function is bijective. F circle I and I circle F is equal to F you get. So when the bijective property comes and identity is there, forget about the function identity, right? Any mapping, when you have identity, right? So F circle I circle F is always what? F. We know about the identity function. So what they are saying is you have only here bijective functions. You don't need to worry about anything else. I have a sigma in which what do you have? You have the functions, not here. Functions are input symbols. Remember, it's not A, B, C, D. They are functions, okay? They are what? Functions. So you have 1 to 5 is given. I'm just taking F1 to F5. So I'm just reframing it to understand easily. So sigma is be the set of all, or not sigma. It's not sigma also. It's a domain. So this is a domain A, let's say. How do I give here? So that's what the problem happens. Let me start again. So now this is your A. Let's say 1, 2, 3, 4, 5. They are elements. Analyze it. Analysis will take time. 1, 2. This kind of questions you may ignore in the exam if you are not able to analyze quickly. So now here you will get a functions. How many functions you will have? 5 elements to 5 elements. You will have so many functions, and sigma is only the set of all bijunctions. Now you need to understand how many bijective functions here. You know bijective, right? How many bijective functions here? Do you remember that? 5 elements to 5 elements. If one maps to any of these 5, how many choices you will have for one? You will have 5 choices. Then 2 you will be having 4 choices. Bijective functions, how do you compute? Then 3 will have 3 choices. Then 4 will have 2 choices. 5 will have 1 choice left. That's it. If 1 maps to 1, 2 will map to 2, 3, something like that. So everybody will map to exactly 1 here, and total possible mappings here, how many? So if 1 has a 5 choices, 2 will have 4, because 1 can map to anybody. Then 2, except what 1 map, 2 will map to anybody else. So now here how many? 5 factorial bijective functions. Is that clear? First, how many bijective functions? Then sigma we can write. 5 factorial means what? How many? Of course, it's so big, right? We don't do this question in the exam this way. I will tell you other technique. But what is a 5 factorial? What is a 5 factorial? Quick. 120. Good. So 120, like F1, F2, F3, and so on. You have 120 symbols in the sigma. So this is how you come to the conclusion. So first, what is bijective function? If you're not clear what is bijective function, you cannot come up with the sigma. Initially I thought only 1 to 5, but something different from what I am analyzing. So sigma is a set of all bijective functions. So now sigma is having 120 symbols. Every symbol is a bijective function. Is that clear? Every symbol is a function here. So now answer you might be getting, but that you need to understand why you get 120 is the answer. That you need to understand. Is that clear? Not because of the sigma, it's because of the problem. Problem is something else. L, the minimum number of states in DFA. How many states we are asking, not how many symbols. Both are different, right? Now this question with 120 functions may take time. So I'll reduce little bit smaller problems. Look at, I'll just analyze to understand with, let's say, if I take 3 states, if I take 3 symbols, then look at the problem is going to be very smaller. 1, 2, 3, here 1, 2, 3. How many functions you will have? Total 3 factorial, 6 functions. 6 functions could take even more time. Let's analyze with the 2 only. Then now we will be having 4 functions. Now my sigma is 2 functions, F1 and F2. So we'll analyze with this what happens here. Sigma is equal to F1 F2. Now we'll start with this. Identity function is very clear. ID of j is equal to j. So ID. So here F1 F2, right? Who is identity? Look at here. 1 2 1 2. So 1 to 1, 2 to 2. This, let's say this is F1 and other one 1 2. Look at how I am analyzing, how much time it's taking. F2. That means among all these bijective, only one function. Out of 120, one function will be identity. Only one you will be having identity. That means in the sigma, you will be seeing one identity function. Maybe I am assuming F1, but you can assume F2, this one, F2, this one, that's fine. So now what is the concept you will get when you are doing the strings? What are the strings you will get in the sigma star? Let me write the sigma star. What is the sigma star? Epsilon. Sigma star I am writing. F1, F2, what else you write? F1, 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 F2, F2, F1, and then F2, F2, and so on, right? This is a possible combination you will get. Now the question is here, for a string x, if you have x1, x2, look at that answer. The phi of x is, you are going to do this, concatenation is going to be bijective mapping. So this one, f1, f1 is going to be f1 again. f1, f2 is going to be f2. f2, f1 is going to be f2, because f1 is the bijective. You know, f1, if you this one, f1, you do the mapping, you will get bijective mapping, you will get f1. Similarly here, f1 mapping with f2, that's circle, right? It's a bijective mapping, so you'll get f2. So that's function is given here. Phi of x you need to analyze with the circle. That's what's f of, right? You will write some of them. F circle I is equal to f, you write. This is a circle mapping, you know, right? The composition, basically called as, this is a composition. What is this? Composition. Because of the bijective mapping, you have all the functions. In that, one identity function is there. F1 is always identity, and F2 you need to understand what you get. That is, F2 you do of F2, right? So this 1 will map to 2, 2 will map to 1. So you will get F1 here. So every one you will get something. So always the result is either F1 or F2, either F1 or F2. You see that, either F1 or F2. If you take any triple F1, what will be the answer? Identity is F1 only. If you take F1, F2. So F1, F2 already F1, F2 is F2. So every result, every string will come to either F1 or F2 in this sigma. But if you have 120 symbols in the sigma, every result will come into one of the 120 symbols. Now what happens? You just need two states. One for understanding F1, other one result is F2. This is not a state name. Remember that. This is a result equal to F1 equal to F2. Now from here, if F1 comes, F1, any number of F1s, you will be always here. If F2 comes, after F1, F2 comes, or directly F2 comes, then you will go to the equal to F2 state. From F2, if again you get F2 followed by F2 will be F1. And after F2, any number of F1s you will be staying there. So that means if I have the two elements to two elements mapping, you will have total 2 bijective functions, so that you got 2 states. In case if you have 120 bijective functions, how many states you will have? 120 states you will be having. So this is the one of the important question, which is really interesting, how TOC can be expanded to different domains, like you are using the mappings from the mathematics. So this is time taking concept to understand what is each line here. Let circle denotes the composition, but composition is applied instead of concatenation. So how many things are happening? TOC will do concatenation, but that concatenation is changed to the composition in the mathematics. So whenever you write F1 F2, you are doing F1 composition with F1, sorry, F1, then F1 composition F1, that is F1 is already identity, so identity is going to get the result as I, circle I is I, so something like that. So here with the 2 functions only I have explained, but if you have 120 functions, the result will be similar. You will be every combination epsilon F1 to F120 you should write, and you write any string over F1 to F120 symbols, the result is always in that. So that's why you will have 120 states. Everybody clear? So that's what I am telling you is really going to take much time to take with this exact given data. Even why I am worried about, if I take 1 2 3 1 2 3, right here, how many states you could have got? 6 bijective functions for the 3 symbols here. So 6 symbols will be there because of 6 functions. When I have 6 functions here, it will be very difficult to analyze. That's why I immediately went back. Epsilon, F1, F2, F3, F4. Here F1 is there. Again F2, F3, F4, F5, F6 with 1 symbol, with 2 length, so many will be there. So I can't explain 1 length, 2 length properly there. That's why I came back to just a 2 symbol to symbol mapping to get the 2 bijective functions. Okay, everybody? So this kind of analysis, which might take time, for me, every day I'm not doing the same question, right? कभी कभी कर लेता हूँ, तो इसलिए डेटा एनालिसिस में टाइम लगता है, बिकॉज आई नेवर रिमेंबर द आंसर्स, मे बी 120 or 60, इट्स डजंट मैटर टू अस. Once you know the concept clearly, right, what is this string and what is this mapping, and what is this language is nothing but x belongs to sigma star, means this is a sigma star, this only there in the language, but phi of x is equal to id. So now which one is the final? Even I did not complete it. See, which one is the final? Whoever gets id. That means L will be something different. Epsilon by default you may consider it if you really want it. Okay, that's special, always special. Now f1 will be there, f2 will not be there, f1, this result is f1, this will not be there here, and this will not be there, this will be there, f2, and so on. So this will become a final state, because whoever gives the id as a result, that will become a final. So that's why you got two states. In the exam, they could ask not equal to id, then other than this one, here you will be making final. Everyone? So question number 35. Question number 36. Yeah, if you are really coming for the answer, right, I can give you in seconds, but that's not my intention at all. Great. Consider the following statements 1 and 2. Which of the following statements are above statements, or which of the above statements are true? If L1 union L2 is regular, then both L1 and L2 must be regular. So here the data is something different. If L1 L2 are regular, that we know, regular union regular is regular, but it's different one. If something union is regular, two languages union is regular, can you guarantee always L1 L2 are regular? Is there anything? So this one is having counter example to understand. See, what they are saying is, if L1 union L2 is regular, can you guarantee that L1 and L2 are always regular? Must means always. See, only one direction, right? So now I am showing L1, just assume a power n, b power n. L2, just assume its complement. Both are non-regular, but when you do the union, you will get a plus b whole star. See, I have taken the data what they have given. L1, L2, I don't know what they are, but their union is regular. But L1, L2, can I guarantee always must? Maybe regular is fine, but must. So that's why this statement is not correct, not true. The reason you have in front, I have L1, I have L2, their union is regular, but these two are not regular. So whenever union is regular, you don't know what they are, but when this L1 and L2 are regular, you can always prove converse. If this direction is given, then this is going to be regular. But result is given, you are asking about the operands in the operation, that's not guaranteed. Okay, everybody got this point? See, A. All are going for neither one, not two. Okay. Another one? Oh, that's, I thought one. Okay, A is correct, na? So the class of regular language is closed, actually not closed under infinite union. Infinite union, infinite intersection, everything you know. So that's why you're going for one. That's fine. Correct. All are A correct. So I was misunderstanding that. You were saying this is A. Fine. Neither one, not two. Correct. Question number 37. This is another question. Most of the people analyze 2 into 3 is 6. But I don't know really that is the right formula or not. Number of a's in x is divisible by 2 but not divisible by 3. Anybody answer this question? Okay, I'll leave to you. If you are able to answer it 6, that's fine. 3 people are answered. I'll wait for the remaining. If you are getting 6, then I will leave to you. I hope you will analyze it correct way, but not the using shortcut. Can anybody need an explanation for this? I need to go for the battery charging. Fine. 6%. Can I skip that? Are you able to understand this question? Number of A's in X is divisible by 2 but not divisible by 3. So you can analyze the other way, that L1, just assume that X such that X belongs to A comma B whole star. Number of A's in X divisible by 2. L2 is different, X such that X belongs to A comma B whole star. Then number of A's of X is but not divisible by 3, right? Is, you can write not divisible by 3 or you can write is divisible by 3, is your choice. If you want is divisible by 3 is also fine. Then you try to understand what strings you will get here. Here you will get number of A's divisible by 2. What strings you will get here? Epsilon. Single A you don't get, but single B, number of A's is 0. And then double A you will get, AB you don't get, BA you don't get, double B you will get, and even number of A's you should have. This is even number of A's, right? It's a divisible by 3. That means you should not get, single B is fine, double B is fine, but this you don't get, double A you don't get here, because double A is not divisible by 3. Triple A is the first string which has A's at least. Next, you don't have A's, 1A, 2A you should never have, and then triple B is fine, and so on. Now the question is, L1 you want but L2 you don't want. So what strings L1 minus L2 you should do? And when you look at the strings, right, when you look at the strings, now you look at L1, otherwise you can do this one. You require how many states? 2 states. This one you require how many states? 3 states. And with 6 states, whatever you get, that will be the right answer. But I'm just telling you the strings only. Epsilon will be deleted because epsilon is there here. So B is deleted because is there. Double A will not be deleted, and double B is deleted, and so on. The strings which are there in L1 divisible by 2. If you observe this, the divisible by 2 is number of A's, it's going to be like this: 0, 2, 4, 6, 8, and so on. Here number of B's, how many? Number of A's only, right? Number of A's here 0, 3, 6, 9, 12, and so on. So if you look at how many here, if I do subtraction, right, this and this, the result, I want this but I don't want this, then what will happen? Divisible by 2 minus divisible by 3, 0, 0 cancel, then 2 will come out, and then 4 is not here, so 4 will come, 6 will not, 6 is here, so 6 will be cancelled, and 0 will be cancelled, 8 will be there, and so on. So you are going to get 2, 4, 8, and so on, right? So let me show you one more concept here. 2 A's, 4 A's, 8 A's. Next, here 10 is there, 10 will not cancel, and 12, because 12 is here, so 12 get cancelled, and 14, yes, 14 is not here. After 12 you will have 15. So understand the problem why you get 6. It's not just like 2 into 3, because here I cannot make a formula here. 14, 16, and 16 we are going to get in the result, and 18 going to cancel. So now understand, see, first you need to understand, accept 2 A's, then 4 A's, then 8. Now you see the distance here. Here distance is plus 4, here distance is plus 2, and here distance is plus 2, and your distance is plus 4. So plus 2, 4, plus 4, plus 2, plus 4. This sequence is going to happen. So what you do is, first 2 A's you need to accept. 1 A, remaining self loop, B self loop only. 2 A's you accept. Then you need to accept 4 A's. So you can't make a loop here right now. Remember that. A, 4 A's. Accepted. Now after that, 4, 8 you need to accept. So this should be the 8 and this should be the 10, so that it will become easy for you. So after 4 A's you should come here. Already 2 here. Now you can't go here directly, so you need to take one more extra, and then from here you can take the loop. So now what happened is, see, 2, 4, 5, 6, 7, 8, 9, 10, 10 accepted, 11, 12, 13, 14, 14 accepted, and 15, 16. So this can take care of, and be self loop everywhere. See, it's not that easy to make a DFA, but why I'm helping, in the future they may ask about the machine, they may give this machine and they may ask the missing transition, then you should know how to design the machine. So this machine is actually number of A's divisible by 2 but not divisible by 3. And how many states? 6 states. So I hope you got the answer correctly, but designing DFA is not that easy. But you might be answered because of Maybe you multiply 2 into 3, but exactly you are not aware how that is 2 into 3 happened, right? So that's what I am showing here. Everybody got? So this motion is number of A's divisible by 2, but number of A's is not divisible by 3. Everybody got this answer? But doing composition will take much time. 2 states, 3 states, 2 into 3 is 6 states, right? So this takes much time. But when you analyze this problem carefully about the A's only, if you don't have the B's, right, the B self loop will not be there. That's it. The same problem, B's are not going to take care the count. That's why B's are self loop everywhere. So assume here B's are not there, analyze very quickly just over the arithmetic progression concept. If it is only A's, whatever the answer is there, with A's and B's also same answer. Everybody got the concept? But in the exam you have another shortcut. Just assume that you don't have the B. Just find out how many states. You will get definitely 6 states, because that sequence is very easy to identify. Then for that, how do you design the machine? Maybe you answered, everybody answered what? The 666. But the reason is somewhat difficult than what you answered the number. Okay. Okay, 37 is done. 38. Oh, what is it? Everything is given, only you need to identify. I think everything is given, right? I think it's so easy for you. Then W ends with the substring 0, 1, 1. W ending with 0, 1, 1. Simply they asked just ending with 0, 1, 1. Which option is guaranteeing ending with 0, 1, 1? And these two options blindly you can delete, because the self loop is 0, 1. This cannot guarantee ending with 0, 1, 1, right? You can have any number of ones at the end. This one having the self loop 1 means I can have 1000 ones at the end. That cannot guarantee ending with 0, 1, 1. Now these two options you need to observe. Only observe. In the exam I am giving a shortcut. Look at the last 3 symbols from the final states. That can make you sense. Look at last 3 symbols. Last 3 symbols from final. So you stay at final, and because you are asking about 0, 1, 1 ending, so from here just look at last 3 symbols who are coming here. So look at this path, 0, 1, 1, 1. Another way from here, 0, 1, 1. Another way, 0, 1, 1. Another way, 0, 1, 1. You take last 3 symbols, any path is ending with 0, 1, 1 here. Now let's look at this path. Here, from here, this is the final state. Look at the last 3 symbols. 0, 1, 1, correct. Another path, 0, 1, 1, correct. Another path, 0, 1, 1, correct. Another path, 1, 1, 1, 1. So this path will not guarantee ending with 0, 1, 1. That's why this is wrong. Already I proved this one. From this final state, you cannot guarantee 0, 1, 1. You cannot guarantee 0, 1, 1. This, take any path that comes here with the last 3 symbols is 0, 1, 1. So in the exam also, you no need to design when the machine is given to you. Just understand the question properly and analyze and cross check it that option A is right. Okay. Everybody, this is the shortcut. Look at the last 3 symbols by staying at the final. All the paths you should look at, not just one path. Look at who is coming. This path is 0, 1, 1. This path is 0, 1, 1. And this path is not 3 symbols anyhow. 0, 1, 1. This from here is enough. 0, 1, 1, 1. Right? So everybody got this point? But here 1, 1, 1. So triple 1 is not guaranteeing you are halting at final with 0, 1, 1. Because your target is ending with 0, 1, 1. Whoever halts at final, they are halting with 0, 1, 1. If it is guaranteed, just look for the last 3 symbols at the final. From the final, the job is over. Everybody got? But practice it. It's very easy than, designing the 0, 1, 1. Designing 0, 1, 1 might take time for you. But observing the concept is so easy here. Valid strings are ending with 0, 1, 1. Whoever it halts here, they must end with 0, 1, 1. Doesn't matter which path they come. But who are halting here, they must end with 0, 1, 1. Everybody got the point? Come on. That was the easy shortcut. Come on, respond, yaar. 39. Question number 39. Oh, what is the question? Minimal DFA with the K states, okay? Which one of the following language must necessarily be accepted by minimum DFA with K states? Yeah, L is given. Then if this is having K states, who will be guaranteed with the K states? That's a DFA, right? K states in DFA. We will definitely have. That's L complement only. L and L complement both will have the same number of states. Who is the L complement? L complement is sigma star minus L. Here, who is the sigma star? As per the data, 0, 1 whole star. That's it. You need to identify who is here. That is A, option A. That's L complement. This is nothing but L complement. Correct. Everybody is good. $39. Next, 40. Oh, 40. Yeah, this is really a combination oriented question. Yeah, it takes definitely time. So if you are really taking the time, be careful, because the numerical type, you might be giving the wrong answer. So it should be done slowly. Number of strings of length 8. So this machine to machine, this number of strings will change. That's why you should work with the machine only. Okay. So 0/1 means 0, 1 basically. Now number of strings of length 8 accepted by the above automata. So what you do, so you need to do one thing, just number it properly first. A, B, C, D, E, F. Now your target is to reach F with 8 length. Now question is number of strings of length 8 accepted. Length 8, if you look at how many length 8, 2 power 8 means total 128 strings are there. Sorry, not 128, even it's 256, 2 power 7, 128, right? 256 strings are there. Among 256, how many are accepted here? That is the question. Are you going to verify 256 here? These 256 strings, how many are accepted? Are you going to check all the 256? No. So now the 8 length, you should have some technique to go to the final. To go to the final, you need to have a technique. So to reach here, first look at how many ways you are going first. 1, 2, 3. There is a one way. So one way. 1, 2, 3. This is the second way. Third way, 1, 2, 3. Other way, this way. So 4 ways only there, I guess. 1, 2 and 3, 4. That 4 ways you are going to look at. After going here, the combinations are going to give you result. So first 4 length is going to be complicated, but after 4 you need to look at. So anyhow, to reach there, so this is a 3 length only, not 4 length, but this is the 4 length. So don't assume every string is accepted wrong, right? Every string is accepted wrong. But look at what's going to be, what 3 lengths, what 4 lengths are accepted. So now from A, just you need to focus on all the combinations. 0, 1. 0 you will go to B and 1 you will go to C. First expand the first one, then find out all the answers this side and all the answers this side. Okay, don't do parallelly, it will take much time anyhow, right? 0 will go to D and 1 you will go to E. And from D anything, either 0 or 1, 0 or 1 you will go to F. So done. Then stop there. You can make a combinations to get the answer for the 8 length. So look at the question. If it is not 8, then definitely the answer is going to be difficult for me right now. Okay. If it is some other length, then you should be careful. Now after that you can make the combinations. Now 0, 1 you will go to E. Once you go to either 0 or 1, again it's going to be final. So now we have, no issue with the D and E. So going to here only the difficult, right? So this is going to be 3 length. This is going to be 3 length. Oh, all are going to be 3 length. So any idea here? 2 power 8, right? All are going to be accepted. But if any time you see, instead of going this one, if one goes to F and something like, if it goes to different length, then you will be having an issue. So you take any length, it's going to be 3 only. 1, 2, 3, 4. But if you see some are 3 length, some are 4 length, this idea, the formula going to be the wrong. So be careful. This question, even though looks easy, But in analysis, if they change the data in future, so don't assume 256 strings are accepted. As I'm saying, all the paths may not come with the same length. Some might come with the 3 length, some might come with the 4 length. Then this analysis needed. So this analysis right now, is it required? Not required, because you understood 0 1 0 1, every path is having just 3 length, and after that everybody is accepted. So when you go for next, how many? 3 length, right? 4th length, 5th length, 6th length, 7th length, 8th length, you will be in the final state only for all of them. For all the paths after 8th length, you will be at final. So it's indirectly set off all 8 length strings. That is the question indirectly. How many 8 length strings are there? 256 strings are there. That means 256 strings are accepted. So getting my point? Right. So you are able to answer it, right? 256, 256. But do not assume all the questions just 2 power 8. Sometimes there is a one question and restrictions are there. Then out of 256, some strings will be accepting, some strings will be rejecting. So always analyze the question that every path is going with a 3 length here, and before 8 length only you are reaching. So there is a one small conclusion. Before 8 length only you are coming to the final. That's why every 8 length is accepted, because of only this self loop. If we don't have this self loop, right, we are gone. It would take much time. Because of only that self loop, we are lucky, and before 8 length only you are coming to the final, and remaining always you will stay in final. That makes every 8 length string is accepted. But in general, it may not happen. It's lucky, because whenever you always remember one more shortcut, guys. Whenever you have, whenever you have a big number, right? Then the concept is so simple, shortcut oriented. 8 2 power 8. Like in the previously, there is a bijective functions concept is there. How many bijective functions are there? 5 element to 5 element. That's going to be 5 factorial. That is a 120 bijective functions. Again 120 states we got. So whenever the number is so big, looks complicated, then the makes so easy answer most of the times. Okay. So that is also one shortcut you can relate in the exam. Not here, but you can relate in the exam when you are not able to conclude. Yeah, this much bigger data, how will you read 40 questions? I did not understand what Aditya is saying, right? Is it TOC question here? Can somebody answer the Aditya question? In which year it is? 1822 gate question? Okay, 41. Take small break. Who will read this bigger data here? Okay, take these. UPSC में आ गया. Okay. Okay, again take the small break. Yeah, every 20 questions we take a small break, so that we can relax for 5 minutes. So this 41 you try to analyze. I think this is a numerical type question. You have the data, options are there. No, we have options. So please try to analyze this question. We'll take some break, 5 minutes, 5 to 10 minutes. I'll be back by 11:15 or 11:20. Kiran, no idea when will it go. Depends on till as many as live are there, then I will be continuing the class. Okay. My aim is to take the class as long as possible. But if people are busy and you wanted to go sleep, then I will stop anytime as per your requirement. Because this class is for you, right? Okay. Yeah, I need to charge my phone, so it's shut down now. Just switch off. Okay, see you then within 10 minutes. guys, is audio and video clear right now? Yeah. Yes, clear. सर्वर प्रॉब्लम ना, अभी तो क्लियर होना चाहिए यार. पीछे से क्यों आ रहा है यार, मैं चेक कर रहा हूँ. So it should be clear now. Yeah, voice is clear. Okay. बफरिंग हो रहा था इसलिए मैं स्ट्रीम स्टॉप किया था, राइट. नाउ अभी ठीक होगा. ओके, नो बट स्टिल ए लिटिल लैग. ओके, एक बार यार एक बार बंद करके बंद करके एक बार ओपन कर दो, वो क्लियर हो जाएगा शायद. ओके, देयर इज इको, ऑल क्लियर. ओके ठीक है, क्लियर होना चाहिए यार. तो अभी तो स्टार्ट हो गया. मैं भी एक बार रिफ्रेश कर लेता हूँ यहाँ पर. ठीक. Okay, the question is looks lengthy but it has very simple meaning. यहाँ पे क्या था, सपोज वी वांट टू डिजाइन ए सिंक्रोनस सर्क्यूट. ऑफकोर्स ये क्या है यार, ऐसे ही होता है टीओसी का. ऐसे नहीं है एक सब्जेक्ट के रिलेटेड है ये. डिजिटल पता है ना आपको, यू नो द डिजिटल, राइट. डिजिटल एंड टीओसी कॉम्बिनेशन है. दिखता है क्वेश्चन पूरा ये डिजिटल की कॉन्सेप्ट रिलेटेड है, बट द मोर एंड मिले मशीन्स आर फ्रॉम द टीओसी. तो टीओसी में क्या है, फाइनाइट ऑटोमेटा वी कैन आल्सो हेल्प्स टू डिजाइन द डिजिटल सर्क्यूट्स, राइट. एक एप्लीकेशन है, तो उसकी वजह से ये देखो कितने कॉन्सेप्ट्स होता है. टीओसी एंड डिजिटल होता, टीओसी एंड डिस्क्रीट मैथ्स है. और मैथ्स कोई भी मैथ्स भी हो सकता है, कभी कभी मैथ्स है. और कभी कभी आपको क्वेश्चन दिखेगा टीओसी एंड कंपाइलर रिलेटेड, है ना. कभी कभी टीओसी एंड एल्गोरिथम्स रिलेटेड. देखो मतलब टीओसी एक जगह में नहीं यार, बहुत जगह में टीओसी का एप्लीकेशन है. वैसे रिस्ट्रिक्टेड नहीं है ये चारों कुछ सब्जेक्ट की, हर सब्जेक्ट में टीओसी कॉन्सेप्ट आ सकते हैं, राइट. it's possible that yeah, TOC is, it's real time. You can use, in general, in daily life also this TOC concepts, but you should know how to apply it. Yeah, कोई आंसर बोल रहा है यार. D is that D? Let's see. In the strings of zeros and ones, what it has to do is it produces another string. कोई input दिया, output produce करेगा, but it replaces the first one in subsequence of consecutive ones. ये double consecutive ones स्ट्रिक्ट नहीं बता रहा है, सबसीक्वेंस ऑफ कंसेक्यूटिव वंस. मतलब वंस आ सकता नहीं आ सकता, बट एक वन आया सीक्वेंस में, तब ए वन को जीरो से रिप्लेस करेंगे. एक देखो इनपुट सीक्वेंस है, या वन आया, नेक्स्ट वन तो नहीं है, बट ये सबसीक्वेंस स्टार्ट हो गया, तो वहां पर जीरो से रिप्लेस किया हम. देखो ये वन को जीरो से. और ये कंसेक्यूटिव वंस में फर्स्ट वन को, सिर्फ फर्स्ट वन को ही करेंगे. मतलब हो सकता है वन के बाद एक वन होगा, जीरो वन होगा, जितने भी वंस होगा चलेगा. बट ये देखो ये वन है, ये वन पर हम यहां जीरो रिप्लेस किया, देखा. तो ये है कॉन्सेप्ट. सॉरी यहां पर एक और है यार, ये वन है, ये वाले है. पोजीशन थोड़ा बदल गया, राइट. थोड़ा यहां से स्टार्ट हुआ, तो याद रखना ये थर्ड पोजीशन जीरो रिप्लेस किया. तो जो भी है, ये जो वन इंपॉर्टेंट है, फर्स्ट वन, ये फर्स्ट वन, ये फर्स्ट वन, जो कंसेक्यूटिव वंस की जगह में, राइट. तो ये है इनपुट सीक्वेंस और आउटपुट सीक्वेंस. समझ लेना. तो कॉन्सेप्ट ये समझ में आना चाहिए, अगर कंसेक्यूटिव वंस आ रहा है तो उसमें फर्स्ट वन जीरो से रिप्लेस करेंगे, बस इतना है. द फर्स्ट वन विल रिप्लेस विद द जीरो, रिमेनिंग वंस वी डोंट डू इन द सेम सीक्वेंस. ओके, तो ये है प्रॉब्लम. अब इस प्रॉब्लम में क्या है, व्हाट इज द क्वेश्चन इज, रीड इट क्विकली. मिली मशीन इज अ स्टेट, यार मिली मशीन बार में बता रहे हैं, तो हमको पता है मिली मशीन क्या है. मिली मशीन क्या है, द एबव मेंशन सर्क्यूट कैन बी डिजाइन्ड एज टू स्टेट मिली मशीन. सो वो भी इंट दिया, ये इसको 2 स्टेट में डिजाइन कर सकते हैं हम. वी कैन डिजाइन इन 2 स्टेट्स. द स्टेट्स इन द मिली मशीन कैन बी रिप्रेजेंटेड यूजिंग बुलियन वैल्यूज 0 and 1. तो स्टेट का नाम भी रख दिया 0 और 1. ओके, और क्या, वी डिनोट द करंट स्टेट. वो करंट स्टेट, और करंट स्टेट किससे बोला? S. नेक्स्ट स्टेट T से बोला. और नेक्स्ट इनकमिंग बिट B है, और द आउटपुट बिट क्या है? Y. तो ऐसे होता है ना, एक S स्टेट है, एक T स्टेट है, और ऐसे ही बताया. और जब भी यहां जा रहा है तो B क्या होगा? इनपुट होगा, Y क्या होगा? आउटपुट होगा. वो ऐसे वाले सिंबल्स से रिप्रेजेंट करना पड़ता है हमको. अज्यूम द इनिशियल स्टेट ऑफ द मिली मशीन इज 0. तो 0 1 है ना, उसमें एक स्टेट 0 है और वो इनिशियल है, और वैसे भी फाइनल स्टेट तो नहीं रहता. व्हाट आर द बुलियन एक्सप्रेशंस करस्पॉन्डिंग टू T and Y इन टर्म्स? तो ये याद रखना. यू रिमेंबर दैट S इज द प्रेजेंट स्टेट, T is the next state, B is the incoming bit, Y is the output. So ये 4 symbols you just try to remember, then we'll think on what is it. So we have what? Present state. What? Milli machine, what is the concept? From present state, by reading the input, we'll get some output, right, as B, and we'll have a next state, whatever it is. Just make the relation. The next state, and you have the Y also, right? So this Y you can keep very quickly, immediately or not, that's your choice. You can also keep if you want here itself, Y, and then what? T. So S is the present state, T is the next state, and this is the current input, and this is the current output. Now we will make some table how we have the states. The initial state is what? 0. Other state is 1. Now you think about it. Whenever first 1 comes, we will replace with 0. But before that, any number of zeros will keep same. Right? 0 is coming, 0 is coming. We'll keep the same. We'll keep the same, right? We'll keep the same. But when the first one comes, we'll replace with 0. So we'll remember that. When the first one comes, we'll replace with 0. But remaining ones we don't do. We don't do anything. We'll keep the same. We'll keep the same. That's why we went here, and from here everyone will keep 1 only. But after that, any 0 comes, it interrupts the sequence. So then we'll come back, because 0 will keep 0, but we'll come back to remember we are beginning again. From here, again 1 comes, we'll replace with 0, and any number of ones will keep the same. If 0 comes, we'll come back, and any number of zeros will keep same, and any 1 comes. So this is the actual problem what they have given. So have you understood this problem? Quick. Have you understood this problem? Guys, yeah. Have you understood the problem? I'm going to solve this question according to the data. So this one we need to represent using this table. If you are able to do that, then you can make a relation as per the given options. Understood? Now just fill it. S is the present state is what? 0. From 0, by reading, let's say 0. By reading 0, you got the output 0. You are going to which state? Same state. So first is clear. This one from 0, by reading 0, I kept replaced with the output as 0, or produce output as 0 and going to 0. This one. And again from 0, by reading B is the incoming bit 1, and we are producing 0, and we are going to the next state is 1. You got this point too, right? This one. So 2 outgoings. So for 2 outgoings, 2 transitions, so 2 rows is over. Next from 1 by reading 0, we are producing 0 and going to the 0. Done. That's it. Okay. Next from 1 by reading 1, we are producing 1 going to 1. I hope done all 4 rows. Now this one you need to match what is exactly happening here. So now the first option, T, is it exactly like a B? 0 0 1 1 0 0 1 1. So T is equal to B is matching. That's fine. Now Y is it going like S B bar 0 1 bar? 0 bar is 1, 0 1 is 0, fine. And 0, that 1 bar is 0, 0 0 is 0. Next 1 0 bar is 1, 1 1 should be 1. So here is this failing, is this failing. Everybody got? Y is not looking like SB bar. Here you can see SB bar means GB bar is 1. So 0 bar is 1. 1 should be 1 here, but it is there 0. So this row is actually not satisfying. Go to the next one. So T is equal to B already we know. We will just go here and check. T is equal to B, we already know it. Now we'll check this. Y is equal to SB. Y is actually, is it AND of this two? 0 0 0 0 1 0 1 0 0 1 1 1. So this is matching. So directly you can choose it. Because unnecessarily going for other options, we already know one thing, then take that as a reference and do it. So remaining you just cross check, definitely they should be failing. Everybody got? Just please cross check that other two options. Just check these two options, which will take time down out. If it is MSQ, you should do that, but is MCQ, I know I can go to the option D directly. Everybody got? Okay. The question number 41. Okay. You may ask, sir, why you are taking this much, this many breaks. Actually, I never take breaks during my class, but I'm doing the multiple things in a day. From morning, I need to work till evening, then taking the class continuously really challenging for me. I'm only coming because committed to the students, and we need to fulfill the student promises what we make, right? That is why I'm just taking the breaks to avoid any kind of misunderstanding while explanation. So please do that. Next question, 40, 41, 42. What is this 42? Which of the following regular expressions correctly represents the language given in the given finite automata? Can you do it? Meanwhile, I'll have a tea. Okay. Are you able to see the expression D? You are able to see? I can't see the D. How can you see the whole D? People are coming with the D answer. That are seeing already D. Oh my god. I can't answer D because I can't see the whole option. Do you know what is there here? It's fine. Really challenging for, don't know how you answer it. Okay. So I'll keep here, then later on I will move it. Fine. Now you can see the whole data, right? So what is the data you have? Right? Just by looking at it, you can answer it. So this side, this is the final state and this is the final state. Either you will alt here or you will halt here. So what is the conclusion from here? What is the conclusion from here? So from this state, I can alt here, or I can come back, I can halt here also. So there are two paths to the final now. One path is go this way or this way. There is another path, you can go like this also, or another path you can go. Even there are many paths apart from two paths what I have tried, right? Memorizing the answer. Yeah, that's correct. How A plus B whole star? A plus epsilon is not accepted here. Epsilon, is it accepted? No, right? So how can you say A plus B whole star? No, yeah, no. Now let's focus on the problem here. Okay, so you try to convert it, but I don't know how to convert it directly. So we'll think about possibilities. Now this option is talking about A, B star, B, A, B star. Is there any such thing sequence here? This happens only when you have the sequence like this. There is a cycle here. In that cycle, you see, there is a possibility. Assume this is a reference, right? A you may accept. How can you come back to A? B star, B, A. So look at that. B star, B, A. There is another path, B star, B, A. So after going to A, there is a path B star, B, A. This can be repeated any number of times. There is a one way that you can make whole star if you want to be here. But if you want to go there, there is another path comes. So this kind of whole star should be there. But in the option A, there is something like A B star B A B star. That means what he is trying to say, after A B A, one more A comes, I don't have a path, he is trying to say. But here the same path, A B A double A, you have a path. For this you have a path, but if you get one more B here also you don't have a path. So there is an issue. But every string there is a path here. See, A B. See, A B, and what is this? This is a B you have, and double A, double A, double A, and double A you don't have a path, looks like. Okay, so now there is an issue here. It's not the DFA. First thing is, did they mention DFA? No, it's just NFA. Correct? Okay, let's go to the, anybody got the answer? So I'm going for the general approach because I'm not able to conclude by looking at the machine, because that's what always we do. Is there any possibility directly by looking at? Okay, another way is, first technique is, okay, let's see how I approach basically exams. First technique is observe. Oh, observing you are not able to understand. Second technique is options elimination. Options elimination. Even if I fail that thing, the third thing is general approach. General approach will never fail because we'll convert using the algorithms. General approach using algorithms or using any approach that you are following. But which is always easy? First, always you spend the time because it might be possible within a minute. But when you go for the options elimination, which might take, this might take approximately 1 minute. So I tried that way, is there any direct approach that I can do it? Looks like, I can't do it. The second one, options elimination, will take 2 to 3 minutes. But this is also very famous method. But this may take general approach maybe 3 to 10 minutes, depends on how quickly you apply it. Getting my point? So always this is an observation. Anyhow, we understood this question is not easy by looking at it. Anybody got any observation directly? No, right? You're not able to options, you're not able to match options by looking at it. So what you do is, we'll go to the second option to eliminate. So now we'll try to eliminate. What is a string you can accept here? A. What is another string you can accept? B. So now we are trying to get the strings. A accepted, B accepted. What are other strings? A B star accepted. What are other strings we have? B A star accepted. What are other strings? A B star B. Even you can write the many paths. A B star. Just take some paths. A B star B, and then take this path B A star. If I take the same path, then A B star B A B star. And from here also you can take this way, and this way is B A star A B A star, something like that. And this can be repeated, not just like this can be repeated. Remember that this can be repeated. I'm just taking one path. This can be repeated basically. Okay, you can repeat them. I'm not doing that, but you can repeat them. So from here, B A star A, you can go that side. A B star, even B star accepted. Then again B. Okay, just check the stars, because stars might go in wrong answers sometimes. Okay, stars I'm ignoring. I'll just take these paths up to here. Okay, another path, that is I'm writing B A star A B star. Okay, just this much enough, I guess. Look at this possible combinations to get right. Anybody got the options? Somebody answering A B star, something like that. So A everywhere there. A single A accepted here. Oh, that's going to be the A is must here, B is must here, A is must. So option A is deleted because single A itself, here B is there, here A, B is must there. So single A failing, deleted. And here A, B is must, here B is must. But in both of them, single A is not there to accept. This A should be accepted. Here single A is failing. Look at elimination, how quickly. But no need to write in the exam. Just think about that way. Why I'm writing, just need to think about that many ways to get the eliminations. And this one, single A, here A, B is must, here B, A is must, whole star means epsilon. Yes, here you get single A. Oh, here you get single A. Single B you get. A, B star, check A, B star. Do you have A, B star here? No. Here do you have A, B star? No. Oh, how do I get A, B star? Is it possible? Single A, B star, A followed by B star. A I can get here, single B I get here. If I don't have a B, I can go there, single B followed by any number of B's. Oh, here. Oh, single A I get, single B I get, remaining B's I can get. So this one I am getting B A star. B I can get here, single A. If you want more A's I can get here. That's also possible. Next, AB star, BB A star. See that, AB star, B, B, and then if you don't have A's, AB star, B, one more B. Oh, it looks like this one is a challenging now. Okay, so I'll just keep it because it's almost matching. Then I'll cross check to eliminate later. So B is deleted, B is deleted. Now C and D you need to cross check. So now when you eliminate two options, when you eliminate two options, when you have left with two options, how to eliminate? This is another shortcut for the exam. How to eliminate when we have two options, which is going to be very easy. See, I'm not going to look at deriving at all because what I derive I may not match in the exam. So I always focus on elimination first. If not works, then whole algorithm I'll apply to get some answer. Even that matches, God will help us. Okay, how to eliminate when we have only two options, only two options left. Anybody guess? Because now we don't approach this. Already two are eliminated. Now don't apply this technique. Cross checking is gone now. Don't do this at all. This is gone now. Cross checking is that elimination options only up to two. Once eliminated two, then this two, don't apply the same technique. Now you do what? These two are left. Cross check what string can make different for this two. Which string one is generating, other is not generating. That's enough. That's enough. Anybody? No B. What are answers here? See, are you able to understand? First two I have eliminated because they should accept A, they should generate A, but not doing it. We have eliminated it. Now these two options, how I do? Which one is the right? You can see which string is different. B, A, can they both generate? Yes. But what string can differ both? Look at the options. Here B star A, here A B star B. Here B A star is there, same. A B star B is same. And here A star plus B star. Here what is there? It's not A star plus B star. It is A B star. So here A star is there. What is the meaning of A star? Can you generate double A from here? So put epsilon, you can get double A. Can you get double A here? See that. The string I found, here you can get double A. Now, can you get double A here? Just check. Can you get double A here? Everybody? Can you get double A here? See that fast. B is coming, so you can't go to double A. Here A is coming, but B is there. After A, B is there. I can't get double A. Here, if you get single A, you can get another A from here, but you don't get a single A from here. So, here double A is there. Here double A is not there. Is there? Is not there. Now, this data is enough to cross check. Do you have a double A here? See, single A followed by no A. Here, oh, B is there, A is not there. That means here double A is not there. So double A here generated. Here not. What's happened? Sorry. Here double A not generated. Now, do you want to accept? No. That means option D is the right. Everybody? Exactly. There are many other strings you can take. Not only double A, you can choose other string. Why I'm going for a single simple one? Because two length is very quick to get it. Epsilon, A, B, double A. That's what I got the double A conclusion. Okay. Everybody? A, B star. Okay, that's very big expression. A, B star. Here A, B star you can't generate. Okay, A, B star. That's possible. Here A star, here A, B star is there. Yeah, you can see AB plus here A star. Okay, just understand, without a B you can come here, with B you can go there. So it's a possibility there. That's why I'm not going. Have you seen? So this kind of questions, this kind of questions could take much time, but there could be, your own analysis for this. Very sorry. So let's keep this way only. Got it? So this is another question where you may take much time to analyze. I don't know how the people answer it. They might be, having their own shortcuts. Whenever I ask the question, they answer D, 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 D. But have you seen how difficult to analyze the data to get that answer? Okay. If I want to say the answer is D, I could do that, but I'm not doing it. In all my explanations, I never do that. I know the question and I know the answer. How the student should approach the question, that is what I'm trying to analyze, and I'm struggling to explain the way the student need to understand. Right? I really wanted to answer the question, everyone. Then you already have the answers for every question. I can go to the answer directly, but that's not the right approach to do, to explain. Okay? Everybody? Ardent's lemma, यार किसको पता यार Ardent's lemma use करना के? How do you know that Ardent's lemma using you will get the same answer? Because Kleene method is there, straight elimination method is there. You don't know which one to apply to come up with the right answer, right? In the exam, you don't have that much time. The third technique, when you fail even elimination, the third technique is using algorithms. Use elimination, use Ardent's lemma, use Kleene method, then don't know whether you get the answer or not. Correct? So remember, whenever I keep the 3 stars, when we are taking much time, that means that questions can make you some trouble in the exam. Right. So always understand. So with this, we have understood how the questions are happening in the first chapter, right? Finite kaise type ki questions aa rahe, sabko samajh mein aaya hoga, right? Mostly where you find the difficulty, like during regular expressions most of the time, right? With the finite automaton, very less difficulty. Only the problem happens with the regular expressions. If you see the questions, right, so many regular expressions so far, not 1, 2, 3. Almost every year one question you may see in the exam. Mostly you see the models like even number of ones, odd number of ones, like containing 0011 or containing 00 and 11, something like that, ends with something. These kind of questions are more popular for the exam point of view. Even second symbol from ending for the number of states. Analyze when you solve these questions, right? Just go back what was happened to all the questions. Just analyze them properly. Okay. 43. Question number 43. Okay, this is about undecidable chapter here. It's not this context-free grammar. It's the last chapter, but it's including all the concepts here. Okay, first option is about all the questions. Which of the following are decidable? It's directly last chapter, but unfortunately it came in the first. Okay, but anyhow, we can discuss in the last. But do you know anything about decidability now? Somebody answering it. So let's see. Whether the intersection of two regular languages is infinite. It means is regular 1 intersection regular 2 equal to infinite language? This is the question. Is this same as, can you conclude this is same as is regular language intersection infinite? Is this same as infiniteness problem? Finiteness, infiniteness. Regular intersection regular is always regular. So this is nothing but regular only. Is regular infinite? That means is that finite parameter accepting infinite language? That you can do two ways. Either you can use dependency graph, or you can use, if you have a DFA for this, check do you have any loop other than the dead state. If you have a loop in the DFA, that is accepting infiniteness. If you don't have a loop, no cycle, no self loop, except dead state I'm talking about. Dead state may have, that's not an issue. So if you don't have any loop, that means it is not infinite. Okay, so that you have an algorithm, right? Algorithm exists. Algo means what? Algorithm exists means what? It's a decidable. Decidable, another meaning is we have an algorithm, means that is a decidable. Okay, whether the given context free language is regular, it means I will give you some PDA. Is it accepting regular? That's the question. Is CFL or is PDA accepting regular? Better to say that way. Is CFL equal to regular? So this is given. Remember that. And that CFL, is it accepting regular? Can you do that? Is given CFL given CFL same as regular? How do you know that? Right? It's very difficult to check, because the regular property, you want to check the regularity for the PDA, you don't have any algorithm. Given PDA accepting regular or not is definitely a difficult question. You don't know algorithm for that. But how do I know that no algorithm? because it's an undecidable question completely. What are other ways to ask? I will give you PDA. Is the language accepted by PDA is regular? This is the best way to write. The above one is not proper to analyze it, but this is the best way. I will give you PDA. Can you tell me that PDA accepting regular? But I know PDA always accepts CFL. But how do I know that PDA is accepting regular or not? We don't have. But PDA accepting finite or infinite? We have dependency graph. We'll see that later. Okay. We don't have any algorithm for this. Okay. Whether two PDAs accept the same language. That means is language accepted by PDA 1 same as language accepted by PDA 2. I'll give you two PDAs. Can you check, are they accepting same language? Again, equivalence. This is called as equivalence algorithm. We'll take the table at the end to understand this concept, not now. Okay, equivalence. So this problem is also no algorithm. Whether the given grammar is grammar only, right? You can ask whether the given grammar is context free, whether the given grammar is regular, whether the given grammar is context sensitive grammar. Grammars you can check. You're not asking language, only grammar. Is that given grammar is G context free grammar? That is a question. Is that given, is given G context free grammar? Oh, given G only, right? I'll just check the every production I'll go, I'll only check LHS because LHS is exactly non-terminal. Then answer is exactly one non-terminal, that too, one non-terminal. That means that is a context free. In every production, LHS is exactly one non-terminal, RHS, anything is fine. So that is algorithm. What I am showing you, that is an algorithm. I'll take every production from this set. I'll just look at LHS. Is it exactly one non-terminal? So algorithm exists means decidable. So 1 and 4 are decidable. Remaining all are not. This 2 and 3 are undecidable. Yeah, checking regularity for CFLs is undecidable. Right? But remembering 1 and 4 is not difficult. We have a shortcut for that is infiniteness for regular, equivalence for PDA, regularity for CFL, and these are the trivial questions. What is that grammar? Okay, grammar type only you are doing it, not what language generated by grammar. There's a difficult one. Language generated by grammar, can I say context free? That is undecidable. Look at it. Whether given grammar generating context free language, that's a difficulty. This is not generating. Grammar type is context free. That's why we are able to say it is decidable. Small change. Whether a given grammar generates context free language, undecidable. So one small change, right? One small change can make undecidable. 43. See, our undecidability should be coming at the end, but okay, that's fine. We discuss decidability at the end only, not now we are. Okay, forget about that. So come to the next one. Given grammar means any grammar. Yeah, type 0. Normally you can't write anything other than type 0, right? Yeah. No, iswar. This is not the question generating. What is it? You are only taking it as generating CFL. No, whether a given grammar is context free, means I'm asking, is that context free grammar? I'm giving you grammar. I don't know what grammar I'm giving. Is this grammar context free? Means I'm talking about grammar, not the language. Is this grammar generating context free language? Then this grammar you can take anything in the world, unrestricted. But right now I don't know this grammar. Can you tell me this grammar? Then that is decidable, right? Can you tell me type of this grammar? I'm not asking what language generated by this. That is undecidable. Can you tell me this grammar? Is it regular grammar? You have an algorithm. Is this context free grammar? Algorithm. Is this context sensitive grammar? You have an algorithm. Because you have the rule to check. Just take the rule. Don't understand what it generates. Okay. But when I ask, is this grammar generating context free language? Then that problem is undecidable. Okay. Only type I am asking, right? Is that grammar context free? I am not asking, is the grammar generating? Both are different. Grammar is context free. Grammar generating context free. Both are different. Just understand the statement properly. Okay. So this is one of the most difficult in TVC because the line, when I change the word, the meaning changes here. Meaning changes here. Okay. Yeah. Good. So one small change can change the data, right? One small change can change the meaning too. Next one. Which one of the following statement is true? Come on guys. If anybody joined now, please don't forget to like the session. Context free only, right? Just we are asking which of them is context free. I not equal to j, that means I less than j or I greater than j is a DCFL. Let me write, forget about CFL, let me write the exact answer, DCFL. I is equal j, DCFL, and I is equal 2j plus 1. 2j plus 1 means almost twice, right? So this is equal to 0 power 2j plus 1, 1 power j. So it's very easy to write, right? So this is almost twice, just first 0 you can skip, and then remaining every 2 zeros you can push 1 0. You know the logic, right? This is also DCFL. And I not equal to j. I not equal to j means what could happen? I not equal j, I not equal to j. What should be the reason? Not equal to 2j means it's not going to be twice to the number of ones, right? Can you do with exactly the same? I not equal to 2j. What could be that possible? It could be possible I less than 2j or I greater than 2j. This is also here, you already know, right? This is a DCFL, right? I less than j or I greater than j. Same way, I less than 2j or I greater than 2j. So this would be happening. This would be happening. Okay, now the question is what? Anybody answer correctly? D. Oh, great. Even they ask, of course, DCFL questions are very less in the exam. Also, you are lucky. Most of the questions are about context-free languages. Very rare questions about DCFLs. Are you clear my point? Theoretical questions mostly. So remember that. Focus on CFLs, because even though I explained DCFL just to make you, in future they may ask about deterministic context-free language, then you should be having awareness. So L1 to L4 all are DCFLs only. So definitely they are context-free languages. Okay. Yeah, all are answered correctly. That's good. 45. Which of the following grammars is free from a left recursion? So it's a common to the compiler also. Compiler also this data can be asked. It's a common question to compiler and TOC. Okay, free from left recursion. Who is not having the left recursion? That is the question. So can you find out quickly? In 2010 they asked, do you have a left recursion here? A is here. A is here. Is it left recursion? Oh, then you can't choose it. Do you have any left recursion here? Just see that A is here. A is here, but there is a connection S. So A to S, S to A, it is also left recursion. And can you, do you have a left recursion? S depends on A and B, A depends on B, but B depends on no one. So this is no recursion at all. And look at this one, S depends on A, S depends on B, that's fine. A depends on B, but B depends on A. So A is again getting A from the B. So B is giving you A somehow indirectly. So this is having left recursion. Very easy. Even B is also having a B as indirect left recursion, but just find out one left recursion, that is fine. You may have multiple left recursions, we don't need, right? B is the right answer, correct. Hardly takes 1 minute if you observe quickly. Observation only needed for that, right? 45. Now this is 46. Yeah, now onwards, we will not have much effort because most of the questions are theoretical except a few questions. Come on guys, 12 is crossed. L1, L2 and L3 are given. Which of the following statement? Oh, not true, not true. PDA can be used to recognize L1 and L2. Is this true or not true? You need to identify. L1 is, first let's talk about what is each one. L1, can I say 0 star 1 star? Okay, it belongs to n, right? So if n starts from, let's say n starts from 1, then this is going to be 0 plus 1 plus, if it is not including 0, if it is including 0, 0 star 1 star. Anyhow, this is the regular. So I'm not mentioning what exactly language is, but it is regular. It could be possible 0 star 1 star, or it could be 0 plus 1 plus, depends on what n is having. N is not including 0, then the answer will be 0 plus 1 plus. Next one, PQ belongs to n, P equal to Q. So this is same, right? 0 power P and 1 power P. So this is the DCFL, because both powers are going to be same. Next one, PQR. Oh, all the powers are same. Then this is not a CFL. This is a context sensitive language. So exact strict answer I'm giving. Okay, I'm writing CSL means I'm saying indirectly which is not CFL. Okay, DCFL I'm writing means indirectly here DCFL but not regular. So I'm answering strict one. Now PDA can be used to recognize L1 and L2. Yes, this is a true, but we don't want true statement. We want not true. L1 is regular language. True. We don't want this. All the three languages are context free. False. We want this false statement. Not true means false. So C we will pick. And D, Turing machine can be used to recognize all the language. Yes, true. Turing machine is a more powerful machine, right? So we can choose our Turing machine to accept all or to represent all of them. So only the option C. Yeah, most of you answered correctly. Great. Yeah, L3 has two comparisons and famous context sensitive language, right? When you have 0 power n, what? 1 power n, 0 power n. This is a very famous language. Not only this, mostly we write like 0 power n, 1 power n, 2 power n. This is the normal way we write A power n, B power n, C power n. When you have three symbols having same power, then that makes, of course, it's not the same symbol. That is also, remember, context sensitive language. Okay, question number 47. See, not going to take much time. We will only analyze as we are not, learning the whole subject right now. Okay. This is one of the interesting question. Let's wait for the answers. Okay, if you know the answer, please do it very quickly. Then we'll just analyze it, how to answer in the exam. 47. M plus N is equal to P plus Q. That means this sum is equal to this sum. Oh, no, sorry. This sum is equal to this sum. Okay. And another one, sum only, not comparison, right? M is equal to N and then P is equal to Q and P is equal to Q both. M equal to N equal to P. Oh, three symbols are depending here. P not equal to Q. Oh, that makes another difficult one. Okay. Mn, multiply these two symbols to get sum of these two. Okay. Who is having the answer? Let's see. How do you get the right answer here? I don't understand. If I am the student, I am solving this question and I might be having the difficulty in first option itself. What is this first one? Anyhow, you have two, so you might be choosing. So there is a one way. When you are not clear about 1 and 2, then other two will definitely help you. Because of M equal N equal P and P not equal to Q, so they are talking about context free, right? So this is another way, elimination. Know what you know, right? Understand what you know, and you can take the help of this two and to choose the options. So it's a very easy, one you are not able to understand, leave it. Two, you are able to understand M equal N and P equal Q. M equal N you can use and P equal Q you can check. So this is basically DCFL. Okay, definitely you can say CFL, okay, not an issue. Very easy. One, I assume that we don't understand, leave it. Then 3, you have all the 4 comparisons. See, M equal N equal P means this 3 should be equal. P not equal to Q means Q is not equal to P, Q not equal to N, Q not equal to M. Indirectly, all the 4 are depending each other. So this is definitely context sensitive language, never be context free. And Mn, multiplication, impossible in the context free. And this is also context sensitive language. Now, when you look at this, you're talking about context free, right? Here 3 and 4, wherever you have, eliminate. 4, eliminate. 3, eliminate. 4, eliminate. That means 1 and 2. So you are so lucky, the first one is going to be CFL. But this assuming, if I ask directly this one, you might take much time to analyze. Everybody? Yeah, you have an approach. What do you do? Push A's. When B's you are going to compare, right? M is this side, N is this side. Now B you will compare with A. B might be equal to A, B might be less than A, B might be greater than A. There will be 3 different paths you need to take. Of course, the deterministic maybe. Now B, if it is less than A, then A is might left, then accordingly you should follow that. If B equal to A, then C and D should be equal. This P and Q should be equal. If B is more than A, then B might be more. Then accordingly you should work. If N is more than M, then if that the P should be greater than Q. So somehow the logic will be connected here. So this is also CFL. But for this, designing PDA takes much time. Not an easy, but you can write the grammar very easily. Okay. Anyhow, understand, when you are not sure about the option, so wait, you have other three statements to help you. So that is how, people are answering directly B. So I am worried how you answered it. Okay. But you take it as homework and please analyze this question, how to write a context-free grammar, how to design a PDF for this. Okay. Question number 47 is over. 48. Some of the questions really challenging in the exam, but you don't need to worry much about, because other things will help you. Use elimination when you are not sure. Okay. Consider the following languages L1 and L2. Which one of the following statement is false? False you have to choose. So everything is about context free, no, right? Somebody asking recursive, somebody asking regular. Okay, let's find out. So PQR, oh, this is 0 star, 1 star, 0 star. Is it regular? Yes, we know it. And another one, P not equal to R. That is the DCFL. Only two symbols you are checking, right? DCFL. Now, based on this, you can conclude the options. Clear? You got the perfect answers. When you are not getting the perfect answer, assume it is a CSL. If you are confusing DCFL, assuming CFL. If CFL helps, fine. If not helps, then try to understand. L2 is a context free. Correct or not? They want false, right? So this is true only, right? True. DCFL means CFL only. L1 intersection L2. DCFL intersection regular. Definitely DCFL. Now they are only asking about context free. So you can choose it is a true. But we want to tick the false answer. Okay. Complement of L2. DCFL complement is DCFL. You can say recursive. This is also true. Complement of L1 is the context free but not regular. But its complement is regular because L1 is regular. L1 complement must be regular. You can say context free, not an issue. But don't say not regular. This makes a false statement. So we'll go for option D. Everybody answer that? Yeah, correct, Ishwar, correct. Everybody able to answer. This is an easy question, right? Not the difficult one. So you need theoretical knowledge to answer such questions like closure properties especially. Okay. You have specific languages. You can also use this closure properties whenever needed. 49. Whoa, symbols are what? 0, 1, C. Remember, your sigma is having 3 symbols. Question is about which of these languages are now the first time you are seeing DCFL. That's why we are practicing DCFLs all the time, right? Whenever the language DCFL, you should know about it. This is a 2014 question. They are asking DCFL, but most of the questions based on context free. Okay, first one, is it DCFL? Yes, because zeros you push, for ones you will pop zeros. Everybody, and WC W power R. WC, whenever C comes, you will start pushing, then remaining symbols you need to match with the W. You know that, right? WC, W power R. What do? You push all the symbols, whatever you see here, and W power R, you need to match exactly like A with A, B with B, because they will be in the reverse order. So stack order they will maintain. So this is also DCFL, you know it. But this is only the CFL, which is not a DCFL, which is not DCFL, one of the famous language in CFL but not DCFL, right? W power R. So anybody answer? C, everybody answering. Is it right? Only L1 and L2 are DCFL. L3 is not a DCFL. That's correct. C is the right one. Correct. Okay, question number 50. And look at when did they ask it. The 2015, and very rare questions, that is they give a PDA and they ask the explanation. Very rare questions. Remember that? This happens once in 10 years like that. It's not happens regularly, like every 5 to 6 years or 10 years you may assume one question happens. In whole 10 years you will see 2 questions max. Okay, but you need to understand what is this PDA does. Okay, can you read the question? Okay, I'll give the time for 2 minutes because this question is not that easy for those people who are studying from the textbooks especially. Okay, need some time to analyze for them. So can you do that? Read the question. I will read it, but read the question first. What is the data given to you? Because you need to analyze. You read the textbook, Z0 is the initial bottom of the stack, but here they could give something else. See, this is the Z0. This symbol is the bottom, initially top of the stack, bottom of the stack. This is the Z0. So they have used the bottom symbol to understand the Z0. So Z0 is not there here. Instead of Z0, you have the bottom symbol. Okay. And what else you have? You have the final state, you have the initial state. And what is this notation? First, focus should be on what is given, not what is the answer. Because always our approach goes to what is the answer. First, when you don't know the question, why do you worry what is the right answer? I never look at the answers first when I don't know it. But if it is eliminating, that's fine. First, the data is there this much, then you can't eliminate it quickly. So need to analyze the data, what they want it from here. Okay, are they asking to accept the string? Are they asking what they need it, right? Anybody answer? Let me check. Yes sir, PDA programming is rare, but 2015 IITK made again 2023. They are only making. Okay, all right. देखो ट्रांसिशन समझने आ रहा है आलम को. मैं ये तो कह रहा है ना, पहले प्रॉब्लम समझना, तो इसलिए टाइम दे रहा हूँ यार. डू समथिंग एंड टू अंडरस्टैंड एवरी वर्ड इज गिवन. एग्जाम में ये सारे जरूरत नहीं. आपको पीडीए पता है, काम खत्म. बट पीडीए आपको पता है क्या? वही तो दिक्कत है, राइट? चलो थोड़ा देर लिखना मत, क्यों है ना, समझ लेते डेटा क्या है. आपको पता है एनपीडीए मतलब बहुत सारे पैरामीटर्स होगा. हर पैरामीटर की डेफिनेशन दिया. क्यू सिग्मा और डेल्टा वहां पर है, और क्यू नॉट यहां पर है, एफ यहां पर है, और ये गामा है, और ये बॉटम है. तो नॉर्मली होता है ना क्यू सिग्मा डेल्टा क्यू नॉट एफ, वो 5 पैरामीटर मेंशन किया, बट नॉट सेम ऑर्डर. क्यू मतलब 3 स्टेट दिया यहां पर. सिग्मा मतलब 0-1 इनपुट सिंबल्स है, और गामा मतलब सेट ऑफ स्टैक सिंबल्स है, 0-1 बॉटम. तो स्टैक के अंदर सिर्फ 3 सिंबल्स दिखेगा, और ये बॉटम ऑफ द स्टैक है. और डेल्टा तो ट्रांजिशन से यहां पर दिया हुआ, इट्स गिवन टू यू, नो नीड टू वरी. Q naught is the initial state, and this is a Z naught. Instead of Z naught, they have used the bottom. And F is a set of final states. Thus Q2 is only final. This is a Q2. Q2 is only final. You have there, and where as per usual convention, Q is the set of states. They mention here everything is same. What I have explained so far up to here is the same. Now you need to understand this. You need to look at this data. Which of the following sequences? There are 4 sequences. Must follow the string. That means after this, the one of them comes, so that the overall string is accepted by the automata. So what you need to check now, the already half of the string is given 1 0 1 1 0 0. After that, this might come. You don't know. After this, 1 0 1 1 0 may come. You don't know whether it belongs to this language or not. You need to check. And after this 1 0 1 1 0, and option B might come to accept, you don't know. Or after 1 0 1 1 0, the option C might come to accept, you don't know. And option D is there. After 1 0 1 1 0, that 0 1 0 1. Don't write in the exam. I'm trying to explain which of the string. This is the whole string now, right? Half of the string is given in the data, half of the string given in the question, and they are accepting. After this string, if there is there any string that comes to accept by this motion. Got my point? Have you understood this question? But still the actual thing is the left. Actual thing is left. Now whenever any PDA is given in the exam, first job is, don't try to do what you know. First look at this transition is what the self loop is given with this transitions. 1 comma Z maps to 1 Z. It means Z, I don't know, it's not Z not, it's Z is anything in the world. That Z, actually what you push on the stack, something is there. 1 comma something, you got 1. So that means Z is only there this is whatever Z is there, and above the Z 1 is came. That means 1 is the pushed. So this is called as push 1. What is this called as? This is called as push 1. That's all. On the top of the stack, bottom is there, 1 is there, 0 is there, we don't care. Push 1. Whatever is there on the stack, we don't care. Push 1. What is this? Push 0. That's all. Z, something is there, I don't care. 0 will push. Push 0 for every 0. Push 1 for every 1. Push 1 for the input 1. Every 1 or input 1. Here push 0 for input 0. Input is 0, you are going to push 0. For input 0 or for every 0. Have you understood this too first? If you don't understand, then I can't help you, because this is how you need to understand. See, here Z is there, and after some time you got Z1. It means 1 is pushed, but what you are reading is 1 and you are pushing is 1. What you are reading is 0, you are pushing is 0. You need to understand. Now come here. What is the meaning of this? Oh, input might be, I don't read it, or I might read 0, I might read 1. So there are 3 possibles to read an input. This is the input. I may read an input 0 or 1, I may not read. That means from Q0 to Q1, I can take my own choice. I might come directly without reading input, I might come with 0 or 1. So this is my choice. I may change any time state, either by reading or not reading. Remember this point. Z I don't care, because Z I will keep Z same, but from here to here I can jump anytime. But after jumping, this one is from Q1. Actually this should be a little bit near, okay? This one, 0, 1 Z means top of the stack is 1, input is 0, I'm going to pop. And this one, input is 1, top of the stack is 0, I'm going to pop. So I'm going to pop the opposite symbols. When the input is 0, I'll pop the 1. When the input is 1, I'll pop the 0. So here, pop 1 for 0. This one, pop 0 for input 1. So opposite symbols you are doing. When the input is 0, you are popping 1. When the input is 1, you are popping 0. So when you understand this, here you push everything, you change your mind either by reading 0 or by reading 1 or without reading anything, and then here you pop opposite symbols. Here pushing is not there. Then whenever this epsilon represents here end only. Why I know this is end? Because once I go, I don't have any transitions here. It means this epsilon will represent end. But if this epsilon is there, this will not represent end, because it's not a final state, and from here there are many transitions. So this may not be the end. So this is definitely end, because from here I don't have any transitions. So if I am coming to the final, this must be the end, because if I left any symbols here, then I can't do anything here. So when end comes, end of the input string, end of the input comes, then stack should contain only bottom symbol. Then I will pop, I'll go to final. So first understand what is given. Push 0 or 1 comes, then change mind or change the state for input 0 or for input 1 or without reading input. 3 options. But whatever I push, I'm going to pop. If this 2 matches, then definitely, see, matching means what? Opposite. If I'm going to push here something like this, let's say 0 1 1 0, or let's say 0 1 0 0. I pushed here, let's say, and now I changed the mind here. I came here. Now to pop this 0, here what should be there? 1 should be there. To pop the second 0, 1 I should read. To pop this 1, you should read 0. To pop 0, you should read 1, because opposite input symbol should come. For this 0, 1 should come. For this 0, 1 should come. For this 1, 0. For this 0, 1. So you should understand, if I want to pop this, exactly in this order, opposite symbol should come. Okay? And without this, you cannot answer the question. What I have explained, what is given to you so far. And now what we have to do. See, this is given to you, right? What is the length? 1, 2, 3, 4, 5, 6. 6 symbols. And what is the length of each option? 5. 6 plus 5, how much length? 11. That means one symbol in the middle, whoever comes, this symbol, you need to skip. You need to skip. Have you understood why I am saying this? This is a middle symbol, 6th symbol, right? 6th symbol, you need to 1, 2, 3, 4, 5, 6. 6th symbol, you need to skip. This symbol you need to skip. That is how you can change the state. But this 5 symbols you push here, 5 symbols you pop, then only you will accept. I hope you understood the concept, right? So these symbols we need to push, and these symbols we need to pop by opposite match. So now we need to work on, so now here this 0 we are going to skip, so that this 5 symbols push and that 5 symbols will pop. So let's push this first. 1, of course bottom is there, and your bottom is there, this is a bottom symbol, right? 1, 0 and 1 and 1, then 0. Last 0 we don't push, because for that 0 we change the state. So from Q0 we'll push 5 symbols as it is, and 0 will change. Now opposite we need to match. So after this, now to pop this 1 should come, to pop this 0 should come, to pop this 0 should come, to pop this 1 should come, to pop this 0 should come. So 1 0 0 1 0 comes, then this stack will be popped, then you will be halting at final, because after that you can assume epsilon is there. So 1 0 0 1 0, who is that option? 1 0 0 1 0, that's option B. Is that clear? How many of you are able to analyze and understand this problem? Come on, quick. I'm not able to see the chart. Have you understood the whole concept, how you need to analyze? The problem itself has an answer, but those people who understand this data, your job is done. This data is very important than the options. Yes. But you need a patience, right? For the last 2 chapters, only the thing is, nothing will be there. After knowing the answer, right? Sir, is this the question? Here all the symbols are pushed as it is. Here all the symbols are popped opposite symbols. Here only one symbol might come or may not come. What is this data, sir? Now I can answer many questions in the exam. If for the same data, if I ask, if 0 is not there, still the same answer comes out. If 0 is not there, what do you do? On epsilon you will change, and exactly 5 symbols I will pop. Right? I can ask any data now, you will understand only when you know the what is given PDE. Correct? Yeah, nice. But takes time, yaar. Everything is not easy. That cannot be explained in 1 minute. The analysis is needed, right? Question 50. Now 51. Okay. Oh, wait, somebody is saying that. Why no transition is mentioned? Because I can come only at the end of the input. Do you know what is the concept? Many people don't know. So let me explain that too. Okay, very good question. See, from the final, I don't have any transition. What is the meaning of this? If I am going to halt it, if I am halting at final, that is only at the end of the input. Only at the end of input, I can come, we can, our machine, it can halt. If you come in the middle of the input, right, then from here you don't have a transition, means that's not the correct path, right? Only at the end of the input. That's why the special transition always comes epsilon comma something slash something. This epsilon represent, suppose you have input 0 1 0 1 0, right? Here you will always assume epsilon. On this epsilon only you will go to final, because this epsilon represent end of the input, because you don't have any transitions here. If you come in the middle, if you assume this is the epsilon, right, this 0 1 0 you can't read it. So that's represent you are going to come to the final only at the end of the input. Of course, this is not explained in the finite automata, because that was very easy. Only input symbols are there, so you are able to understand. Even I give at the final the transitions, it was so easy to understand. But here it's not that easy. Here also you can do that. You can give from the final, you can give it, it works. It works. But understanding would be difficult. So we have a different approach for these problems. Most of the standard textbooks, they wanted to have a clear cut when you come to the final. Oh, this one, right? Oh, you are talking about this one. This is a typing mistake, yaar. No transition at all. This is a typing mistake. I'm very sorry. I was thinking that you were asking why there was no transition. It is a typing mistake, okay? It should not be. There is no transition here. There is no transition here. Remember that. So these two are for this self loop. These two are for this self loop. I did not see that at all. Okay? Good one. Why no transition is mentioned on self loop of state Q2? It's actually, there is nothing. There's nothing. Even in the exam, if they give like this, they mentioned nothing, that there is no meaning. That's simply epsilon comma epsilon slash epsilon. That means nothing. Okay. Don't worry about, even in the actual gate exam, if they don't give anything here, just ignore it. You don't require it. Fine. Question number 51. Yeah. What is the answer? Context free. Very sorry, yaar. Now the time is 12:30. Now we can go quickly. Should I? B. So let's go for that. First one, M, here NN comparison, and then here MM. That's A's push, B's push, and A's you pop B's, and B's you pop the A's. Right? That will be happening, right? Every symbol is definitely guaranteed here. So it's a DCFL. So you can say CFL, not an issue. And this one, MN, MN. So this order is conflicting. M you push, that A's you push, but once you push the B's, then A's want the bottom of the bottom stack, right? Bottom of the stack that A's are present. So now this is going to be very difficult to match using the stack. So it's not CFL at all. The problem is this is not the stack order. It's coming like a Q order, right? Q we don't have. M is equal to N plus 1. In fact, it is a DCFL. Just before we have seen similar question, right? It's just like A power 2n plus 1, B power n. What you do, just write like this, A, then A power 2n, B power n. So you can skip this, and now here you you push all the A's as it is, push 2n A's. Then what you can do, every B you pop 2 A's, every B pop 2 A's. This is one logic. There is another logic here, push half of the A's, then every B pop 1 A. This is a one logic. This is a deterministic logic only. So it will work, no doubt. Every B pop 2 A's, every B pop 2 A's. So if you want another logic, there is another logic is here. That's actually deterministic logic. Here every 2 A's, you push 1 A. How do you do that? When 2 A's comes, 1 A you skip, other A push. That means every 2 A's you are pushing 1 A. So that's very easy. Now every B pop 1 A. Every B pop just 1 A. That makes this problem is DCFL. So now the question is, which of the following are context free languages? That one, L1 and L3. That's you have already answered option B. Correct. Most of you answered right. That's correct. But understand the logic behind it, because in future they may give you machine DPDA, then you should understand. T152. Okay. 2016. Which one of the following pays of the language generated by G1, G2? Oh, what G1 does, what G2 does, that's it. So you know the approach, right? Quickly, can you do it? So you do the bottom up approach. What is G1 here? S derives AS or B. What is B? B derives B or BB. And what is G2? S derives AA or BB. A derives AA or B or epsilon. B derives BB or epsilon. So mostly when you look at, you get the answer very quickly. So you need to practice that way. So what it does B star. And this B star you keep here. So that's B star going to be, right? This is a B star or epsilon. That's simply you can say B star only. So AA or B star. What this A does? So A repeats, right? A star, and B you substitute there. That's going to be B star. So capital A is going to do A star B star. So here you will get A star B star. Before that A is there. So A star B star. A star means A plus. I'm just writing directly, but don't confuse here. So let me write A star B star as it is. And this one B followed by B star. B followed by B star. So overall the language is here A star B star or B star. In case you want to simplify further, like A plus B star plus, this is a B plus. Okay, if you want to analyze that way, that would be fine. So this is the L2, assume L2. L1, what is the L1? So this is going to give you B plus, because at least one B is there. This is a B plus, and you put this B plus here. Then what is the L? This one gives you A star. Whenever you want to end S, it comes as a B plus. So L1 is A star B plus, L2 is A plus B star plus B plus. So you should know the technique how I am writing that answers directly. I am approaching bottom to top. and I'm understanding each productions because we practiced in the practice session like BB or epsilon means it is a recursive of the B star concept. Okay, similarly you need to understand everything. Now which one is matching exactly A star B plus, right? Just look at that. Any you are answered already, right? Everybody answering B, somebody answering D, then which is the right answer? Somebody answered A, then we need to work on work on the options. Okay, so we'll go from L1. So we'll match L1. Who is saying this A star B plus? Who is saying A star B plus? A star means, you know, A power 0 should be there, and R is there, it's wrong. R you can eliminate, gone. And this represent A star, this represent B plus, and this represent A plus B plus. So now this one gives you A plus B plus, and this one gives you A star B plus. Now without looking at even L2, you got the answer B, you eliminated D's. See, this is another shortcut, right? Even though they have given G1, G2, G1 is helping you to the answer. So whatever we spend the time is gone, right? It's a waste of time, but we don't know how to approach the questions in the exam. So better to, you know, use some shortcuts like, let's see G1 what it is doing and then match immediately so that you may save the time. So rather than doing this two at a time, so G1 do it and you got the answer. Now just do G2 is really the right answer, because sometimes you see the G1 difficult, then G2 might help you. So G2 cross check. Is it saying A plus B star or B plus? Look at that. M greater than 0 or N greater than 0. So what is the meaning of this one? M greater than 0. If it is M greater than 0, this comes as A plus, then B did not mention, right? B star. Okay. Or N greater than 0. That means that comes as A star B plus. Now is that going to have both of them here? You can see that A star B plus, is it covered here? Is it covered here? Suppose you have two cases here, you know, might be complicated, right? Without 0, that is a B plus. With A plus, that's A plus B plus. I put A is A power 0. This B plus is already covered. And A plus B plus, is it covered here or not? This is also covered. Now A plus B star exactly same here. So understand, when A power 0 is there, B plus, when A power plus is there, this one. So all the three forms are actually covered here. So somehow this L2 represented complicated way, if you try to understand, this might take time, but already we got the answer with just G1. So when there is a difficulty, when there is also easy, but we don't know how to analyze. So even just follow the given order. G1, just try to simplify, then match it. You got the option, choose it, then don't worry about G2. That must be this one only. Okay, everybody? Yeah, I hope you understood what I'm saying. Oh, another one, 53. This is happened in 2016. Good. Okay, can you try this again? Now, I explained the previous question, right? Same way you analyze. First, understand each transition, then only go for the options. Because they are asking about the languages. If you want to answer what they are asking, first you need to understand, is it push or pop or skip operation? Then you need to analyze based on that. Before that, understand what is given to you, right? Gamma is having only two symbols, X, Z. Now Z is initial stack. Previously Z was anything. Here Z is like a bottom of the stack. This Z is like a bottom. Previously bottom symbol was there, or Z naught is there. Instead of that, they have used Z now. Okay, so understand, this Z is different from the previous Z. Every time they may not use the same symbols in the machines. Okay, so follow them and understand. Change your mind logic. Like sigma is A comma B stack alphabet XZ, and Z is the initial stack symbol. That means Z is always there initially. That is important. Now this Z is different from the previous problem Z. Let L denote the language here. And now the question is very simple. This A comma X. X is the symbol that you push every time. So A comma Z, A comma X. A comma Z means this is the first A, first A. So when first A comes, first input A comes, what do you do? First A, first input A. That is also input. First input A. What you do? Push X. Understand clearly? First A, how do you know? Because Z is there on the top of the stack. Remaining A's, what you are doing? Definitely X will be there on the top of the stack. You will push X. So every A other than the first. Every remaining A's, every A push X. So I hope you understood, right? First A push X, remaining A's also push X, but both combinations are different because first time you see the bottom of the stack, remaining A's you will see X on the top of the stack because X already pushed first time. Then indirectly what you are doing here, the push X for every A. That's it. That's understanding. What is the meaning of this? This is P pop X for input B. And this one same pop X for input B. And this one is end of the input. How do you know end of the input? Because from here no transitions. So end of input. What should be there on the stack? Z. End of the input, no X present. That is the meaning of the Z here. Z should be present, keep the Z, doesn't matter. Okay. So I explained each transition. Let's do what is the meaning of this. You push every A, I pushed it. Okay. First B I pop A, and then remaining, this B is very important. See, there is a final state here. There's a final state here. This is also going to represent something. Somebody asked, right? When I have the self loop on final state, something will happen. That means first A comes without A, epsilon accepted. 1A, I push X, but I will halt here only. Double A, push double X, but I will halt here only. So any number of A's I will accept. So in the language, A star is accepted by this final. Let's say capital A. Capital A will accept A star. And let's say now another state C. What C will do? A will do A star. Sorry. So A will do A star. What C will do? The C will do when A is pushed and every B comes, and then that should pop all the A's, then only Z will be seen on the stack. So A is equal to B should happen. So the C will do A power n, B power n, such that n greater than 0 should happen. Because this B will guarantee at least one A and one B happened. But when I combine this, see epsilon already accepted, and while representing A union C, it's my job. A union C I can represent infinite ways. Because that epsilon I can put here, that's my choice. I can say A plus, and I can say union A power n, B power n, where n greater than or equal 0. I can write many ways this one. So understand what is that A union C. That A star union A power n, B power n. I can write now even n greater than or equal 0. But C cannot do epsilon. But union I can write as A star union A power n, B power n. That would be sufficient. That would be sufficient. No need to mention n greater than or equal to 0, greater than 0, because epsilon already accepting anyhow. Now who is that right option? Just look at this is A power n, B power n present. So accepted by any finite arbitrary is wrong. Option B, A power n is there, and also this is also fine, greater than or equal to you can keep, and is not accepted by any determinist. This is a DPDA concept, right? The A star, this is a DPDA only, there is no issue at all. But it is saying that not accepted, wrong. It is accepted. L is not accepted by TM. Yeah, TM can do everything that other machines are doing. Okay. The last one, yes, A star union here greater than or equal to is there, or only greater than is there. Both are correct, and it is DPDA, DCFL, right? So D is the right option. Okay, D is the right option. Correct. Exactly correct, Ishwar. Initial state is the final. That is the reason any number of A's are accepted. Any number of A's are accepted. If you look at the concept of that capital A, right? A comma, what is the given? Z is given AZ, and A comma X, sorry, XZ, right? Fine. XZ, and here XX. Now, what is the language accepted by this? A star. How do I know that? Because you give epsilon. Now I don't read, I will halt at A. That means I'll start at A, I'll halt at A. Give A, I'll start with A, I'll read A, but I will push X on the stack. Z is there, I'll push X, but where I am halting? Halting at A, I am halting at final. Halts at final. Epsilon also I am halting at final, A also I am halting at final. Double A, what I do? Initially I have Z on the stack. The first A from, let's say initial state A, right? From A by reading A, will go to A, but will push X. Another A will push X, but I will go to A, and again I am halting at final. That's why all these things are halting at final. That's why A star is accepted. Correct? 53, right? 54. Yeah, 54. Can you answer it 54? Quick. Come on guys, count is decreasing. That means you want me to stop now? Come on, respond. Don't sleep, yaar. I'll go to sleep otherwise. Respond. It is sleeping time for many people, right? So respond will make us, interesting. If anybody is going to sleep, you are waking up them directly. If you stop charting, right, then it feels sleepy because we are tired because of many other works. Fine. Keep interacting. That is the best way. Speak something in the chat. Put some symbols and do something here. Do some activity at least. No need to answer the gate question if you are not able to. Okay. Which one of the following is true? They are talking about context free, not context free, right? So focus on context free then. Which of the following is true? So think about context free. Is this context free? Ace, you push. Okay, I'll just do something. I'll explain the logic sometimes. Easy question, right? So that I can explain. So Ace, what you do? Push x power n you do. For B's, what you do? Again push x only, x power m. Then C is pop x. This pop n plus m xs over. Then exactly they will match. Is that clear? That's DCFL. In fact, that is DCFL. It is DCFL. And this one, yeah, all powers are depending on n. Doesn't matter it is 2n or 3n, right? So many problems are there, like a power n, b power n, c power n, a power n, b power n plus 1, c power n plus 2, and a power n, b power 2n, c power 3n, or a power n, b power n square, c power n cube. Doesn't matter, c power n cube. All these are not CFLs. They are in fact context sensitive languages. Okay, this is a context sensitive language but not CFL. Okay, yeah, good. Now I can see the symbols here. Okay, now both L1 and L2 are context free. Is that correct? No. So L1 is a context free but L2 is not a context free. Yes, this is the correct option, right? Option B. Anybody answered? Anybody answered? So we are just understanding question, the answers that you can do always, right? I'm explaining the whole data, exactly what is the right thing and what are other languages which are related to this. Okay, option even I do something in wrong because I never look at the options most of the times unless that answering depending on the options, right? Okay, just you do, when I explain this correctly, when I don't choose this properly, then choose it properly. Okay, don't worry about it because my focus is on the whole question and you do cross checking and matching. So I hope you can answer it right. Question for 54. 55. Language L1 is defined by somebody, L2 is defined by somebody else. Grammar. Consider the following statement: L1 is regular, L2 is regular. Just look at it. What is the meaning of this language? Do you know, right? A power n, b power n. What is the meaning of this language? A, b whole star. That's enough. Gone. Answer is over. If you are able to understand what S1 does, what S2 does, answer is over. This is not regular, this is regular. The statements are given to you. L1 is regular, wrong. L2 is regular, correct. So true, you need to choose that Q is a true, P is false. Done. Over. C. What are you asking? L2 is which one? 54 are you asking L2? L2 is, why cannot we say it is CFL? Because how you do it? A power n, B power n, C power 2n. You have three symbols dependent. Suppose you compare A and B, then C we will compare with whom? Try to understand. Don't do like A's I will push, B's I will push, then C will do. What will happen if I do that? Then let's say triple A, 1B, then what will happen here? 4 C's. You might accept this. Some people might think gently, like, A's they will push, B's also they will push, C's they will pop both B and A's, but that will not work. See, here 4 symbols you will push, C's you will pop, it will match. But is it matching this one? You are going to accept invalid strings, right? Don't ever try to do with a one stack. It will not do the job properly. Maybe this logic, A's I will push, B's I will push, every C I will pop, B then A. This will accept all the strings of here, but will also accept some of the invalid strings. That's why this logic will fail. That's why this is not a context-free language, okay? That's why I have written so many languages there to help you, okay? 55 is the clear? 56. Yeah, one of the interesting question in the context-free grammar. Okay, it's almost 1. Which one of the following represent the language generated by the above grammar? Can you do it? Okay, don't look at the options which are provided by somebody else. Just do on your own. And also ask me the question, sir, why not this is the right answer? Because you might be concluding some other option is also right, but why not that is correct? Just ask me the questions. Somebody saying B, but I don't know, how did you understand? Any other? 3 people are answered B. क्यों कुछ अलग दिखता है ना क्वेश्चन, इसलिए you try to remember the question. That's possible because you will remember, because this question is somewhat different than other questions. So you might remember this option because so lengthy than other options. So you might remember this option. But is everybody answering B? Okay, let's see. First, how to analyze the question. Look at that, how to analyze the question. You know the grammar, right? The grammar definition is given. So now, what is the B here? What is the T here? T is doing B plus. Now you just change the grammar now. S derives AB as C B plus. Okay, B plus, or ABC B plus. Now you know this, right? Suppose you have S derives X, S, Y or Z. What do you do? X power n, Y power n, then Z you keep in the middle, right? Did you remember this concept? So use this to apply here. So now I'll write the language here. L is equal to, so now X power n is what? AB power n. Then Y power n, that's a CB, sorry, the CB plus power n. And then Z is there. Z is what? ABC B plus, ABC B plus. Everyone? Now you may understand, here AB is there, here CB plus is there. So now both are same, right? Like you have something like X power n, okay, X power n. Something like P power n, P Q power n. So now what you write? This is same as P power, this is n greater than or equal 0, right? And this is n greater than or equal 0. So what do you write? P power n, Q power n. Now you write n greater than or equal 1. The same way I'm just writing L is equal to AB power n, CB plus power n, such that n greater than 0 or n greater than or equal to 1. Both are same. N greater than or equal 1, same as n greater than 0. Okay. So everybody got this point? Now you need to observe, of course, greater than 0, you can everybody saying greater than or equal 1, right? Choose that. Now this one is matching with which one here? And why not? So first let's see it. Is this matching with this one? No, you can easily ignore it. Fine. And which one you can delete apart from that? This N and M both are different. So you can delete this one also. And now option B, C left. What is the difference between option B and C? Anybody? What is the difference between option B and C? The problem is, let me write some explanation to this. The option C, what you might be missing. Let's say when I say n is equal to 10 and m is equal to 5. These two are fixed outside, so that when you go inside, it happens like this: ab power 10, cb power 5 power 10. That means that within that power 10, this b power 5 is fixed. But in this, when I put here, when I put n is equal 10, then b power 5 need not be there. It's just like ab power 10, cb plus power 10. Now in this power 10, I will have cb power 1, I will have cb power 2, I'll have cb power 3. It's my choice, right? This 10 times, here 10 times when I write, first time I can take cb, next time I can take cb, next time I can take cb power 2, next time I can take cb power 100. But here every time I write cb power 5, cb power 5, cb power 5, this all powers are going to get the same. 10 times we'll write. But here you look at, when I say cb plus power 10, the 10 times I no need to write the same cb powers. I can keep on changing my b powers. So this b plus is different from b power m. B power, here that's why they did not write b power m. See that ab power n is fine because inside ab only, because both powers are 1. But this one, cb power any m1, m1, m2, this mn are anything. m1 means there's a plus, they are saying that because greater than or equal 1, they are saying that cb power plus cb power plus cb power plus, that can happen n times, because this n says that you can say n times, 1 to n times, because here n is there. So 1 to n times the cb plus can come. So this is exactly same as what we have written here. So this b is only matching here, that's why we are choosing it. But most of the people confuse us with the c, that cb m, because m is also greater than or equal 1, but it's not a plus, because every time that m is the same, that is the issue. If you keep the 5, every time 5 only comes, but here it need not be same every time, n times, the plus can be different. Everybody? Right, power of b plus is fixed here. That's why c is, most of the people might misunderstand this terminology. Okay, so I want you to analyze properly. This is only the matching with the option B, but not option C. Never do plus, simply blindly don't replace with some variable, because that might change the meaning of this. That's why CB plus you can replace. I'll tell you when you can do that too. So when I have CB plus definitely equal to CB power n, such that n greater than or equal 1. The problem is CB plus power k there, let me keep m here. When you have n, never write that cb power m power n such that m greater than or equal 1 is not wrong, not correct, because this n is different. This power n is there. That is the reason this plus you can't replace. But when nobody is there, you can replace, because here m is a free. It's not bounded by anybody. But this m is this plus is not free, because bounded by n. That is the reason plus you can't keep with the m, then m is going to be restricted. So look at the difference here, right? This is going to be a very challenging representation. But the same thing I can tell you some other way, but don't worry about it. This can be cb power m such that m greater than or equal to 1, and that n I will keep out. Now see, this is the different one. This is same as exactly cb plus power n, because this n is outside now. This n is outside. That is the reason this is correct. But this m is inside the n, so every time I come m can change. But here this m is outside. Here n is also there, let's say. Then m and n are fixed at the same time, but here n is fixed. Then when n is fixed, when you come inside, before taking the m is fixed. So every time you come for n, then m can change its value. So look at this two. These two are going to match, but this is different. Everybody? So how you analyze these powers are going to be the matter for this kind of question. Okay? Okay, 57. You have A, B, C, three symbols, right? They are talking about what? Union, intersection. First understand what they are each one. What is this L1? A power n, B power n, that's C star. And what about L2? That's A star, B power n, C power n. Now when you do the union, that CFL, this is a CFL, right? Even include, in fact, it is a DCFL. DCFL union DCFL, you definitely get CFL only. So this is correct. It's a CFL, no doubt it's CFL. Because both are CFLs, you can do the union is always closed. But intersection, you should work hard. Intersection could result anything. So you should work hard. Like first one, A power n, B power n, C star. An intersection, A star, B power n, C power n. What is going to result? Here AB should be equal, here BC should be equal. To match both of them, all should be equal. Is this a context-free language? Not. Right? This is not CFL. You know it is a CSL. So one is the CFL, two is not CFL. So they are asking about CFLs, one only. Okay, correct. Good, everybody answered A. That's nice. Next, 58. Consider context-free grammars over the alphabet. Two grammars are there. Can you analyze it quickly? Yeah, you know it, right? 58. So every 20 questions we take small break so that you can refresh. When people are not coming, then I'll close up the session, right? If you are there, then we are lucky. Yeah, 58. Tomorrow also we have today. That means today we'll be having another session, compile design today night, right? Shivam, yeah, don't ask on platforms, yeah. You can ask in separately. Mac, thank you. Dedication is only for, you know, it's just for helping the students, right? You know, somebody saying pi, somebody saying epsilon, just work on. So what is G1? So you understood, right? This comma T, right? This is a C star, and C star when you keep, then this will give you the whole language, this language, right? This one, whole one will give you A power n, B power n. That S is nothing but going to replace with the T. T is a C star, and this is the answer, n greater than or equal to 0. So this is one language. And what about this one? That this is also C star, and this one you need to understand, B power n, A power n. Similarly, this one will give you B power n, A power n, C star, and almost same. Now they are asking about intersection of these two languages. You know what is the intersection? A power n, C star, B power n, B power n, C star, A power n. They are going to match only when n is equal to 0. Put n is equal to 0 in both of them, it comes as a C star. But if n is other than the 0, both will never match, because this starts with A, this starts with B. Only they will match. Put n is equal to 0 in both. Then C star will be seen. N greater than 1, greater than 0 in both. You will see nothing. You will see pi. You will see C star. Okay. So you will choose C star. C star, is it finite language? No. Is it not finite? Yes. But regular? Yes. Context free? Yes. But don't say not regular. This is wrong. Recursive? Yes. But is it not context free? It's a context free. Okay, which of the following is true, right? Is what? Correct. Not finite but not regular. Option B. Everybody? So don't say empty language. Empty language, when you say, right, it will become finite. So the option A is not correct. Here option B. Got it, everyone? Yeah, good. 59. Next one. Identify the language generated by the following grammar. You have a grammar where S is a start variable. Just, you know, you need to identify, right? Very easy. What is this? A power n, B power n. Always go from bottom to up as per my technique. That's A plus. Then A plus followed by Y. What is the meaning of this? A plus followed by Y means A power n, B power n. A power n, B power n. So now you have a power n, b power n, a plus. What it makes basically, this is n greater than or equal 0. What it makes, see, if you, this a plus means definitely at least one a comes. And what is this means? This means equal a's and b's. So what it guarantees, it's going to guarantee always a's more than b's. If you look at this two, yes, definitely more, because here equal is there, here at least one a is there. So at least one a comes before this equal a's and b's. That makes a power, what is there, m is given, right? A power m, b power n, such that m definitely greater than n, because this a will guarantee that. But if this is a star, then you should write greater than or equal to. So very small thing, if you see a star, a power n, b power n, this makes a power m, b power n, such that m greater than or equal to n. But if you see a plus, a power n, b power n, then you will have answer a power m, b power n, such that m greater than n. So understand, here definitely one a at least comes before, that's why we choose this m greater than n. Of course, m comma n greater than or equal to 0, that is there. So you choose that, which is correct one. M greater than n, where is that? Here equal is there, here equal is there, and here these two options are there. But this one is saying that n greater than 0, but n is actually greater than or equal to 0. So we'll choose for option C. Everybody said right, option C. That's good. That's very easy for you. It looks 60, question number 60 for the breaking point. Okay, small break after the 60 again. So every 20 questions we are taking a break, and we'll just do that because it's taking much time to analyze every question, right? So let L1, L2 be any context free languages. You might aware that why I'm going very slow, because you should aware of the each explanation or each concept that is coming in the exam. We are not just, if it is marathon, right, this question will be A, this question will be B, you know, that 100 questions can be done within 100 maybe, you know, minutes or less than that. Within 1 hour we can do that. But anyhow, take it as a reference for, you know, practicing. L1, L2 be any two CFLs, any CFLs, or be any regular language, then which of the following are correct? So now you need to analyze L1, L2 or is given. CFL, union CFL. CFL, you need to choose a correct. Every word should be read properly. Correct or not correct? Correct. So is a CFL, CFL, union CFL, CFL. You know that CFL complement is context free? No. No need to be. Actual answer should be L1 complement need not be context free. Don't write not context free also. L1 complement need not be context free or may be context free. But is there, so wrong. CFL minus regular. You know, right? CFL union regular, CFL intersection regular, CFL minus regular, even quotient, CFL quotient regular, all are going to be CFL. Okay, the result is always CFL. So this is the right. L1 intersection L2, CFL intersection CFL, no need to be CFL, right? Now 1 and 3 only correct. So how many of you answered? B. Multiple answers are coming. Keep this point. Third one that I'm giving a reference, whenever they ask for CFL, these are called as regular closures over the CFL's domain. When one language is the CFL but other is strictly restricted to regular, that's why we call it as the regular closures. And here if it is DCFL, here it is DCFL. Okay, if it is CSL, then answer is CSL. But if they ask for regular, CFL union regular, may be regular, may not be regular, but always CFL. Understand that too. If I'm writing CFL, doesn't mean that it is not regular. It may be regular, may not be regular, but answer is always CFL. Yeah, you can write. That is another way to analyze. But what did you write? CFL intersection regular complement. What is it? CFL minus regular. You can write as CFL intersection regular complement. But regular complement is regular. Don't take any other DCFL, CFL. They are different words. If it is regular, then CFL. But regular is regular only. The CFL intersection regular is always CFL. They have the proofs. One PDA, one fundamental data. They have the composition proof to make a PDA back. So never take, if it is a regular, you can say CSL. But don't take CFL, CSL here. Why? Because regular properties are different. CFL properties are different. CFL intersection regular is already CFL. Then why are you going for CSL to answer, right? So don't say that way. CFL intersection CSL. Who told you to take the CSL? I did not ask that, right? So don't do the changes, that makes the wrong analysis. Okay, I understood your point. Yeah, somebody is asking the question, let me answer him. That CFL, if they ask CFL union CSL, then answer is CSL. If they ask CFL union regular, don't assume that it is not CFL, it is a CFL. If they ask CFL union DCFL, so this DCFL, don't write CSL, wrong. So already CFLs are closed under CFL union, so it should be CFL. If the CFL union finite, then answer is CFL only. But CFL union infinite, then what is the answer? It should be infinite. Okay, so understand that way. CFL union recursive language, what do you answer? You will answer recursive. If they ask CFL union REL, answer is REL. If they ask CFL union L is unknown, then answer is unknown. We don't know what's going to happen because L is not mentioned. All right. Keep going to ask, keep asking the question so that you will get additional points too. Okay, 60. 61. Need a break? Or we'll complete the CFLs, then we'll take a break. What is your choice? Because before the Turing machine, you definitely need a break. Do you need a break now or after the CFLs? Okay, after CFLs. That's what I'm saying, right? CFL intersection regular complement. First you take the reference. CFL intersection regular. This is a CFL, you know, right? So now regular complement also you want. Regular complement also you want. This is a regular complement, right? Any language, not only one language I'm talking about. Regular complement is always regular. Always regular. So CFL intersection regular is always CFL. For this there is a proof, but we don't need a proof, right? There is a proof. You can ask that PDA can be composed with the FA to get back to PDA. There is an algorithm. So this proof makes a CFL with a regular, you will get always a CFL. This proof will works for union and intersection and set difference. All of them it works. The same proof. But anyhow, we are not worried about that proofs at all. Okay? Fine. What is the answer you got? The question is about which of the following is correct, and then context free they are talking about, and deterministic, regular, recursive, all the points. Let's understand what is this language. Whenever you see that over one symbol they are not forming AP, right? Blindly answer context sensitive language. Okay, this is another point that you should remember. A power anything, right? Number of A's is actually not forming, or all the strings in language not forming AP, then we will come to directly context sensitive language. Now here the B's only depending, B's and C's depending, A's are free. A's are free. This is DCFL in fact, because A's you will skip and B's you push, and every C you pop 2 B's, or every B you push 2 B's and every C you pop 1 B. That's possible deterministically, and all the powers are depending on which is going to be a context sensitive language. And only 2 symbols, right? 2 symbols dependence you can do with the stack. That's in fact DCFL deterministic. So by looking at this, just choose the correct statement. L1, oh, context free, wrong. L2 is not context free, is actually context free. L3, it's a not context free but recursive. Yes, it's a CSL, so recursive, so this is correct. L4 is in fact DCFL, so 3 and 4, that's a D. You have answered correctly. Good. Yeah, I'll stop the session when there is no response from the students. Okay, you remember that, because I'm also looking at only chat to make active myself. (62) Which one of the following languages is not context free. Oh, not context free means it should be either CSL or recursive or anything could be possible, but it should not be context free. So is this context free? I belongs to somebody. That means I maybe n, maybe 3n. This is nothing but like a power n, b power I, such that I is equal to n, or I is equal to 3n, or I is equal to 5n. So you know, right, each one you can have a different path to understand. So you can, in a PDA, like when B comes, you can take this path, or you can take this path, or you can take this path. So non-deterministically you can design. So this is definitely CFL. Otherwise, while designing, grammar also, S derives A or B or C. Then A you can implement I equal n, B you can implement I equal 3n, like this. A derives what is equal to, that's AAB. This is equal to, and I is equal 3n, that number of A's is thrice, right? So triple A, B and 1B. That's done. I is what? Not A, sorry, I'm very sorry. That's I is what about the B's. That's not, means 1A, then 3 B's. And C is about what? The I is 5n, that number of B's is 5 times. So A, B, 5 B's. So I hope this kind of analysis required. Sometimes in the future they may give this grammar, they will answer, they will ask what is the right option for this, then you should choose option A. Anyway, it is a CFL. Because I'm, rather than designing the PDA, sometimes the grammar could be easy. That's why I'm trying to help you. Kitne chahiye, Sritam? How many you need? Okay, next one, option B. So try to understand again. A, W, A power n, reverse of the W, B power n. So what you can do? Suppose if I push both of them, then this reverse will depend on the W. That means I can't match even non-deterministically. In case the same problem comes like this, okay, here is already there. W is there, push. A power n is there, push. And B power n is 0, right? We don't know n comes or not, but we can pop with this. And if these two matches, then definitely W power R will find the W to pop A with A, B with B. So it's very simple to understand, but it is non-deterministically. Again, it's a CFL only we are talking about. It's not a DCFL anyhow, CFL. And this one with the stack you are not able to understand. The reason is you push W and push A, but W power R need to compare with the bottom of the stack. That means below the A's. Oh, that's not possible. That's why it's not CFL. Okay, it's not a CFL. This is, sometimes I do analyze wrongly. So can it be done some other way? Can I assume, because sometimes it could happen, it's equal to W power R. If that happens, then this will be CFL. So let's analyze. Can I delete this side? Okay, let's analyze this one. Can somebody come up with the answer? Is this possible equal to W power R? If possible, then this will be the right answer. Is it possible? Just check it, because I don't know whether it is possible or not. Just you need to analyze. Will it be possible to W power R such that W belongs to A comma B whole star? Will it be covered? Because I'm just checking for the strings. Let's say I'm taking W is equal to AB, and that A power n is triple A, and then reverse of the string is BA and triple base. Is this covered by W power R? Will it be matching somehow? No, right? The reverse of the string is, let's say this last, total amount 1, 2, 3, 4, 5, 5, 5. Is it matching here? No way, right? So that means this is not going to happen here at all. So that dependency cannot be eliminated. It's not going to be CFL. Because sometimes what happens, if that's, I don't know exactly how to analyze right now, but sometimes if these A's are covered by W and this symbols are also A's, then these are covered by this, maybe this W and this might happen. I don't know, like this W, A power n, then A power n, W power R. If this is there and this A's will be covered here, this A's will be covered here, and this, if you assume some X, if you assume X power R, exactly matches with what we are analyzing. So I'm trying to understand, is there any other way? Okay, now this one, it is a CFL, right? It is CFL, and this is also CFL. And which one of the following languages is not CFL only, right? So we have come up with only one option, that is the B. Yes, Alam, you will get it. Yeah, 62. Just let me check how many are there before taking the break. 1 2 3 4 5 6 7 8 9. Okay, let's complete this. Okay, yeah, D is not DCFL. Correct. So that's not going to be DCFL. When it will be DCFL, how can I say that? It's a very difficult point to analyze right now. So if you have something like this, W hash A power N, B power N, hash W power R, then you can do it. W, you will push everything. The hash will remind you that A power N, B power N is going to come. So A's you will push. Now B's you will pop the A's. Then hash comes, then you need to do the pop. So this will become DCFL. But here it's very difficult to understand when the A's comes. So here what is the problem? Why it's not a DCFL? Because W A power N, you will push everything, no doubt. But this B, is it inside the W or outside it? You don't understand. Suppose I got A, B, double A, double B, and this B, is it inside the W or outside the W? You don't understand, because after that BA might come, and again this triple A, triple B may come, and whatever you have, this might come here, reverse order. So this makes sense, right? You don't understand when to understand this B's, I need to pop with the A's. Here this B's, I can't, because this B I need to pop. So there are multiple choices that you will get here, non-deterministic choices. So understand, the option D is a complicated, deterministically you can't do it, because that B, when it comes, you don't understand. Okay, 62, 63, fine. Anybody join now? Just don't forget to like again. 63. Yeah. Sorry. This is the compiler question, okay? But still you should understand. Otherwise you can ignore. Right now in compiler you can analyze that. What is that? No Rohit, not now. I'm staying in Bangalore now, but I do visit. Yeah, Manjit Singh, we did in 2021, again back to 2022. That's good. Yeah. We have another session like Maha revision, right? That day also we will be, going with a lot of time. Let's see, in revision also we will be looking at a lot of shortcuts, a lot of techniques to answer the gate questions without having any examples. No, Shivam, don't know exactly how many hours goes. It depends on how many students are coming to the live. So it all depends on the student's interest, not my interest. One is true. Okay, what you are doing here, the first one, it's a DCFL only, right? The A star union A power N B power N. A star union A power N B power N. So this is pretty easy. It is what? DCFL, okay, DCFL. Fine, this is a true. They are asking about true only. L1 is context free but not. Oh, this is a false. Okay, that's good. Now coming to the option 3, statement 3. L is not LLK for any K. What is that LLK? What is talking about LL1 or LLK? What about it? Whatever it is. What is the meaning of this one? Can you make a grammar without having a common prefix? Because there are two concepts, right? Here A star should come, here some A's should come. So this A's, can you cover up without having the common prefix? Like if you want to design, right? One way I will design A or B. What A will do? A will do that A star, like A or epsilon. What B will do? That B should do that A, B, B. There should be a connection, right? There should be a connection. So any number of A's comes, that many B's should come here. So we don't know whether A's. Now these two problems. Can you avoid the common prefix from this two? Is there any way that you can avoid with one non-terminal? Can you generate both of them? Like A, without having A or B, only A can do this two without having common prefix. If I take A, again you need to consider B or C. That makes a common prefix. From here, there are common terminals or common prefix, you can say. Common prefix, not 1 length, 2 length, 3 length. That's why you take any LLK, you will see the common prefix. That means any LLK you are not able to do it. That any means here every basically. L is not LLK, you take any K. You can't implement with LL. That means indirectly I am saying there is no LLK grammar. If you study LL1 grammar, indirectly I am saying there is no LL1 grammar. It means you don't have LL2, you don't have LL3, you don't have anybody here basically. No LL1 grammar for this language. Even not LL1, LL2, LL3, LL4, every grammar you can't write here. That's why L is not LLK for any K. This is going to be the true statement. This is going to be the true statement. Everybody, the common prefix, because I'm trying to write, you always get common prefix. You always have common prefix. You tried any grammar. If you are going to come up with I never have a common prefix anywhere, then that will be the LL grammar. But you can't implement LLK grammar for this. That's why L is not LLK language, because you don't have LLK grammar. You don't have LLK grammar. That's why the language is LLK not LLK language. So that's true, right? Anyhow, just ignore it. If you are not able to understand what is LLK, just ignore it. What is LL1 definition? LL1 is not ambiguous. LL1 is not left recursive. LL1 should be left factored. Then that's going to be the LL1 grammar. Of course, you need to follow the definitions. 64. First. I think it should be easy, right? Is it easy or difficult? Oh, this one. WXYX and WXY. What is the common here? X is the common. So understand here, X is the common. And what you can do here is X is only dependent, not W. But we might be practicing something like that. That's different. Like X, W, Y, W. That's similar to this one. You can also write this way. W, X, Y belongs to 0, 1 whole plus. So understand X, W, Y, W is same as W, X, Y, X. Oh. Right, this W was dependent earlier in regular practice, but here X is dependent. That's fine. But have you come up with the answer now? X is dependent, right? Put minimum X. Put minimum X. What will you get the answer? When you put minimum X, either 0 or 1, this will be converted to W0, Y0 or W1, Y1. So W and Y both replace with 0 plus 1 whole plus. What will come up with? 0 plus 1 whole plus 0. Y is also what? 0 plus 1 whole plus. Sorry, 0 plus 1 whole plus 0. Or the other one, W you replace, right? Similarly, you replace W1, Y1. So this is a regular language. What is L1? I'm just come to the regular language. Okay, we have concluded it is a regular language. What is L2? Anybody? Come on, guys. Length of X is equal length of Y. Length of X is equal length of Y and X not equal to 5. What is the meaning of this? Anybody guess? Anybody understand this question? I want XY, but X length equal to length Y and X should not be equal to Y. What should be the meaning of this? It means, let me try something here. Epsilon, can I take? Epsilon, when I take, the lengths are same, epsilon, but the both should not be equal. So you cannot choose the epsilon. You cannot choose epsilon. The string should be equal there. So let's try another way. Can I write double A? If I write double A, then A comes A, B. Both are same length. Sorry, A, both are same length. A not equal to A. Should satisfy, but it's failing. AB I can write. Why? A comes as X, B comes as Y, and both are not same strings, but both are having same length. What about BA? I can write BB. Can I write BB? B is one length and another B is one length, but both are same strings. So X should not be equal to Y. But this is failing, that's why I can't give. So this kind of strings are going to come. So when you divide the string into two equal length, and these two strings should not be same, but their length should be same. Like when I have 4 length, I can't have AA because these two are equal. I can have AAAB, I can have AABA, I can have AABB. So when this X is AA, X is AA, Y has to be AB, BA, BB. These are valid, but this is not valid. So how you can guarantee that other Y is not the same? So that makes sense. That makes sense. But is there any way? Because it's one of the difficult concept. Anybody answered it? Trying. Somebody saying CFL. So L2, can I come up with some logic? Like length only need to be verified, right? Anyhow, deterministically you can't, but non-deterministically what you can do? Can you do it? Non-deterministically what you can do? You will push this X and this Y. How can I guarantee is not same, right? It's a W, X not equal Y. Can you guarantee it is a CFL? First thing is, how can I guarantee it? Is there any way that I can check X not equal to Y? You have to check X not equal to Y, yaar. How do I know that this, let's say AAB not equal to AAB? Because my string might come as AAB, AAB. How will you guarantee this is not same? But if any string is different, then I can check. So do you have any logic for this? WW, checking that. WW, is there any logic? Is there any logic? Anybody guess this? WW can't check, but this one we have a logic. If anybody remember WW complement. Do you know this is not a CFL, right? Remember this point. This is not a CFL, right? When you do this complement, it is going to be a CFL. But W belongs to A comma B whole star. This is not a CFL. So using this concept, of course we can write a logic, but the logic itself takes 20 minutes or 15 or 30 minutes. That we don't have the patience right now. But this logic, anybody learns this problem, same logic will apply here. But only the difference is here, whenever even length comes, you are going to verify WW. Whenever odd length comes, you will accept blindly. You don't need to check this logic. So here, this logic came from, one of the logic is this one, and this is when even length is there. When all odd lengths, you don't need this logic. Just you can write regular expression for that. All odd length blindly accept, but all even length which are in WW or which are in this form will guarantee it is not in WW form. So this, if you have studied some point of time, then please use this logic to answer L2. L2 is actually CFL, but not DCFL. Yes, it is possible. It is possible to create a logic. NPDA is possible. But looks like, yeah, you are talking about WW concept, but it is, we are not talking about WW. We are talking about WW not there. So not, you can verify. There is a mathematical logic for WW not in the language. Okay, even length which is not in WW form. What is this logic? This logic is, I'm going to write here L2. The problem is very simple. The name is, it is even length but not in WW form, but not in like WW form. This could be verified. Okay, that's why it comes as L1 is regular, L2 is CFL. But if L2 is really complicated question here. But if you don't know L2, can you answer it? Let me say L1 is regular, correct. L1 is context free, but L2 is not context free. Yeah, you may come up with some answer B2 if you are not able to understand L2. So you should be careful about it. Okay, which year it is? So not mentioned. Fine. 64. 65. Really, anybody want explanation for that? Ask me, then I'll take the time. Only the thing is which takes time, that's all. That's actually, that's going to be master level assignment questions. Prove it. 5 to 10 marks questions you may find in IIT MTechs. Let's find out number of strings of length 100 accepted by the above pushdown automata. Yeah. Can you try this question? Where is the machine here? So they mentioned what is this means. Okay, what is A, what is X, what is Y. They mentioned it, and this means delta of P comma A comma X, P comma A comma X is equal to Q comma Y. The same meaning what you know, right? So only the thing is just you need to understand the machine. Are you able to understand the machine? As I told earlier, first they are pushing the hash, then they are pushing the capital A for small a. They just change the state, and for every b they pop a, and when epsilon comes at the end of the input, the a left on the stack, that means a left on the stack means the number of a's more. So understand the concept. Here only the answer is coming directly. So they push the first push hash to bottom of the stack, they push hash. Now here every a, this one, every input a push capital A. That means they are going to push a's, capital A's only. Doesn't matter how many capital A's comes. Okay. Now change the state. But when you change the state, look at that. When you change the state, now there is another way. This path you take, this path without b's also may happen. Directly you may go this path. That means when epsilon end of the input comes after this a's, even you can go to final. That means one concept is a star accepted. How a star accepted? You can see that you push, for every a push capital A. This means epsilon means without looking at the top of the stack. This epsilon is very important. Without looking at the top of the stack, push a. That means hash is there or small capital A is there, doesn't matter. Small a comes, push capital A. So every small a push capital A, and just without doing anything change the state. Don't read input, don't look at the top of the stack, don't do anything, because epsilon means nothing happened on the stack. So this is blind move, right? Without looking at the stack, without input head is there only, but you change, only change happens in the state, nothing else. Stack doesn't change, input pointer doesn't change. Now from Q2, if you don't get the b's, you can go to final directly, because epsilon comma a. That means a already pushed, but this will guarantee at least one a pushed. So now epsilon, is it accepted? Epsilon is accepted? No, because this is demanding. A must be there. So a plus is accepted. If it is epsilon comma epsilon, arrow epsilon, then I can even accept a star. So epsilon, if I want to accept, this is guaranteeing epsilon, but this is not guaranteeing epsilon, because demanding a must be there on the stack. Must on stack. That makes at least one a happened. At least one a happened means a plus only can come here. Other way, at least one a pushed, and every b you need to pop a, and if any a left on the stack, that means like this: a power m, b power n, m is equal happens, then here a never happens, right? So m should be greater than n. So these strings are also accepted, and these two strings are accepted. Now the question is number of strings of length 100 accepted by the above PDA. Now length 100, here length 100, how many there? Only one string. That's 100 A's, one string only. And here you need to find out any combination that you have. Oh, somebody saying regular. Why regular? Yeah, are you able to accept b's, any number of b's? Single b, how can you accept? Impossible, right? Without a, there is a connection here, m greater than n, because every b comes, you need to pop the a. If you don't have the a's, you can't have the b's. So single b not accepted, because you can't, because b demands a. B always need a. Pop a for every b. If b is coming, a definitely should be there, because without a you can't do anything. Without a you can't do anything. So who is saying that? A plus b whole plus. Come on. Here you need to find out this one. 250s. A power m, b power n. Yes, all of them is correct so far. But there is another one. A plus is accepted. A plus. From here there is a one string is going to come. But from here, oh, that's already covered here, then no need to worry. If it is already covered here, then no need to worry, because the m greater than n, is it covering a plus? Is it covering a plus? It's covering, right? When n is equal 0, it's covering, then it's fine. Then it's fine, it's fine. Okay, let's find out. $50. Do you have the 50 here? Let's try that 50. What are the 50 strings you have? Up to 100 length, right? 100 length, how can you get here? So do you know the combination? If it is 0, you will be having 100. If it is 1, it is 99. It is 2, it is 98. It is 3, it is 97. And 0 to how long you go here? Let's say 49. Here you will have 51. If you have a 50, you will have a 50. Right? but this is equal never happen, right? Equal never happens because already m greater than n. So how many strings are there combination? That is a power 100, a power 99, b power 1, and so on till a power 51, b power 49. How many strings? You can just look at the a power 100 to 51 or a power b power 0 to b power 49. So you will be having 50 strings only. 50 strings having 100 length, having 100 length, 100 length. So it's also very interesting question because last one is the trick. If you include a power 50, b power 50, that's not the valid string because m should be greater than n. A power 50, b power 50, here m is equal to n. You can't choose this, okay? So that count is going to miss 50 or 51 or 52 because initially there is a path that is going to the acceptance, that is a plus, that is also having one string. You should not count that because a plus already covered here. Everyone got it? Yeah, it's also another interesting question, looks like. Fine. 66. Can you try this? Just spend the time. Whenever you don't understand, right, only the way that you can understand, spend the time and don't do any mistakes. If you do mistakes in calculation, definitely goes in wrong direction. Okay. 79 likes so far, yeah. 80. Make it 100 before closing. We are able to take a small break. After that, let's see. Suppose that L1 is regular, L2 is a CFL. Which one of the following languages not necessarily context free? Okay. That is L1.L2, regular.CFL, regular.CFL. Is it CFL always? Because you can write a context free grammar for this. For this, you can write one non-terminal, you can concatenate. So it's always CFL. And regular union CFL, you know, it's also going to be a CFL always. Why? Because you can write A or B. You can write A or B, a production. And A you can generate, B you can generate. You can write a context free grammar for both. A dot B, S derives A dot B, A can generate this regular, B can generate this regular. Yes, you can write a grammar for that. But L1 minus L2, this is the regular minus CFL. Of course, this is going to be a different one. Regular intersection CFL complement. CFL complement, no guarantee of CFL. So regular intersection CSL comes, that's guaranteed always CSL. So this is going to be not necessarily context free, no doubt. And L1 intersection L2, regular intersection CFL, I was talking about this, that regular closure intersection and union minus, they are, of course, that's minus should be the regular should be right side, then only CFL minus regular, that is closed. But CFL minus regular, that is okay, fine, but it is a CFL always. But regular minus CFL, that's a different answer completely. It is going to be CSL. So these 2 points are different. So this is also CFL. So we'll go for only option C. Yeah, you are able to answer, right? Any example for option C? Any example for option C? Oh, really interesting. Okay, let me talk about that. So now just look at it. Just track back. So some CSL should be there. Intersection regular, you need a CSL. So I'm just tracking back. See, A power n, B power n, C power n. We know it is CSL, right? It's not a CFL. So intersection with the A star, B star, C star. Now I'm tracking this step, and above one step, this is A star, B star, C star is a regular intersection complement of this one. A power n, B power n, C power n complement. This is actually what I'm doing is, right, complement of this one. So just first write here, the CFL complement is A power n, B power n, C power n only. This is the CFL complement. Just take one more step. A star, B star, C star minus its complement. Its complement, that is going to be what? As intersection of this one, CSL we got, and take the CFL. CFL is what? A power n, B power n, C power n complement. So this is what happened. This is a CFL now. Of course, writing is going to be complicated as you asked the example, right? This is a CFL. You don't know, that's A power n, B power n, C power n complement is CFL, but this is not CFL. because you wanted example, right? I'm just showing it. Regular minus CFL, I'm showing that it is need not be CFL. It is going to be a CSL. Got an example? Right. So this is a very complicated, if you don't know that A power n, B power n, C power n complement is actually CFL. Take this example as L2. Then when you do it, its complement back to A power n, B power n, C power n. There you will see the answer, not a CFL. When you do intersection with A star, B star, C star, you will get this as the result. This is equal to what? A power n, B power n, C power n. This is actually not CFL. Okay, got it? That's what, some of the examples we cannot come, but if you really want to remember, you need an example. You need to, ask doubts, and you need to discuss, you need to involve how I am doing this, all the things, right? 67. So we are trying to do whole TOC in half day almost. For a string W, we define W power R be the reverse of W. We know that, no need to do. W is this, W power R reverse is that, and which of the following languages is context free? Okay, just do it. You need a context free language from this. We have seen a lot of questions like this, right? Let's come up with the answer, guys. Yeah, let me refresh once. B, C, D is MSQ type. Okay, they forgot to mention MSQ. Okay, MSQ. Context free. So is this possible to be context free? That you need to work on, right? So there is a dependency. WX is there and W power R is coming here, and that's the bottom of the stack, and you need to cross check this. Is there any way to do that? Okay, A, it looks like very complicated, right? You can't. So this one is already regular, we know it, which comes as 0 plus 1 whole star. W you can put epsilon, X can do everything. And what about this? Is there any possibility? W you push and you can pop, again push, again you can pop. So there are two things, right? You can do individually. So you can build a stack, or you can do something like this. I'll write a grammar. S derives A dot B. What A will do? A will do palindrome, B will also do palindrome. Both will do palindrome. Let's try that. A will do A or B or epsilon. Even what B will do? B will do the same. A or B or epsilon. So this also doing W power R, and this also doing another W power R. We can call it XX power R. So that's all. I'm able to write a grammar, so you should believe it is a CFL. Are you getting my point? So why I'm able to do the CFL here, but here you can't do it, because there is, W goes bottom of the stack and X comes above, and W power want bottom of the stack. That's going to be complicated. And this one, W you push, X you push, and X power R is coming immediately, right? W power R you need to pop with this. Can you write a grammar for that? So let me try that too, right? This you understood, right? You understood the first, which one? The option C, right? Option D, let me write a grammar. So how do you write? S derives ASA or BSB. This can guarantee W power R, but I need somebody A to represent again this one. This I will do with the capital A. So that S can do this W power R, but to end this, you need a capital A. What capital A does is going to do XX power R, like A or B or epsilon. So this one will guarantee the D. So this is also CFL. Now the question is, which of the following are CFL? B, C, D. Okay. Is saying that X is epsilon, but double X you can't take epsilon because X is also dependent, right? You need to have a dependent like this. Let's say ABB. I have something, let's say AB. This is X, and W power R depends on this BA, and then X power, this is reverse BA. So this is X power R. Now W power R cannot generate this. That's the issue. W power R, if we put X is epsilon, right? W power, can it do it? No. If it is, the whole string is equal to W power R, then it's fine, because X is also having a dependency. If you are eliminating X, then W power R can't do this. Can you assume this is a W and this is W power R? Is it matching like this? No, right? You can't. When you can do that substitution, when you have X is alone, you can eliminate, and X is doing everything. So you should believe that even W, you want something 0 1, that 0 1 X 0 1 0 is already covered here. That's why we don't worry about that problem. Okay, don't do that mistakes. Yeah, don't substitute unnecessarily. Here you may do it, put epsilon, but X can do everything. That's why you are believing X. Suppose length of X is equal to, when this is going to be a not regular. So understand, this is regular because X is not restricted. If X is restricted like above, X is depending on somebody else, then you should analyze properly. Okay, so do that. Question 67, 68. Let L1 be the regular language, L2 be the CFL. Which of the following is or are context free? Again, so regular, so keep writing it. So let me write R for the regular, C for the CFL, so that it will become easy. Okay, R intersection C complement. So R intersection C complement is CSL. So R intersection CSL is a CSL. So we don't say this is a CFL. Now L1 complement, L2 complement. So let's try that. What is this? What is the De Morgan's law? When you apply the complement here, what happens? L1 intersection L2. So you know, right? L1 intersection L2. This is exactly same as when you apply the De Morgan's law, right? Complement gets cancelled. Union will become intersection. L1 intersection L2. L1 is regular. L2 is a CFL. So definitely this will become CFL. So don't do unnecessarily complement first, because complement of complement you will get back to the same CFL. So should be careful. Okay, next one. Here L2 union L complement is a sigma star. So L1 union sigma star is equal to sigma star. So understand what is this here, L2 complement. When we do CFL complement, we assume CSL, but this L2 union L complement, you know, it's something different. So you need to understand this component. So this is also getting regular, in fact. And another one you need to observe, L1 intersection L2 union L1 complement intersection L2. So what does this means? Let's try. The L1 is regular, intersection L2 is what? Anybody answer this question? B, C, D. D also coming? Okay, what is that? Any concept here? L1 complement intersection L1 intersection L2, L1 complement intersection L2, the union, what will happen? Any short form? Let's see, anybody answers that. C. Yes, B, C we got. D also you are saying, right? So let me depend on you. Why D is context free? Okay, my question is, why D is context free? Before analyzing, how did you say that? Common portion, then L1 outside, you are common with L2. What is this concept? Any idea? So you use the Venn diagram or anything, just you can easily conclude. L1 intersection L2. So this portion comes common, right? L1, L2. And you are doing L1 intersection L2. This portion union with L1 complement, this assume this is a whole, the L1 complement is outside, intersection with L2. So L1 outside intersection with L2. So this is only the common portion, right? When you do the union with this one, this is the L1 complement intersection with L2. When you do the union, what happens when you do the union these two? You will get the whole L2. What is L2? L2 is the CFL. So this is how you need to understand, because they use the Venn diagram concept to explain. If you come up with some other way, like regular intersection CFL, regular complement, regular intersection CFL, CFL in CFL, that is another way to do. So just do accordingly your understanding, right? So you can also substitute, you can do very quickly. But when they do L2 complement, you might have a trick like this. There is another way. What is another way? Put CFL, regular intersection CFL here, and here regular complement intersection CFL, this is also CFL in CFL is CFL. So do another way directly. So that is also possible. Okay. So many ways to answer this question. It's fine. Question 68. Then 69. Okay, any tricky in this question? Which of the following is true? Oh. Regular or context free, just we need to find out. W everything, and what is this a power n? So can you conclude this answer when n is equal 0? See what I am doing here put n is equal 0. Why I am doing this? Because you are getting this L1 is equal W. So W is a plus b whole star. Now when you have this one, you no need to ask, sir, where it is going a power n. That is always there here, right? So if you want a power 100 before last a power 100, that is also covered. Also, if you have a power 100 before last a power 50, still it is covered. So this is a more powerful language than what you are thinking, just a power n before after. Okay. Another one, wx w power r. Length of w, length of x greater than 0 means whole plus. Whole plus we already know it is regular. This is the second time we have seen, right? Second or third time. So both are actually regular. Now the question is what? L1 and L2 are regular, and L1 and L2 are CFL, and L1 is regular, L2 is a CFL. Did they ask any strict answer? No, right? True only. L1, oh, this is only D is wrong. So A, B, C are correct. In fact, correct. You can say both are regular, you can say CFL or regular, doesn't matter. But don't ever say not regular, not DCFL. That will conflict with the answers. Sorry. Question number 70. Oh, what is it? False. And the question is about context free. This is how you conclude, right? Don't unnecessarily read the data. First, when the randomly languages are given, so look at false or true and look at what they want, context free or regular or DCFL. Then focus on the terminology. So DCFL is terminology and CFL is the terminology. So now you focus on what is this, right? So WW, what is WW? This WW is not a CFL. Of course, we know it is a CSL also. Okay. And this is not CFL, but also we know it is a CSL. And this one is A star, B star, C star. Oh, no, sorry. This is something different. A star, B power n, C power n. This is a DCFL. Now, once you have this, just follow the options. L1 is not context free, that's true. But L2 and L3 are DCFL. So this L2 is not a DCFL, right? So option A, false. You need to choose the false statement. You need to choose the false statement. Okay. So this is the false. And option B, L1 is not context free. L2 is also not context free. Neither L1 nor L2 is a context free. This is a true statement. Don't choose true because they want the false. Okay. Option C, L2, L3 and L2 intersection L3 are context free. Just you need to look at L2, L3 are actually not context free, right? But they are saying context free. Here only the false statement happened. Don't worry about unnecessarily, don't waste what is L2 intersection L3. Don't, because L2 already we know it's not CFL. He's saying CFL, choose it blindly, it is a false statement. So this is a time saving factor. Even though L2 is answering, right, complete the statement, that's enough. L1 and L1 complement is not context free. That means neither L1 nor complement is context free. So L1 is not CFL, but anybody doing L1 complement, this is what I am saying, right? WW complement is a CFL. And not only that, L2 complement is A power n, B power n, C power n complement. This is also CFL, but which are not DCFLs. Remember that too. Okay. So L3 complement, in fact, DCFL complement is DCFL. So these two are very special languages, but this statement is false. This statement is false. L1 is not CFL, but L1 complement is a CFL. But he's saying that L1 and its complement both are CFL. That's wrong statement. Okay. Even you don't need to worry about complement. Why? L1 is already answering. L1 is not CFL. Oh, he's saying what? The statement, I'm sorry. It's not either, right? It's neither. Neither L1 nor its complement is CFL means L1 is not CFL. L1 complement is not CFL. So this is only going to answer you, right? L1 complement is CFL, but he's saying that L1 complement is not CFL. So that statement will answer you, not L1. L1 complement will answer you. And you have A, C, D. Who is not answered? Yeah, B, C, D answered. Who is a true? We don't answer, yeah. True, we don't answer. This is going to take the time, right? BD. Why BD? L1 and L2 both are not context free. That's correct. We need to choose a false statement or don't choose the true statements. right? Come on, come on. Who is answering? What is answering here? L2 is the CFL. Oh, I'm very sorry, yaar. The whole statement is gone. I'm very sorry. I'll repeat it, this question. So that's my assumption. Okay, I'm very sorry. So let me do one more time. I'm very sorry. This one we know, not CFL. My assumption, it did not see properly this one. This is M, right? So I was assuming this all are power same. That's why comments will help me. This one is in fact DCFL. Okay, and this one is almost same, right? These two are dependent, these two are dependent. My eyes are not seeing properly, guys. I'm very sorry. So now you answer again here. L1 is not context free, L2 and L3 or DCFL. Oh, this is the right statement. Because of my first assumption, it went wrong. Anyhow, so please, that's fine. We are doing continuously, not observed here. This is M. Neither L1 nor L2 is a context free. Oh, L1 and L2 both are not context free. Wrong, right? This is a false statement. Why false? This is the true. True, we don't tick. False only we don't tick. We'll tick. Okay. How many mistakes here? L2 context free? No. L2 is context free, right? That's correct. L3 is context free. That is also correct. And L2 intersection L3, DCFL intersection DCFL. If we do this intersection right, what happens? Now it comes as A power n, B power n, C power n. This is not context free. Because of this statement will be false. So false statement will choose. False statement will choose. Okay, please do it accordingly. L1 is, okay, here already we have chosen this is a false statement, right? L1 and this we have analyzed already, right? So use the same answer. Yeah, now we got the answer. The BCD. Okay, yeah, how difficult, yeah. If you don't look at even one power, then we gone. 2022 is really good. Okay, that's good. With a patience, we can get right answer. Yeah. Anyway, we are at the end, right? So I'm just thinking about to finish the CFLs as soon as possible. Take a small break. Okay, is that completed 70? We are lucky if we completed. Yes, very good. So we need a break, yeah. So now almost 2, right? 2 am. Just take our 10 minutes break to 10 am back. Okay, we'll resume. If possible, 2:15. If I don't come at 2:10, so just go for 2:15. Okay. Then have water but don't go for the sleep, because we can see half of the students are already going for the sleep now. We can see in the chart, right? Yeah, we'll wait and then we'll complete the remaining 30 questions possibly, but I will do as soon as possible to complete, but don't worry. Okay, we'll just wait for 10 minutes. Yeah, this is going to be the very important topic. Next 30 questions to analyze. Okay, 10 or 15 minutes. Take a break, then we'll meet back. Bye bye. Good morning to all. Yeah, good to see more than 100 likes. Yeah. Good morning. Looks like just woke up now. How many of you are woke up just now? Yeah. It's okay for practice. You can do it continuously, but never prepare continuously, because preparing continuously, you need to remember a lot of things, right? So for that you need breaks. That's why in every 2 hours I'm giving the break, that I don't want to overlap the things in the brain. It is that a break makes to refresh. Earlier I used to do continuously for hours and hours, but that's not the good strategy, I felt. Okay, good morning to all. Let's see how long it goes. This morning I have to go for the duty there. Movie. Who is that profile pic movie? Hello, Arjun. Let's begin. Show in the chat. Let's begin quick. Are you ready? Are you want to talk something relate to anything? AKTU students are having university exams. Okay. Yeah. Come on, yaar. You're not discussing at all. Please, everybody should appear in the chat. यार सब chat में कुछ तो discuss करो यार, तो सभी पता चले यार लोग not sleeping. Ready? Virak, I didn't understand. Is it possible to cover max syllabus in 15-20 days as GATE exam is on? What is max syllabus? How much you have done, right? That depends. Bhagwan. MTech days are, it's okay. Let's complete today. Tomorrow we have the compiler, right? There we will discuss. MTech, oh, you do not aware of that. So I did MTech from IIT Bombay. Okay. Fine. You can search my name, right? You will find every detail of mine. Just Google search my name. You don't need to ask anything about me, right? Okay. Turing machine. Let's begin now. First question, which of the following pairs have different expressive power? So this is a combination of all the topics. That's why the question came to the last one. So how many questions we have completed previously? 70. Yes. Now we'll start with the 71. Deterministic finite automata and non-deterministic finite automata. Do they have different? Because we need to choose different. But here equivalent. So equivalent symbol also we know, right? This one. So we don't choose this. DPDA and NPDA. Yes, these are not equivalent. The reason is you need to remember an example that W power R, or you have A power N, B power N, C power N complement. This a CFL can understand, but DPDA cannot understand this. So there are many such examples, WW power R and WW complement. Many problems can understand by PDA but not DPDA. So these are different expressive power. What about other one? A deterministic TM and non-deterministic TM, single tape or multi-tape, doesn't matter. They're always equivalent, okay? So we need to choose not equivalent again. Single tape Turing machine and multi-tape, they are also equivalent. So don't worry about them. Yeah, simply B is the option. Many times it was a gate question, right? Shivam, yeah, we'll see. So yeah, there is one more relation somebody written. Yeah, DPDA we can say not equivalent to NPDA. And what else we can say? DPDA is not equivalent, we know, but it is having expressive power is less than NPDA. What is the meaning of this one is actually the languages accepted by DPDA. If you collect all of them, right? If you collect all the languages accepted by DPDA are inside the languages, LS means languages accepted by that PDA or NPDA. So this is the actual relation. That's why we have this expressive power, less expressive power for DPDA, more expressive power for NPDA. Okay, 72. Easy questions, right? False statements you need to identify. Can you identify, tell me the answer so that I can start discussion quickly? for every NTM, there exists equivalent DTM. So NTM, there is an algorithm to convert into DTM, like DFA to NFA to DFA. So that is the reason every NTM you can convert to DTM. There's subset construction again. The Turing recognizable languages, recognizable means RELs. Remember that Turing recognizable means you are talking about recursively enumerable languages, RELs only. Are closed under union. That's correct. Union, because REL union, REL is REL, but complementation is not closed. So if anybody asks, right, REL complement is, what is the exact answer? Is need not be REL. But this is also may not be asked in the exam sometimes. What is other answer you can provide? It is either a recursive language. If not a recursive, it goes directly not REL. So these are only two possible answers you will be having in the need not be. So this is one of the important concepts. But other languages there, RE which is not recursive, that never happens. So here the meaning of this one is never be. RE but not recursive. Within the RE class, but which is not recursive, never happens. So this is the one language name, remember that. Okay, RE but not recursive never happens when you do the complement. So this complementation is not closed, union is closed. Which of the following is false? You need a false, right? So this is a false statement, because they are saying that complement is closed, but we know it's a complement is not closed. Your chart is not visible here. Please do, at least in Turing motion, I need the chart response. If you don't do the response right, I think here and there. Always look at the chart. Okay, every option is important. Turing decidable. Decidable languages means recursive languages. Recursive or decidables all are same. Recursives are closed under intersection. Yes, correct. Union also correct. Complementation correct, because recursive complement is always recursive. So if you want to understand the recursive language complement is always recursive. So complementation is closed, even intersection is closed. This is a true statement, so don't choose it. This is a true. First one is a true. Second one is false. Third one is true. And fourth one, Turing recognizable means RELs. Again, we are talking about RELs closed under union and intersection. Yeah, intersection of two RELs, union of two RELs, not an issue. So this is also true. So only we'll choose the false. Only two. Option C. Anybody answer that? Please answer it. You did not answer for this. Option C is the correct. So if you want to remember some, of this languages, right? So remember this point. When they talk about equivalents, you should know, right? DFA, NFA are equivalent. In fact, you say just finite automator, that's fine. TPDA not equivalent to PDA. Remember this point. Are same as, this is the same as DPDA not equivalent to NPDA. Both are same. PDA and NPDA are actually same synonyms here. Okay. And here PDA and DPDA, NPDA are actually same. There's no difference. They are same. And LBA, they don't ask ever. TM is equivalent to DTM equivalent to NTM. In fact, if they ask variations like single tape TM, multi-tape TM, universal TM, so never miss them. They are all equivalent. In the exam, they keep on changing the words. So just remember that. And anything else, if they ask two stack PDA, so all are equivalent. And when they talk about the union, intersection, complement, so remember union, intersection and complement. So these three for RELs, these two are closed, but this is not closed. For recursive languages, so I'm just putting as S. Recursives all are closed. Okay. Yeah, we'll see in the revision, Maha revision we have, right? So there we will see all the shortcuts for the remembering. Meanwhile, you keep understanding the operations. We'll put a shortcut there. Okay. Because even I don't remember the shortcuts unless I write them. Okay. Yeah, I'll give the shortcut, Bhagavan. Don't worry, Bhagavan. So you have the schedule, I guess. One day the Ankits are given the revision schedule. Please follow that. Okay. Mostly in the last 10 days of the January, you will be having the revision. 73. Can you do it? So this kind of questions are regularly happening in the exam. Most of the questions are similar. So first you need to do two things. First, this is the language. So focus, whenever this is given, focus on the problem. Problem, language, both are different. I'm focusing on the problem first. Problem is whether M accepts 2014 length string, that string of length 2014. This is the question, this is a problem, and the language is collect all the machines who are accepting the string of length 2014. L is that, L complement is who are not accepting the string of length 2014. So everything is important here. What is the problem? What is the language? What is the complement of the language? What is the complement of the problem? Remember my words. This chapter is going to depend on two things, the problems and languages. If you can understand the problems, the languages are going to be so easy. Most of the time, the decidable and undecidable concepts are derived from the problems. Okay, so this problem will decide this language. If this problem is decidable, and this language will be decidable. In case if this is not decidable, then that will be also not decidable. So here it's a very important, what decidable is only one option, but what is undecidable? So remember these words. Undecidable is having two meanings. When it is undecidable, it may be real. When it is undecidable, which may be not real. So undecidable, you have two options. You need to know exactly which two options are going to be. So now let's talk about this. This problem will have two answers. How many answers you will have? Yes or no. Yes or no. So which one you can provide the logic that halts always? So if both are having logic, this problem will have halting Turing motion. So this problem will be decidable. Hence this language is decidable. Look at what I am doing. If only S is having a logic, then answer goes to that undecidable but real. If answer is not there for S, then that answer goes to here. So do you have the answer for both? Do you have answer only for this logic? Or do you don't have a logic here? So three problems we have totally. Again, both have a logic. That means you can go to the first option, decidable, recursive indirectly. Only S has a logic, then answer is real, which is undecidable still. If S is not having a logic, then you go for this. Okay, so focus only on S. Do you have only S is the logic? Do you don't have a logic for S? Do you have the logic for both? So these are the three things you are going to analyze. Right, that's why I'm giving you definition, so please understand. So in case if you are really confusing here, just look at this. L may be decidable, it means recursive. L may be undecidable, in which you have two types. One is RE but not recursive. Inside the RE also there are undecidable. There is outside RE class. They are not RE. Right, total you have three types. Language or problems. For both of them, these three cases are there. Decidable means if it is a problem, right? If it is a problem, yes, I know both will have a logic. Both will have a logic. That means HTM exists. That means HTM exists. RE but not recursive means yes, only will have a logic. It's clear that no, you cannot provide a logic. The meaning of this one is, of course this meaning you understood, right? This means only S has a logic. Here, yes, no, we don't know, but S will definitely have a logic. No logic. S is not having a logic. Logic not exist. We don't know about no. No may have a logic, no may not have a logic. That depends on which not real you are talking about. Okay. Everybody are. Anjali, if I don't teach for the 10 years, even all these concepts will go from my brain out. Okay. But only definitions can provide the right answer for every question. Now the problem is S means the M accepts the string of length 2014. No means M does not accept the string of a 2014 length. So we will have a logic. It's just like a membership problem, right? 2014 length, how many we don't know, right? But if it is exactly one string, that's a membership. Now such strings are there, finite number of strings with 2014 length. Now S, why we have a logic? Because if that string is accepted of a 2014 length, then definitely the machine will halt at final, right? Machine will halt at final for some string who is some string of 2014 length will halt at final. So this will have a logic. What is the logic you will have? The TM halts at final. When it is halting, that means you got a logic. Halts at final. For some string which length? 2014. Now no means the machine doesn't accept the string of length 2014. First, how do you know the string doesn't accept? What logic you will say, you will give for the no? The machine may halt at non-final or may not halt. If machine is not going to halt, then you will never come up with the answer, right? All the strings of 2014, let's say machine is going to loop, like never halt case, then you will never come up with the answer. No, you cannot provide the logic here. No is not having a logic. No logic for this. Logic not exist. The logic you will try when you are trying for the logic, right? The machine may halt at non-final. That's the logic. Machine halts at non-final is the logic, but you cannot guarantee always halts at non-final. So what is going to happen? Machine may never halt. Then in that case, you will never provide the answer. This machine is not going to accept the string of length 2014. So when it is going to accept, you have a logic clearly. You can stop and you can provide the logic. But when the machine is not accepting the 2014 length, you cannot provide why it is not accepting, because every string of 2014 length, when you verify, everybody might never halt. Then Turing machine never halt. You will never come up with an answer, right? In case if every string it is going to halt, whether it is valid or invalid, then you can come up. That's the halt in Turing machine happen. But this problem is about the Turing machine. This problem is about if this Turing machine were changed to halt in Turing machine, then both the sides you will have a logic. So if it is a halt in Turing machine, definitely this problem could have been decidable. But anyhow, S has a logic, no has no logic. Which one you will choose? You only tell me now. Which one you will choose? Will you choose decidable? No, because both should have a logic, so you can't choose it. And will you choose undecidable but REL? Yes, this is what only S has a logic here, so we'll choose it. And undecidable but not REL means this should not have a logic. S, don't worry about no, S should not have a logic, but this you can't choose it. Decidable but not recursively enumerable. This statement itself is wrong because every decidable is not REL. So this statement you no need to look at all. This statement itself is always wrong. Doesn't matter which question is given in the exam. Decidable but not REL never happens because every decidable should be REL, right? So remember this point. Option D never be true for any question in the world. Okay. So A, B, C, out of them B is the right answer. Yeah. All right, any confusion here? Only the confusion might happen how to analyze this question, right? For this question, understanding you should spend more time. So how you should understand that also I will help you. So the question is, suppose here M is given. Let's say M is given. See that M is input. Now you need to understand what do you have here. What exists? Do you have TM or TM? What exists? TM or HTM? Or no TM, we don't know, right? TM only, HTM, or no TM at all. So three cases might happen. What do you have? If it is having HTM, yes and no will have a logic. You need to understand. If you have TM, only S will have a logic. If you don't have a TM, this will not have a logic. So HTM you will look for both. For TM only, no TM, just look at this, you will understand. Only S or no S at all. Now the problem is this M, question is what is TM, that M is TM accepting 2014 length, right? String, some string, any string is fine. So what you are going to do, you are going to do like this, look at that. So 2014 length, how many you have? Find it only, right? 2 power, let's say double sigma is equal to a comma b, 2 power 2014. So you will try like this. You have a TM, ask W1, and W1 of which length? 2014 length only. W1 2014 length only, remember. But how many you have? Like 2 power 2014. So TM, you will ask W2. You keep on asking it. You keep on asking it. Don't worry, don't wait. How many TMs? How many? Only one TM. But you create the thread and ask the last one W2 power. Let's say this is a 1, 2, 3, right? So let me write a subscript. W2 power 2014. Assume sigma is equal to a comma b you have. Then how many 2014 length strings? How many 2014 length strings? 2 power 2014. So the same TM, I'm asking different W's, right? The question is, if any of the string, for any of the string, the TM halts. Why different TMs? Because one TM I can't believe, this might go infinite loop, never halt case. That's why same TM I keep on creating a thread. This because I have infinite tape, I can create the threads. These are all threads. So this TM, I'll ask the W1, but I don't wait for that. I'll keep on doing it, but any of the thread, I'll run another Turing motion to check is anybody halting at final. If anybody halts, because finite number of strings, and if anybody halts at final, definitely I can find that position, right? So if any TM halts at final, then stop. That S will have a logic. If any TM, how many TMs I have created? 2 power 2014 TM threads I have created. If any TM halts at final, any TM, but out of how many? 2 power 2014. If any thread halts at final, then you got the logic over answer. That means the 2014 length is accepted. Halts at final, that means you got a logic. No means you can't understand, because everybody might halt at non-final, then that is fine, but you can't guarantee. Everybody might never halt, or some might halt at non-final, some might go to never halt, then you don't understand. If you get a situation never halt here, let's say this TM going to infinite loop, then you can't wait what it is going to happen. Is it accepting or not accepting? You don't understand. We know it is not accepting, but we don't know how to check that. That's why this no will never provide a logic. I don't understand. We don't understand. No logic for this. Logic not exist at all. Okay? Everybody, it takes time. Every question we can't do this way, right? But that is what I am speaking all the time. So when I am speaking for the question, please watch this video slowly and understand every word and every statement. You will get the same conclusion what I am explaining. Okay, done. So in the future you will see like this. M is a TM that accept 100 length string, or that accepts a string, they don't mention the length. All the questions have the same concept, but length is mentioned. When the length is not mentioned, then TM accepts some string. Some string means what we will do here, the length we don't take. What we do, same TM, but we don't know sigma star, infinite strings are there, W1, W2, W3, keep on going like infinite strings. But anybody accept, you don't need to go to infinite string. You will halt at some final, you will halt at final, then you can come up with the answer. But if everybody is not accepting, then you are in trouble. So S will have a logic, no will not have a logic. Anyhow, this problem is undecidable, but in that undecidable, you have a partial logic. That's why we say is real but not recursive, because I'm not able to create the logic here. That's why I can't build HTM. That is the meaning. Okay. Question number 73. Okay, remaining I may not go this much in detail explanation, but you understand please. 74. Right? Yeah, please do something in the chat, yaar. If you are only sitting idle, I can't help, right? Keep asking the doubts. This topic is only you will get an idea when you involve more. Okay, what L1 is regular, L2 is CFL, L3 is recursive, L4 is REL. Which of the following are true? So what is this question? L3 complement. What is that L3? Recursive complement union. Recursive complement union. L4 is RE. Recursive complement is what? A recursive union RE. So they are only saying is RE, right? Yes, you can always say RE, but we don't know it is recursive or not. That's true. So this is the true, no doubt. This is the true. Ishwar, that is a problem. Never say semi-decidable. Ishwar, no, you have come up with the wrong statement. You have come up with the... So these two are actually semi-decidable because both are REL. So this is the one problem people might face, and this one both are actually what? RELs. RE, right? Both are what? RE. This is RE and this is also RE. RE another name only is semi-decidable. That means every decidable is semi-decidable, even RE but not recursive also semi-decidable. So when both are semi-decidable, so only you can't say this is a semi-decidable. That's a wrong statement. How do you say? Semi-decidable but undecidable. This name is, you have another name, SD and UD. This one UD but not SD, not REL. It means there are many names that you need to understand by the practice. So don't say this is just SD, wrong, because this is also SD. Every decidable you can say semi-decidable also, because it's just synonym of recursively enumerable. Every recursively enumerable is partially decidable. Okay. So that's one more problem with the semi-decidable word. Initially also I used to do that mistake. Okay, first one is RE, that's fine. Next, L2 complement. What is L2? Is a context free. Context free complement is context sensitive. Union recursive is the recursive. That is correct. Okay, L1 star. What is that? Regular star is always regular. Regular intersection context free is always context free. Correct, right? Regular clinic closure is always regular, because clinic closure you have a proof. Even regular expression has a star as a proof. And L1 is regular union. Context free complement, no guarantee of context free. So this makes a problem why we are not saying context free. Okay, may or may not be context free. We can say like this: L1 union L2 complement may be context free. That's right statement, but is there, so we can't say always. So this statement is false. 1, 2, 3. This one. D is right answer. Okay, done. 75. Take time to understand each word, each sentence, that especially in this problem, in this chapter, right? You try to read every statement. Do not skip like finite automata and PDA. That might be easy to skip, but here you can't skip. One word can change the answer. Okay. First L of R is the language represented by regular expression. Okay, so it's about regular expression. Or G is the language generated by O. G is the CFG. Remember that. M is about Turing machine. So they are talking about regular expression representation, CFG representation, and Turing machine representation, right? So understand, they clearly mentioned it. Which of the following problems, these are called as decision problems. They may be decidable, they may be undecidable. The problems we need to find undecidable. So you are not worried now. Is that semi-decidable or not? We are not worried now, right? This undecidable may be RE but not recursive, or maybe not REL. Don't worry. This is the one of the easiest question. You can answer with the help of the table. Okay. Now just let's look at the each statement. What is related to? What is related to? Regular expression or string W is W belongs to L of R. It is called as membership problem. What is the definition? Membership problem. Which languages you are talking about? For regular languages, for finite automata, for regular expression, for regular grammar, for LLG, for RLG, same definition. Membership problem for finite automata is decidable. D means assume decidable. Okay. Context free grammar, this is equal to language generated by grammar is equal to empty. So this is emptiness problem. Emptiness problem, how do you solve? Using simplification of the context free grammar. Okay, so this is also decidable. Emptiness, finiteness, membership, what else? Halting problems are decidable for context free languages. Given context free grammar, is it generating everything? This is called as totality problem. Totality problem and equivalence problem is undecidable for 3. This is undecidable. Totality problem is undecidable for the context free grammar, because there is no algorithm to verify whether the given context free generating every string. That we don't have an algorithm, right? But you can design a context free grammar to generate the sigma star, but they didn't ask. They will give you grammar, you need to verify. That's not having an algorithm. Okay, given Turing machine and string W, is that given string accepted by the given TM? That's a membership problem again. Which problem it is? Membership, for the which domain? Turing machines. So membership for TM is undecidable. Of course, everything is what? Undecidable for TM if it is, you know, non-trivial problem. Yeah, 3 is what? Totality, also called as completeness. Both are same. Totality, also called as completeness. Okay, whether it is having Turing machine or not, please check. That's a difficult question. These two are undecidable, but you may have a Turing machine for any one of them. For this, you have a Turing machine, still it is undecidable. Turing machine can understand this problem, right? Whenever the string is accepted by Turing machine, then another Turing machine can understand why it is accepting. Okay, so this 3 and 4, just cross check what is it. So 3 and 4 are undecidable. D, how many of you answered? Please try to answer it properly. Okay, D. Question number 76. So go slowly because there is high probability to misinterpret the questions, especially when you are with undecidability. Go slow and understand each sentence, what you are trying to analyze, then answer it. Some M denote an encoding of an automaton M. Which automata they didn't mention, could be any automata according to this data. Suppose that sigma is nothing but 0, 1. Which of the following languages is not recursive? Not recursive means not decidable. Not decidable means undecidable. Okay, not decidable means undecidable. They are asking which of the following is undecidable. That's it. Clear? So you need to identify who is undecidable. Okay, so now before understanding the language, just understand the problem. So M is given. If DFA is given, can you answer it? Is L of M equal to sigma star totality for finite automata? Is it decidable or not? It's decidable. So this language is also decidable. There are two things here. So convert this language into problem all the time. If I give you DFA, do you have an algorithm to verify is it accepting everything? Okay, totality completeness problem for finite automata is decidable. Why it is decidable? Just learn, right? You can do another way checking, like emptiness you can convert. Complement of language you do, that should be equal to pi. Then the L will be sigma star. So by doing the complement also you can write emptiness algorithm. Anyhow, so next one, the totality for PDA. What is this? This is totality or completeness for finite automata. For finite automata it is already decidable, so it is decidable. And this one is also totality. Totality means is that given PDA accepting everything. So totality for which machine? PDA. This problem is undecidable, so we will choose undecidable as the statement we need. Next, emptiness. Emptiness for PDA. This problem is decidable or undecidable? Decidable, so we don't choose it. Okay, you can use a simplification algorithm for this, simplification of the context-free grammar. So what is the approach here? You take the PDA, convert to context-free grammar, and this context-free grammar you apply the simplification algorithm. Okay, then if you have at least one production, that means it is going to generate non-empty, otherwise it's going to generate empty. Next, this is emptiness for the Turing machine. You know, it's everything is undecidable here, all the problems for Turing machines, but some problems are trivial problems are decidable. We'll see if anything comes. So B and D. Sean 2021, is it MSQ? Oh, it's a DFA. Sorry, I'm very sorry. So I did not see it. So it's a DFA. So I was assuming it is a Turing machine. I just explaining Turing machine only there. Okay, so please, it is a DFA, right? For DFA everything is what? Decidable. I'm very sorry. You're correct. So please remind me if I'm not looking at data properly, because I was assuming it's a Turing machine question. But the Turing machine emptiness is undecidable. If anybody want shortcut for this, right, you just remember something like this: halting, membership, what else? Emptiness, finiteness, and totality, equivalence, disjoint, what else you have? Set containment. So these problems, just make a table, a very simple table. For finite automata, everything is decidable. Everything is decidable. So you can write a D or tick, whatever is your choice. Decidable, all are. Which one? For finite automata. For Turing machine, right? Everything is undecidable. So for these two columns, you don't need to remember anything. It's very simple. All these problems are what? Decidable for finite automata. All these problems are undecidable for Turing machine. But remember, halting, membership, emptiness, finiteness, totality, equivalence, disjoint, and set containment. Or in set inclusion, what is that? Set containment is nothing but subset checking. Another one, the DPDA and PDA. What else? LBA or HTM, both are here going to be having the same answers. Okay, that's why you can keep same column. LBA anyhow we don't have in the syllabus. So here you have a pattern, particular pattern that you can remember. What pattern you will follow? These are decidable up to this three, right? Only remember this middle one. And emptiness, finiteness are decidable up to here. And totality, equivalence up to here. And that's all. These are not. So you can remember this table. Up to here you can remember, right? You can just remember these things. Especially focus on these things, you will get easy logic. Yeah, so there is a shortcut Swagatin is saying, right? Headmaster effectively teaching data structure. Yeah, this was a shortcut I made earlier, so you can follow that. Is already kept in the chart. Is given language regular? Really, we don't know what the conclusion. There is no algorithm to verify whether given language is regular. Only we have the concept understanding. So we have, but there is no algorithm to check the given problem is a regular or not. Only by understanding. If it is regular, we do it. If it is not regular, we don't have a logic. Okay. But there are theoretical concepts like if that language has finite number of equivalence classes, it is regular. Infinite number of equivalence classes, it's not regular. There are some proofs, but there is no algorithm to verify yes and no. Okay, that's one of the difficult question what you are asking, Himanshu. Unknown problem, it's difficult. That's why so many unknown problems are there in the world. Still need to find out. Okay, so make the shortcut according to your requirement. 76 done, right? 77. Oh, Turing machine problems are not there. That's it. Anyhow, this undecidable is also with the Turing machine. It's not different. Turing machine and undecidable both are not different. Both are combined. Okay, so don't worry about that. 77. Let L1 be the recursive. L1 is what? Decidable or recursive. So let's write REC means assume recursive, decidable, all are same. L2 and L3 are what? REL. Oh, this is different. See, L2, L3 languages that are REL but not recursive. So this statement is a single statement. Remember that? REL, RE but not recursive. You might know this language, right? What is the meaning of this? What is the meaning of this? You have these are RELs, these are REs, and these are what is L2. L2 stands here and L1 stands here. It's clear. But if anybody say REL, you don't understand, is it staying here or here? So you are very in confusion. Anybody using the word L is REL, be careful. This might be here or here, you don't know exactly. It might be recursive or it might not be recursive. So this statement is so confusing. I'm saying I have a Turing machine, but I'm not saying is it having HTM or not. So L is REL. So be careful. This could be recursive or not recursive. Okay, but these statements are very clear, very clear. Recursive means both valid and invalid will have a logic. RE but not recursive means only valid strings will have a logic. You have a very clear concept what we are speaking here. Now let's see this concept. Which of the following statements is not true? Okay, is not true, we are going to see. Not true means false statements. Not necessarily true means not true only. Okay, is that L2 minus L1 REL? Just check. L2 is what? RE but not recursive. Minus recursive. Let's see. RE but not recursive. Minus recursive, right? L1 is recursive. So can I say this is RE, minus means intersection. I can say intersection recursive complement. Right, this is RE which is not recursive. RE but which is not recursive. Now recursive complement is what? Recursive. So intersection I can write still recursive, and this is some RE, right? Definitely RE but not recursive means some RE. Definitely outside the recursive, but some RE intersection recursive, you can always prove it is RE. Okay, we don't know RE but not recursive, but still definitely this has a Turing motion, this has a Turing motion, and you can definitely say REL intersection REL is REL. So this is only that saying REL, they are not saying any recursive, right? Recursive, no guarantee. Okay, even RE but not recursive, no guarantee. So it is guaranteed only RE. So this statement is true, but we want false statement, we want not true statement. This is the true, so we don't choose it. Now L1 is recursive. L3, where is L3? Reverse, right? So now this statement, recursive minus L3 is also what? RE but not recursive. RE but not recursive. Now see what is the interesting fact. So you should know this. Recursive, L1 minus L2, you can always write L1 intersection this complement. RE but not recursive. Step by step, just follow the definitions, nothing else. And this complement, what happens? RE but not recursive means only valid strings will have a logic. Only valid. When you do the complement, the valid strings will not have a logic, because invalid strings of this will become valid strings of the complement of L2. So when you do this complement, right, this REC intersection, this problem will become not REL. Then REC intersection not REL. God will understand, because this problem is not having a Turing motion. You are doing intersection with alternate Turing motion strings. Then the language recursive intersection, the language which is not having any motion at all, right? So it's not a computable problem at all. We don't understand what's going to happen. So you cannot answer. This is, you are saying REL. So this is a false statement. We don't know what will happen. May have the may be REL, may not be REL. We don't know. We don't know at all. Okay. If anybody says may be REL, then you may fact, because this is not about maybe, it's about guaranteed always statement. Okay. Next, L2 intersection L3, that L2 L3 both are RELs only. REL intersection REL is REL. So this is a true statement. Anyhow, so far we can choose this statement B is not true. Not true we need to choose, right? Not true. And last one, the L2 union L3, that L2 is RE, L3 is RE. So RE union RE is RE. So this is also true statement. So which one you will choose? The option B. So really it takes time, but you should just go as per the definition. Yes, it's right. 77. Alu explains. Yeah, you are not discussing, just came here talking about how long, right? So far, are you sleeping, Alu? Yeah, explain, yeah. Alu explains, sir, how many questions left? I did not see even single time you are discussing in this class, yeah. How can you ask me? Ask God. God will help you. Question 78. Please discuss. It's not that we are trying to discuss as long as students are present. If you are going to everybody leaves, then I will leave. I will not teach to the blank board, right? 77, 78. Next. I'll be there as long as you are there. Which of the following problems are decidable? Can you tell me what are decidable? Which of the following problems? Does a given program ever produce an output? Does a given program ever produce an output? Look at how you should analyze. Indirectly, program, right? Program means by default Turing motion. Now I'm asking indirectly, is that Turing motion ever produces an output? So can you do that? Can you wait? If the produces output, you will understand, right? That means yes, definitely you will understand, because it will print something on the screen or something on the tape. So normally computers, what happens? They will print something on the screen. You will understand. If it is not at all producing, how long you will wait? The program might be in infinite loop, program might be in the recursion, a program never stops. You will expect that output, but it might not happen today, tomorrow, but still program is running. Then tomorrow if you conclude that you will not get an output, day after tomorrow you may get output. You don't know, right? So that's very difficult to judge, is it producing an output. S definitely will have a logic because you will understand. But no, really if program not producing an output, you don't understand, because the program might go to infinite loop like a Turing machine, never halt case. Here there is a problem, logic not exist. So anyhow, it's about only decidability, right? When you ask about the Turing machine, the problem is going to be undecidable, right? This is not going to be chosen anyhow. You don't need to analyze much, but for understanding this kind of concept, you need to analyze much, because it's not the exam, right? You are outside the exam, you are so lucky because you got the question to understand more in detail. So that's why you need to put an effort to understand this statement, how long this question can, asked in the exam. Because they change tomorrow. Does a given TM ever produce an output? Does a given TM ever produce some symbol on the output on the tape? So these questions are similar to this. So you need to analyze that. Okay. If L is context free language, then L complement also context free. Can you verify is that L complement also context free? It's not about closure property. Remember, that's different. Now the question is, I will give you PDA. I'll give you PDA that accepts something. Now its complement, do you have a PDA again? So is there any way to verify that given language is having a PDA? So that's what the problem. If it is not having a PDA, again, S means you can design a PDA, right? S means what? Suppose regular language you have taken, its complement is also regular. You can design a PDA, right? So S will have a logic. If you have a complement is a CFL, you have a logic. Suppose that complement is not having a PDA. So you will try for the PDA, but you don't know how to do that. So this one is an issue. This one is no. The logic is an issue here. Logic not exist. When you don't have a PDA, then how can I say that I don't have a PDA? If you have a PDA, you can design it. You can show that. But if you don't have a PDA, there is no proof why I don't have a PDA. But I can show that Turing machine or somebody else, but I don't know how to do that. So this one you need to analyze much. No. Just understand, you will be having a Turing machine, you will not have the PDA. But it's not having the PDA, that logic, we don't know what do you mean by not having the PDA. Okay. So this one is also, we can't come up with the answer. But you see that you have two options. The other two you need to work on. L is a regular language, then L complement is also regular. Oh, that's proof we have, because we can design a DFA, interchange final, non-final. That's an algorithm why we have the L complement is also regular. So this is decidable. This is decidable. If L is recursive, then L complement is also recursive, because HTM you design, yes you make is no, no you make it as S, then HTM you can make another HTM for L complement using the same HTM. So this is also decidable. So definitely 3 and 4 are decidable. So 2 if you are not confident, so you need to analyze more in detail, because 2, 3, 4 also there. Okay. So don't say need not be context free. It's not about the closed or not. If L is a context free, then can you verify? Do you have any algorithm? Question is like that. Do you have any algorithm that L complement also context free, right? So yes or no might happen. L complement may not be context free, may be context free, but can you provide algorithm, is it context free or not? So that algorithm needed, not this problem. L is a context free, L complement may be anything. So is that L complement also context free? Can you verify? Can you tell me? Do you have any logic for that? That problem, logic is not there for us. Algorithm is not there to understand this statement. We know theoretically L is a CFL, L complement anything, but do you have any algorithm to verify this? Okay. '79. Which of the following is undecidable? Oh, undecidable statement, so easy. Right, decidable, undecidable, these questions are there. Blindly you can answer it. What is this context free grammar language? Language generated by CFG is empty. That's emptiness. Emptiness problem. Emptiness problem for PDA. PDA, push down automata, is undecidable. So this is undecidable. And CFG, oh sorry, what I'm trying to say here, sometimes my brain will not work. Already I told, right? Emptiness means which algorithm will use? Simplification algorithm. Please use that table, because every time I need to remember this. Simplification algorithm will work. Why it is decidable? This is decidable. because we have algorithm. Simplify the grammar. If no production left, that means it is generating empty language. At least one production left. You know simplification, right? Eliminate null rules, eliminate unit rules, eliminate useless symbols. Then you will look at, is that my context-free grammar having at least one production or not? Next one, totality. This totality, what is this? See, I'm not able to hold the pen also. Totality. Totality for the push down automata. Is it decidable or undecidable? It is undecidable. So we'll choose this is the right answer. Undecidable. Totality. Totality and equivalence. Turing machine. Oh, this question is like the previous question. Is that program ever produces an output? Is that program ever produces epsilon? Is that program ever produces regular language? Is that program ever produces only A? So all these questions are similar. Like Turing machine means program. You can replicate. M is a Turing machine. Is a Turing machine accepting regular? So this question is really undecidable. Is this this is called as non-trivial question, because some Turing machines are accepting regular, some Turing machines are accepting non-regular. So this is actually proved. Rice theorem is proved this question. Trivial questions are regular, non-trivial questions. This is a non-trivial problem is undecidable every time. So this is undecidable. Okay. Fourth one, it's a non-trivial question called as DFA and NFA. You are talking about equivalence, that language accepted by DFA and language accepted by NFA are the same. So DFA you convert into minimum DFA. NFA you convert into minimum DFA. If both are isomorphic, if both look same, then definitely they are accepting same language. Why? Because every regular language in the world only one minimum DFA. If both are accepting same language, their minimum DFA must be same. So you have an algorithm to verify this. So this is decidable. So we'll choose 2 and 3 only. Okay, how many of you answered? 2 and 3. D. Everybody is able to answer, right? Yes, great. 79, 80. Let L be the language, L complement be its complement. Which one of the following is not possible? Viable, possible, not possible. Okay. So L and L complement, we are both are talking here, right? So now neither L nor L complement is REL. That means not possible. You need to verify. Is it possible first? L is not REL, L complement is not REL. Yes, possible. When the language and its complement both are not REL. So do you want that language? L is equal to, let's say I want every TM, that language of TM is finite. This is definitely what? Not REL. And L complement, when you do right, you will get again TM, and the language accepted by TM will not be finite, means not equal to finite means infinite. This is not REL. Even this complement is also not REL. See, L and L complement not REL possible. So neither L nor L complement is recursively enumerable. Means both L and L complement are not RELs. Yes, this is possible. But what we need to choose? Not possible. Okay. One of the L and L complement is RE but not recursive. One is this one and the other is not RE. So there is another possibility, like a membership problem. Suppose you do, let's take this is a L A, because I'm talking about A, right? Now I'm talking about LB. LB, let me take, I'm taking TM such that TM accepts epsilon or any W you take. TM accepts epsilon or TM accepts A or any string, fine. So this is the membership problem. And this is what? RE but not recursive. Why RE but not recursive? This language is RE but not recursive because we have a TM, we don't have HTM. Because S has a logic, no will not have a logic for the membership. But when you do the complement, right, REL complement is always what? It is a TM such that I want all the TMs who doesn't accept W. TM does not accept W. S itself will not have a logic. Why? Because S means TM not accepting W. Then how do you know if it is going to never halt? How do you identify that? Impossible, right? So this is a not REL. So this is also possible. Anyhow, L is RE but not recursive. Then its complement has to be not REL. That is the principle of RE but not recursive. So this is the actual definition of RE but not recursive also. Any language in the world is RE but not recursive, right? Then its complement is this only. So one direction I am saying. Okay, not RE complement, you can't say this, but this language complement always this one. So this is also possible. Okay, so every statement is important, guys. So both L and L complement are RE but not recursive. Both L and L complement are RE but not recursive. Impossible. Because a language, if one of the languages is RE but not recursive, other definitely goes, complement always goes to not REL. So both never be RE but not recursive. This is one of the important point. Impossible. So they are saying that not possible means impossible, you have to choose. So both and L and L complement are recursive. It's a possible because L is decidable and L complement is decidable. So this is the possible. So understand, the most of the definitions will be repeated and the same concepts you keep on speaking, and at some point of time you will correlate what is this RE but not recursive, what is not RE, what is the relationship between these two. So please understand one by one. Yeah, if anybody joined late, right, please don't forget to like the session. Question number, what is the question number here? I forgot. Question number 80. Okay, 20 questions. 81. So how much time we have now? 3:13. Okay, so let's go for last 20 questions we have. Fine. When we have started here? 7, almost coming to 4, so 3 hours, almost near to 9 hours, 7 p.m. Yeah, please think about it. Let me have some water. Okay, anyhow, these questions, you keep think about it, but I'll read the questions and I'll explain. So follow that. A is reducible to B denotes that language A is mapping reducible. Of course, it's a many to one mapping or polynomially reducible. Right? This concept is the same. Which one of the following is false? Okay, now before answering this question, A is reducible to B. What is the meaning of this? It means, in all of my classes, I used to explain like B just think like a project and A think like a module. When A is reducible to B, that means suppose if B has a solution, the project has a solution, then every module should have the solution. That means if B is decidable, A should be decidable. And if the module is undecidable, the project will not complete. The project will also undecidable, right? So the same way, if A is undecidable, B will be undecidable. If B is decidable, A is decidable. So decidable will flow from right to left, undecidable will flow from left to right. So remember these 2 points, remaining will conclude. Okay. Now look at, if B is decidable, recursive means decidable, then A is also decidable. This is a true statement. That's what I am saying. If the project is decidable, if the project is having halting program, then A will also having halting program. So some points you keep remembering, just do rehearsal like recursive. Oh, is that recursive? You did not understood? You did not understand? Just make it's a decidable. Oh, still you didn't understand this decidable? Then try to think like HTM. Oh, still you didn't understand? Try to think like algorithm. Still you didn't understand? Try to think like halting program. Still you didn't understand? Then think like L has TM and L complement has TM. Still you are failing something? Then assume like that L is REL and L complement is also REL. So if you are able to prove any one statement here, that's fine. So they are talking about recursive means decidable, means HTM exists, means algorithm exists, means halting program, means that problem L, that logic, the language L has the TM and its complement has the TM. That is the meaning. Or you can say, that's it, I think, right? L is having HTM, already explained here. So many statements are there. This all are, there's no difference. You are talking about the same sentence again and again, but in different forms. Okay, so you convert your logic into any of this. If any of them you are able to understand, that would be sufficient. That means whenever I say recursive, my brain is changing to somewhere. Like I'm thinking about sometimes halting program, I'm thinking like sometime algorithms, I'm thinking like sometimes HTM, I'm thinking like decidable sometimes. Sometimes the problem not able to understand, then I will convert that problem as a Turing machine, that problem its complement also as a Turing machine. That means that problem itself is HTM having. Okay. So that is how I analyze the concepts here. Now the same way, If B is recursive means I'm thinking like, oh, B is a halting program. If B is the halting program, then the whole project is having halting program. Definitely every module should have halting program. That's why it is a true statement. Everybody got this point? So our analyze, right? Yeah. Module and project. The another one. A is undecidable. The module is undecidable. Then project is also undecidable. That is a true. That is a fact, right? If A is not having halting program, module is not having a halting program, how a project can have halting program? Because project depends on that, right? Okay, next one. This is also true. This B is REL, means I have a Turing machine for the project. Then A is recursively enumerable. So now whole project, the project is having a program, don't worry about halting program. If B is having a program, then can you guarantee the module is also having a program? Yes, because a B is a project has a program, means the module will also have a program. So this is also true. Now another one. B is not REL, then can you say A is not REL? Like the project, you don't have the Turing machine. But module may have, right? Because when I'm saying the module, this project may not depend on only A. It might depend on other projects. That's other modules. That's an issue. B is the project. Don't assume that only A is there within the project. You might have other components. You don't aware of that. When B is not having a program, but A might have a program, you don't know that. So this is the one of the important one. So that's why this is a false statement. B is not REL, then you cannot conclude A is also not REL. You cannot. But another way, if A is not REL, if A you don't have the Turing machine, definitely the project will never have a Turing machine. So this is a very easy statement. But when B is not having a Turing machine, don't say A is also not having Turing machine. Why? Because B and A are not same. B depends on A as well as some other modules. Because of the whole project is not having a program, but module may have, this might have a program, this too may or may not have a program, you don't know, right? So that's why option D is the false statement. So initially may take time to interpret these words, but if you keep on practicing, this reducibility concept goes very easy. I think the chart is very slow here. Should I stop here? Remaining 20 questions should I give as homework? Okay, before going to the 82. This is 82, right? Do you want to take it as homework and solve the remaining 18 questions? Or do you want me to solve? Quick guys, because I see less response and most of the people are going to the sleep, because even I have to go. Come on, quick. If you are there, then I will be there. C is the right answer. No mini session yaar, Shivam. Either now or never. Today compiler class is there, right? In the evening I need to come again at 7 for the compiler class. Okay. So now understand, I basically don't use the words theorems and all these things, right? So understanding is only the best solution rather than any of these theorems. Now sigma is always finite non-empty alphabet. That's the definition of sigma. Always 2 power sigma star is nothing but the set of languages, right? What is the meaning of that? Power set of sigma star. So sigma is nothing but set of symbols. It's always a finite language. It is always what? Finite language. And sigma star, it is set of all strings. Set of all strings. It is in fact regular. It is in fact what? Regular language. Regular. You have a finite automata for this. And 2 power sigma star, this is nothing but set of all sets. Set of all languages or set of all sets. Okay, now the question is about what? Countability. That's it, countability. Okay. Now, what is the relationship between the countability and the enumerable languages? So here countable, no need to be having the Turing machine. The countable word came from the mathematics. So if something is countable, it may have the Turing machine or it may not. Remember that point too. So now, which are countable here? That is the question, right? The countable definition is somewhat different from the TOC. In mathematics, countable, if any set is countable, you have to prove that some other countable set has a bijective mapping with this unknown set. So if I am saying, let's say x is countable, then you have to prove me this x is having bijective mapping with another set y, that y is known as the countable. Like example, if I want to prove that set of integers is countable, what I do is set of natural numbers I will take. Then I will prove that I have the bijective mapping with the natural set. That's why I am countable, because I am here set of integers. This is how you prove countability. Anyhow, let's look at an easy way. Which of the one of the following is true? Sigma star is countable because sigma star is, it is a regular language. Every regular is countable. Okay, every CFL, every DCFL, every CSL, every recursively enumerable, when some of the not RELs are also countable. So sigma star is countable. How you count it? Epsilon, A, B, like you can generate the strings in lexicographical order. You can map with the natural set. That means I have the bijective mapping with the natural set. But 2 power sigma star, the issue with the 2 power sigma star is the set of languages. Set of languages means this is a set in which you have the languages, like an empty set. You have the language which has only epsilon, the language which has only A. Let's take sigma is A comma B. Okay, B, and I have only one length strings. I have infinite. Then I don't know, if I go this side, then I may miss the 2 length strings. Sorry, 2 strings set. I have the set with 2 strings, like I have epsilon comma B. If I am going for this languages, then I may have the language with 3 strings. I may miss them. So this languages, I don't know how to count it. This because the one language which has every language, then this is uncountable. So here 2 power sigma star is uncountable. So 2 power sigma star is uncountable, and sigma star is countable. So we will choose the true statement, option C. Good. That enumeration is not the TOC enumeration, right? So Himanshu, the countable is somewhat different problem than enumerable. Both are not same. So if anybody want the relation between countable and enumerable, so like this one are decidables, means I have the alternating Turing motion for this sets for languages, and these are the enumerable languages, RELs, enumerable. The countable is this one. There is still some of the not RELs. These are the countable sets, and countable sets no need to be RELs. So from here to here, these are all are not RELs. Even uncountable also can come under, these are all languages in the world. You can say all sets and comes under like this. Okay, so keep this relation with you, and from here to here, they're all not RELs, but some not RELs are countable, some not RELs are uncountable. Okay, so use this relationship for easiness. 82, come on, 83. Which of the following problems is undecidable? Okay, ambiguous, right? Checking whether the given grammar is ambiguous, undecidable only you have to verify, right? Not more than this. If it is more than this, then you will be in trouble, because undecidable, which is in REL or outside REL, it's going to be complicated for you right now. Deciding if a given CFG is ambiguous, definitely this is undecidable problem. Okay, this is undecidable problem, but it is partially decidable, because whenever the context free grammar is ambiguous, you will be having some string, at least one parse tree. So S will have a logic, no will not have a logic. That's why it's undecidable but partially decidable. Remember that it is still having the Turing motion, but you don't have alternate Turing motion for this. Okay, deciding if a given string is generated by given context free grammar, means it's a membership for context free languages, it's a membership for PDA, for CFG, for CFL. So this is the decidable. You want undecidable, right? Undecidable, you have already chosen one, and this is decidable. In fact, you have algorithm for this. What algorithm? CYK algorithm. That's why it is decidable. Language generated by given context free grammar is empty. Emptiness, just now, right? Third time is came in the exam. Look at that. Third time. Emptiness for push down automata, emptiness for CFLs. Third time. Deciding the language generated by the given context free grammar is finite. Is that finite or not? Language, right? Finiteness. That you require dependency graph for the given context free grammar. So you need to have a dependency graph algorithm to verify the grammar is generating finite language or not. It's still decidable because you have an algorithm. Okay. So only you will choose option A. That's correct. So here for this you have a proof, right? If you want to learn, just learn these proofs. For this, simplification. For this you need a dependency graph. You need to construct that graph and check do you have any loops or not. If you have a loop, it is generating infinite. If you don't have a loop, that is generating finite. Okay. So dependency graph you design and then check for the loops. 84. For any two languages L1 and L2 such that L1 is the context free and L2 is RE but not recursive. This is one name, remember that. Don't break it. RE but not recursive. Which of the following is true? Okay. Which of the following is compulsory true? This is true definitely. Which one? Okay, first one. L1 is context free. Then L1 complement is a recursive or not? Recursive means decidable. Decidable means what? The L1 complement, we know it is a CFL. CFL complement is what? CSL. CSL is what? Recursive. Recursive, another name is what? Decidable. So they may ask even in future L1 complement is decidable. Yes, it is correct. It is true. You need to say it's true. L2 complement. What is L2? RE but not recursive, right? L2 complement is RE but not recursive. Complement is not RE. Not RE. Right? So this statement is false. L1 complement. Can you say context free? No. This statement is also false. Because it's a CSL. The context free language complement is what? CSL. L1 complement, that is a CSL union RE but not recursive. So this is also RE, this is also RE. So definitely union of two RELs is RE. So this is a true statement. How did I conclude? The L1 complement, CFL complement, assume RE. L2 is RE but not recursive. That is also RE. RE union RE is RE. So when you have the complication, so just look at this is answer is about RE. So for RE union is closed. Just look at is this RE or RE. So both are RE, then answer is RE. Okay, very simple. So 1 and 4. 1 and 4. Have you answered that? D. So most of you are answered, right? Nice. 84. 85. Can you answer this question? Consider the following statements. The complement. 85. 15 more questions here. The complement of every Turing decidable means what? The another name of Turing decidable means just decidable. Recursive. Decidable language, another name only Turing decidable. The complement of recursive is a recursive. Yes. True. We need to choose true only, right? So this is the true. And 2. There exists some language which is in NP but not, what is, it's not related, right? NP. So we'll just talk about that. There exists some language which is in NP but it is not a Turing decidable. So this question, actually it is removed from the syllabus. It is not there in the syllabus, right? Right now P and NP is not there. So you can ignore this point, but I'll just relate it. What is the relationship between P and NP as well as what? The recursive and all these things. Let's just keep that point. Okay, let's take that. So we know what context free languages, right? CFLs. From here we'll take inside regulars are there. So now context sensitive language I can't relate, but the P problems, the problems which are solvable in polynomial time, so definitely they are going to be here. So all the context free languages, they take polynomial time. So there is NP class, they are actually called as NP problems. NP problems. Of course, they are also solvable in polynomial time but using non-deterministic Turing machine. Don't worry about it. These are the problems which takes polynomial time with deterministic Turing machine, and including P problems. These problems, now all these problems takes polynomial time with NTM. So non-deterministic polynomial algorithms are problems. So now if you want to know decidable, right, so these are the decidable problems or decidable languages, recursive languages. And where is REL? So there is above, you know already the class, right? Then where is the CSL? CSL, you know, they have, you know, slight relationship, different relationship with the NP. So some problems are there in CSL, some are not there in CSL, so that's why we are not keeping here. So now the question is like they are relating NP with the REL and decidable, P with the decidable and REL. So understand, every NP is decidable, every NP is REL, and every P is in NP, every P is in decidable, every P is in REL. So keep this relationship with you, so it might help you, but it is not there in the syllabus. There is no exponential word, polynomial and non-polynomial, remember that. So don't use the exponential word here. So it's non-deterministic polynomial problems. Okay, the problems can be solved using the non-deterministic polynomial time. Okay, there exists some language which is in NP class, but it is not in Turing decidable. If it is in NP, right, it is always in Turing decidable. So they are saying that not. Oh, this statement is wrong. Every problem which is in NP definitely will be there in decidable. That's why this class I have given. So now anyhow it's not there in the syllabus, right? Don't worry. If the problem is here, right, anywhere, these problems are, if they're in NP, means definitely they're in decidable. So that's what the problem, the statement is contradicting, right? So you can't choose it. It's a false statement. There is no language which is in NP which is outside the decidable, right? If L is the language in NP, then L is Turing decidable, obviously, right? If L is in NP, L is always decidable. This is a true statement. Okay, so don't worry about this question. It's out of syllabus question, you can assume right now, because this syllabus is not there, P and NP, so we don't study right now. But in case if you want to know the relation, then keep that. So true statements 193. Okay, so keep that relation if you really want it, but not required. 85 is over, right? Yeah. NP includes both exponential and polynomial time. Okay, that's your choice. How do you analyze? 86. Oh, question is, X is the recursive language and Y is RE but not recursive, and W and Z be two languages such that, so keep that point. Y bar reduces to W and Z reduces to X bar. Z reduces to X bar. So these are the two different statements, and then which of the following statement is true, you need to find out. Now let's relate it. What is X bar? X is a recursive, so X bar is what? Recursive again. So Z is reducible to recursive. The first statement, right? Another one, what is Y? Y is RE but not recursive. So its complement is what? Not RE. So not RE is reducible to W. So I told you, right, if the one of the module is not having the program, then whole project is gone, will not have the program, because module decided this answer. And this is now we look at what is W. W is definitely what? Not RE. Let me write that answer. W is what? Now with this I can conclude it is not RE. Now with this, whole project is having alting program, then Z module is also going to have alting program. We can call it as a recursive. Now see, W should be not RE, Z should be recursive. Now let's look at W can be REL and Z is recursive. It's never be, right? W should not be REL and then Z should be recursive. This is the right answer. But do you have any other answers? Let's just check it. Z is not recursive, we don't choose it. If Z is REL is fine, but W can be recursive is wrong. Z is recursive is fine, but you can't say W is recursive enumerable. So C is only the right option. In future, which of the following statement is false? Then you should choose A, B, D are false. Good morning, Sweta. Just woke up. We are just going to sleep after this class. Okay. 87. Which of the following decision problems are undecidable? How many times are undecidable? Let's look at this. Intersection equal to empty. Intersection means is a disjoint problem. You can say disjoint. Disjoint problem for finite data is decidable, but we want undecidable, right? So this is the decidable. And given CFG, you are talking about membership again. Membership problem is decidable for CFLs. Given CFG's equivalence problem, this problem is undecidable. Equivalence for the context-free languages, undecidable. And emptiness for Turing machine is undecidable, right? You choose 3 and 4, that will be the right answer. Okay, it will not take much time here. See, Only you should know what problem it is. You should know what problem it is, that's it. They are just giving the definition of the problem. You need to understand, is it membership, is it equivalence, is it finiteness, right? Which domain it is it a context free languages or regulars or what? 87 is over. 88. I'll wait for the answers. If you have any answer, please let me know quickly. We have done some similar questions already, right? So this is the membership problem. So you can answer here. You need to choose a true, right? This is the membership problem for Turing machine. M is not given means by default you take M is Turing machine. If it is given, you are so lucky. Not given Turing machine, you assume always. Okay, membership. And L1 and L2 you need to analyze it. Okay, here you might take much time. Let's see, we will answer it. The answer C. L1 and L2 both are recursive and L3 is not recursive. So this is anyhow it is undecidable, right? Undecidable means it is not recursive. So UD language means it's not recursive. So L3 is not recursive. How many are saying? The option A and option B and option C. If this option D you can eliminate directly, but A, B, C are saying about all are correct about L3, but L1, L2 you need to understand. So let's look at it. If I give you Turing machine, if I give you, you don't design Turing machine now, I'll give you Turing machine. Can you verify which is it taking at least 2016 steps on some input, right? At least 2016 steps on some input. Takes means it will not halt within 2016 steps. That is the meaning. It takes at least 2016 steps on some input. Suppose if it takes, then definitely it halts somewhere within 2016, right? So you will keep on verifying it, right, up to 2016 length only. Why? Because every 2017 length onwards they will follow 2016 length prefixes only. So up to 2016 length string, not every string in the world, remember that, up to length this much only. You will verify every string. If every string halting within the 2016, within the means less than 2016 steps, that means that machine will not keep here. If any string takes 2016 steps, then that machine comes here. So the machine, will it come to L1 or L1 complement? You are able to decide how. If that, how many strings will verify? Length of W should be less than or equal to 2016. All the strings, every string, how many strings are there? Only finite number of strings. So every string, will it take a never halt case? Never, because we'll verify up to 2016 step. Suppose epsilon you are asking, if suppose it takes 2016 steps, that means you got the answer. You don't go for next string, 1 length, 2 length, you don't go, because you already got a string which is taking 2016 moves. So this, how many strings are there here up to 2016 length? That you need to look at, right? 0 length 1, 1 length 2, 2 length 4, 3 length 8, and so on, right? To power 2016 for 2016 length string. So all the strings are finite number of strings. Every string you will verify. If any one string is taken 2016, you will stop algorithm. If everybody halts within that, still you will stop. So yes and no, both you are able to provide a logic. What logic? S means, look at, understand, S means the sum string, that sums input, it's going to take the 2016 steps. So sum string, but that sum string also just you can verify up to here. No need to go for, you know, every string, just to verify up to 2016. 2017 length also no need to verify. No means every string up to 2016 length is halting before 2016 move only. So within 2015 up to 2015 moves only, you are able to see everybody is halting. So no, you are having finite time to halt your algorithm, and S also you have the finite time to halt algorithm, and also you will always verify up to 2016 length, because 2017 length, 18 length, 19 length strings and so on, they will follow 2016 length prefix. So no need to worry about it. So this is the decidable. You have algo, so it is recursive. It is recursive. And now what is L2 problem? So look at what I have explained. The next one, M takes at least 2016 steps, at least 2016 steps on all input. What is the meaning of it? That means every string is going to take the 2016th step. That means same, check up to here. if no string halts within less than 2016, that means everybody will take only, right? Doesn't matter halt or not, never, we don't care. But if every string of this one, S means what and no means what, let me check. S means what, no means what. Understand and watch the video if you want to understand again. M takes at least 2016 steps on all inputs means just verify this. No need to verify every string in the world sigma star, right? Just these strings, if every string in this, right, 0 length, 1 length, 2 length, up to 2016 length, every string is taking 2016 step. Epsilon you are asking, it is going to 2016 minimum. 2017, 18, no need to verify. It is taking 2016, stop. Then ask A 1 length, ask B 1 length, it is also taking 2016 step. The 2 length, 3 length, 4 length, up to 2016 length, everybody is taking, then S. That means every string you will come up to 2016 step, then stop. Every string. If every string is coming to 2016 step, that means that machine will be here. In case any string it is halting within the 2015 or up to 2015 verify, then what happens? This machine will not be an L2 complement. That means no logic, right? That case also you will halt. You will halt in very quick compared to the first one. This one should verify every string up to 2016 length. This one should verify only when if it is coming as, you know, at 2016. If anybody takes, then stop it. No need to go for everyone. So this one is also turns as a recursive because yes and no will have a logic. That means valid and invalid. I'm explaining for the problem yes and no, but valid and invalid strings both will have a logic. L3, this is a membership problem. It is already undecidable. So L1 and L2 are recursive and L3 is not recursive. So we'll go for the option C. How many answered it? L1, L2 both are recursive. This is most of the gate questions which are similar to this L1, L2. Okay, so understand this problem. For both the same logic, you need to verify. We need to verify only. We need to understand up to this only. In both the problems, same concept. We need to understand the length of the string up to 2016 only. There you will get the logic for both the problems. Okay. Understand the problem. M takes at least 2016 step on every input means just at least 2016. How do you understand? Just verify this strings enough. No need to verify on all. If we verify up to 2016 length, it means indirectly we verified all inputs in the world. It means indirectly same as indirectly all inputs. Why? 2017 length string will take the 2016 length as a prefix. That 2016 length already taken 2016 step, 2017 length string should take. And let's say 3000 length string. In that 3000 length string, this 2016 length string is already came as a prefix. Let's say this string is 3000 length. 3000 length, and here to here let's say 2016 length. This string already verified, it is taking 2016 steps, then this string definitely will take, right? There is no doubt about it. That means no need to verify on all inputs. Indirectly you are saying that you just need to verify up to 2016 length strings. That is the logic you need to understand. So that takes time basically, right? So that's why this question is very important for us, for exam point of view at least. Just keep on repeating this similar kind of pattern. Okay, only this one. If we verify up to 2016 length, it indirectly means all inputs verified. All inputs verified. Without verifying all inputs, we have that logic because 2017, 18, 19, 3000, 4000, 5000, everybody is having the prefix of 2016. This will stop at 2016 length strings only. Okay. Question number 88, 89. Okay, another interesting question. Yes, 2021 also asked, right? Okay, can you try this question? I don't know how many of you got the right answer. Let's see who will answer it. 13 people. 89. Okay, just take 2 minutes time. I'll just have water. We have not taken the break after 80 questions, right? No answer yet. Come on, guys. And those people who joined just now, please don't forget to like the session also. That's what I'm thinking, how you are answering these questions. Some people are saying B. Okay, let's see how you analyze it. I want you to understand every sentence that is given to you, then you will come up with the right answer. Which of the following is true? Well, 2 people are trying, right? What about others? Just guess something. What could be the right answer? Then listen explanation what is going to happen. Okay, it's a 2017 question. Yeah, I'll explain a little bit. Anybody else? It's given halts on for members it will halt, but for not members it may hang. So I thought let's explain, right? So I think you are taking time, right? So please let's look at the question. A and B, obviously finite alphabets, no need to worry, like sigma 1, sigma 2. So 2 sigmas are given to you, and hash be the symbol outside the sigmas, that's fine, but that is also input symbol. They can kept inside the A, inside the B, but they are mentioning that the hash is another symbol, that's fine. Let f be the total function from A star to B star. So this is a function, right? So whenever you are talking about total function, right, total function definition is every symbol in every member or every element in the A star will have the mapping in B star. So that makes you that every string, valid string or invalid string, because A star, like sigma is there, sigma star is a language, right? So every string you will have a logic whether it is valid or invalid, because you will definitely have a mapping to B star. Total function definition is every element in the domain will have the mapping in codomain. That means every element is well defined map. You have the mapping for every element in the A star. That means whether the string is valid or invalid, you will have the logic to stop. Okay, that is indirect meaning of total function. Anyway, we say that f is computable, that function is computable if there exists a Turing machine M which given that input x in A star, that input x in A star always halts with f of x. So now he is talking about f is recursive, that is computable if there exists a TM. That is giving definition, yeah, don't worry about it. What is the total function? He has given definition, you are so lucky, right? Let LF denote the language. Now they are forming LF. Don't worry anything here, just they mentioned it. So this is A star like a sigma star, this is the B star like another sigma star. A and B are alphabets, A star, B stars are, you know, some languages, universal languages. So here there are elements x1, x2, x3 and so on. Every x1 there is a mapping to string in B star. So this is already, this is when you say total function, right? This is the meaning that every x1, x2, x3 you have a logic. That's why you are able to halt, always halts, right? So what do you get here? F of x1. What do you get here? F of x2. They may be same or different, I don't care, right? But you will have the mapping that f of x is there in B star. That is the meaning. And it's able to halt because it is already recursive. Okay, you have HTM for that. That is the meaning. To do this, you have an HTM. To compute this f from here to here, you have HTM. Okay. Now, what is LF? That we need to analyze. LF is a language. You have this x belongs to A star, right? So if you have x1, then f of x1 you need to have a string. x1 hash f of x, this is a string. String belongs to LF. Similarly, x2 hash f of x2, this is also a string, belongs to LF. LF strings they are. And similarly, you are going to write the strings. Now the question is, what is L of LF? Already F is mentioned as computable, right? Everywhere you see F is computable, no problem. F is having HTM, that is the meaning. F is having HTM. If F is really giving you HTM or F is a computable, then LF, is it recursive? Is it having HTM? That is the meaning. Can you show the algorithm that LF is going to halt all the time by generating the strings or by accepting the strings? Okay, now look at F is known as the computable, right? F is known as computable. Now if I have the F, can I generate this LF? Now I'm showing that x1 is you can get from this one, right? Because you can ask the Turing machine. We can say that F is computable. TM exists where if you give x in A star, it will give you f of x. So you ask the TM always. X1 asks the same TM, it will give you f of x1. Then take both of them, put hash. And another one, x2 asks the TM, and you will always halt by giving f of x2 and put hash and concatenate. So similarly, ask everyone, because this is the A star, it is a countable, right? You can enumerate in a sequence x1, x2, x3 and keep on doing this. So you are able to collect the strings in lexicographical order. So this LF will be recursive when F is computable. F is what? The computable, then LF is recursive. So this direction I told you just now, if F is computable, LF is recursive. When LF is recursive, can you show that F is computable? That is also very important. If LF is recursive, then this language is there with you. And also algorithm is there, also HTM is there for this language. When you have this language, what you do, x1 you take, put here, f of x1 you take, put here and just map it, and x2 you take and put here, f of x2 you take and put here and map it. So every string will give you the computable function, because this one is actually giving the elements of this one and giving a relation between these two. So when LF is recursive, F is also computable. So this direction is also going to hold. This direction is also going to hold. That's why this option A is correct, no doubt. But that doesn't mean that remaining options are wrong. Also got right. So you need to cross check, because even though it is the 2017 question, there is a possibility that the gate committee might make the mistakes. We will just look at it. F is computable if and only if LF is REL. So now what I am saying is, suppose F is computable, we can say LF is recursive, so REL. But this is not, we don't know recursive or not. Suppose this is REL. If this is REL, there is no guarantee that is it covered every x1 here, because some x1s might miss if it is REL. So this direction is true. F is computable, definitely LF is recursive, so REL. But this direction will fail, because this direction will fail. Because if LF is recursively enumerable, no guarantee every xi is covered in this language. That is not guaranteed. And no need to be this lexicographical enumerable. So you don't understand, is that all elements in A star are covered here or not? Because we are thinking reverse direction. Assume that F is unknown. And no, you know only LF is, this is only recursively enumerable. Then here you have a confusion. Oh, is that every xi is covered from here or not? We don't know. If it is recursive, right, definitely every x might be covered here, and you will have the computation to halt. That is one more interesting question here. Okay, if LF is recursively enumerable, then you don't understand these strings at all, right? So let me see your comments, what you are talking about. Okay, you got the point, right? So see, if F is computable, LF is recursive, that we know, but not conversely. Oh, it's already conversely, right? So both are failed. And last one, if F is computable, then LF is recursively enumerable, but not conversely. This is what the statement we are saying, right? D is the right statement. I don't know why did they make like this. This is the actually right statement. That's why we did not choose option B. Right? If F is computable, you only said LF is recursive. When LF is recursive, LF is REL. The option A, when you are talking about this direction, this statement is already true. Right? And but not conversely means LF is REL, then F is need not be computable. That's what already we have proved, right? That's why option B we did not choose. So A and D, this was the gate question, and In fact, nobody was challenged, so A only assumed by everyone. So D is also right answer here. So understand why D is also right answer. But most of the solutions that you see in many platforms, they say only A is the right, D they don't care because they don't understand the first options at all. Okay, done. 89, right? Just revise the video if you really wanted to understand more in detail. 90. Set of all recursively enumerable languages. That means you are talking about the closure properties. Is there any operation closed for this RELs? Complementation, is it closed for RELs? No, we want closed, right? This is not closed. Closed under intersection, yes. Subset of, well, this is a different statement. Set of all RELs, subset of recursive. Set of RELs, is it really subset of set of recursive? No, right? Reverse, it is a superset actually. So it's not subset, but it is superset. This is the right option. So it's a subset, that's why we don't choose it. Oh, uncountable sets, wrong. Set of all RELs, actually when you take all RELs, right, it's a countable set. So it's, they are saying uncountable set. We go to only option B. Very simple one. So will you try the last 10 questions? Because I think you may try. Can you try these questions here? Okay, so I'm just giving this last 10 questions at least. Almost it's a 4, right? Can we stop with this 90 questions? I believe this 91. Please post your answer in the comment. I just don't want to choose anybody answer in the world, because the most of the ABCD options, sometimes you have seen, right? If you don't believe me, right, this question you go and search, not this one, before one. Here everybody answers A only. They don't know why D is right or wrong. So don't believe the answers of somebody else. You just analyze the questions. I want your answers below this video in comment section. 91, just answer based on your understanding. So keep having a discussion, right? So can you do this as homework? Of course, if you want, I can discuss right now. So at least these 10 questions keep in the discussion. So in case if you're not able to do, you can ask me in the revision section. I will do it. Okay, 91. And 92, it's also similar to the question which we did earlier, but something different. Set of valid C programs, syntactically valid C programs, is nothing but set of all context-free languages. That is the meaning of syntactically valid C programs. Remember, this is indirectly similar to set of all context-free languages, but it is a C related. Set of all C context-free languages based on C syntax. Okay, it is similar to that, because sigma is depends on C character set. Set of all RELs, just now we have seen, and are uncountable. They are asking first two are countable. Set of all languages means 2 power sigma star. This is uncountable. Set of all non-regulars. Set of all non-regulars is also uncountable. So this is also uncountable. So here just choose S3 and S4 is uncountable. S1 and S2 are countable. So similarly, please try these questions, right? Keep answering. I'm just helping how you analyze it. 92. So can you do that? Great. So let me take it as the questions. You can do it, right? You can see, we have already seen L of M is regular. Now it is, they are talking about not recursive is recursive. They're all non-trivial questions. Non-trivial questions you just do similarly. So at least 2 strings, at least 2014 strings, or at least 2014 length strings, or at least 21 members. The size of the language is greater than or equal to 21. This problem is language of M is having at least 21 members, means greater than or equal to 21. Okay, so this is 21 strings are accepted by the machine indirectly. At least 21 strings we have already seen, right? At least 2014 length strings length we have spoken. Now at least 21 strings are accepted. Okay, similar problem, and you just think about this problem also. This one is 93. Okay, please analyze this question. In case any question you face, please try to discuss with the comments. I will help you. Okay, 94. I think similar to that, right? This one only you are talking about. These similar questions are already we have seen. Okay, 94. We have discussed that. 95. Any difficulty here? Regular languages, infinite regular language contains undesirable. So just it's a subset relation problem. Okay, every finite language is regular. Just only you need to understand S1. Okay, So at least do homework for this questions. 96. Which of the following is true? Again, subset property is there, and complement property here, and complement intersection. Yeah, this one you can also do it. No difficulty, I guess. 97. Which of the following is undecidable? Yeah, undecidable questions are easy most of the time. This is about equivalence for Turing machine. This is about the language accepted by Turing machine is regular non-trivial question. Say undecidable. And if M accepts all strings, that's called as totality problem for Turing machine, undecidable. And M takes more than 10,000 steps. It's, most of the problems are undecidable. Just look at and answer it. That's it. 98 question gone. Okay, the 2 questions might be skipped somewhere. Okay, all right. So with this we have completed today's session, right? Okay, still we can discuss more questions, but not this time. Yeah, so we did most of the things needed for the revision. So anything that you are still lacking, you come to the Maha Marathon and ask the doubts, right? You have the marathon revision session, right? For the whole syllabus. There you come up with the questions and ask the theoretical questions. I'll come up with the explanation in the same class. Any other discussion that you want before leaving, because today we'll meet again. Yeah, thank you Mahapatra, thank you Lord Shivam. Yeah, thank you Pallavi. Yeah, thanks all. Anything else before leaving? If you are really interested to ask any doubt, please you can go ahead. So I'll wait for the few minutes, as we have spent many hours, right? So at least 5 minutes I'll spend for you if you have anything to discuss other than the subject. Yeah, Himanshu, TCFL, and good question. So you people, you may ask some questions, right? DCFL, it's a one language, right? So now I'll just tell you, DCFL also called as LRK, any K that you take K at least one, LRK language. I'm not talking about grammar. LRK language, when we say, if you have LRK language where K greater than or equal 1, it means you have LRK grammar. Suppose I say LR1, you can say another way, DCFL also called as LR1, because any LR2 language is also LR1 language. There is no difference. Why there is no difference? The reason is LR1 and LR2 languages are actually having LR1 as well as LR2. So LR2 language also will have LR1 grammar, but you need to write appropriately. So if you look at this relation, right, so DCFL is called as LR1 language. You can also call LRK, because every LR2 you can convert to LR1. Every LR1 you can call it as LR2. So that is the reason that DCFL also called as LR1 language. Now if you want to call set of all DCFLs, it is same as set of all LR1 languages. How do you know LR1 languages? Because every LR1 language you have LR1 grammar. So it's same as set of all LR2 languages. Why LR2 languages? Because LR1, LR2, there is no difference. All are same. So you can simply say set of all LRK, because 1, 2, 3, this all are no difference, right? So you can say K, and K is greater than or equal 1, still same, because 1, 2, there is no difference. All the LR1 languages you collect, all the LR2 languages you collect, you will get the same set. That's why this LR1, set of LR1 languages, set of LR2 languages, there is no difference. So they are actually set of all DCFLs. So every DCFL you can call LR1, every DCFL you can call LR2, and every LR1 language, not a grammar. LR1 grammar, LR2 grammar may be different, but LR1 language and LR2 language always equivalent. Right? So this is one of the important point about the languages. When it comes to grammar, LR1 grammar, LR2 grammar may be different, but the LR2 grammar, what it does only LR1 language, because you can write LR1 grammar equivalently. So this is the one of the relation you have. Got this is a very important relation. That's why DCFL, you can write always LR1 grammar, LR2 grammar, LRK grammar. You decide which one you want to write. Okay, any other relation that you want? Okay, LR1 language, nothing but that language generated by some LR1 grammar. Any other apart from this subject or any other? Yeah, I am only asking, do you have anything to discuss with me? Great. Still you don't want to go sleep? You want more questions to discuss today? 2 more minutes. We'll wind up the session after that. Good night, good night, good morning. Yeah, good night. Okay, for us, good night. All right, good, Priyanka. So you remember the triangle formula? Good. So let me explain that triangle if anybody is missing that short video, right? So the triangle formula is something, you know, that I told. The triangle formula is, just assume, so you start here, right? So this is the topic, wise revision. And what you do this topic revision, it means you do all the concepts. Then here you do, so you will go this direction. This is the first, and let's go to the second. Second, what you do here is the same topic wise, but not revision. Topic wise practice, but not from, you know, any other resources. Topic wise practice using gate PYQs. Then that makes, you know, some sense. You will understand the difficulty of that concept. Then once you do this for every topic, this is, you know, kind of a loop is there here. So try to complete as many as possibilities here. Like if you have 4 topics in the subject, then try to complete the 4 topics. But if you have the topic wise test in the test series, do it now. So it's decided by based on the topics. If you have the topic wise test available, so attempt test series. So attempt the test in test series. But which test? It might be the topic wise test. If it is topic wise, then go to the second topic and do it. If you do for the subject, then you after the topic wise, then go for the subject wise. Once you complete all topics, then once you complete all the, you know, concepts of the subjects, and then go for the mock test. So this make it revision, right? Do systematically. Don't go that whole subject I want to revise, then whole subject I want to practice. This may, you know, miss. It will take time, and you will forget some concepts. That is the reason this topic wise revision and practice, and attempting the test immediately to test your knowledge. If the topic wise test is not available, then this do for the subject, then do the subject attempt. Okay, yeah. Then you will get to know how strong you are in that topic, then how strong you are in the subject. Then you can conclude, you know, what topics you are in weak and strong, and you can correct yourself. Okay, this is, I called it as a triangle formula in the chart. Yeah, any others? Yeah, thank you for revising. Not tomorrow. Today I think there is a compiler class, right? Today or tomorrow. So we'll meet anyhow. See you then. Bye. Take care. If you have any doubts, please put, you know, in case if I answer any question wrong, right, please discuss in the comment. We'll cross check once. Okay, see you then. Bye. Take care. Good night.